this is going to be the ultimate software security beginner's guide, where we understand how security integrates into the development process of an application and learn how to mitigate common vulnerabilities in applications. This is a part of TryHackMe's pathway for security engineer. And so as a part of this video, we're going to go into the OWASP top 10 room. Then we're going to do OWASP API security part 1, OWASP API security part 2. Then we're going to go into the secure software development life cycle. And then we're going to go into the SAST, which is for static application security testing. Then dynamic application security testing, which is DAST. Then we're going to learn weaponizing vulnerabilities, introduction to DevSecOps, and then there's a couple of tasks for essentially challenges. One of them is called Mother's Secret, and the other one is Traverse. And both of these are challenges where we get to use a lot of the stuff that we learned in this module, as well as a lot of stuff that honestly they didn't even cover in this module. So I had to pull knowledge that I had gained from various courses inside of TryHackMe to be able to pull off these two challenges right here. So all of this is going to be covered inside of the video that you see in front of you today. And without further ado, let us jump into the first part, which is OWASP top 10. All right, how can you hack into a website? What is the OWASP top 10 list, and what exactly does it teach us to do? For example, these different vulnerabilities that exist, and can you actually use these vulnerabilities that are on the OWASP top 10 list to hack into websites? That's literally the content of the video that we're going to be talking about today, and it's actually a really fun one because the internet is full of websites, and if you have beef with somebody, you can go ahead and hack them. So that is the entire purpose of the video today. It's your boy Hank Hackerson at Hank Hacks Hackers, and if you want to find more videos like this, feel free to rummage around the website or the channel that we got over here. And if you want to get more videos like this in the future, make sure you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. Now, without further ado, let's jump into the hacking of the website's room here. Let's get some fun going. All right, in this video, we're going to go through the top 10 specific security vulnerabilities for web applications. That's what OWASP stands for. It's the Open Web Application Security Program, I think, is what the full acronym stands for. And we're going to be going through each one of these individually, and then we're going to get some details on it and maybe even some exercises to show us, how all these things actually apply and what you can do to exploit these specific security vulnerabilities. So let's jump into it. The first one is broken access control, and what that basically means is that the pages or parts of your web application that should be accessed only by admins, for example, shouldn't be accessed by any other users. They shouldn't be accessed by the public. These specific pages, if they have access to the public or other users, that means that the access control for that page is broken. And this is the top vulnerability in the last OWASP top 10 list that was dropped out. It was in 2021. This was the top vulnerability, meaning most applications, most websites, and all these different things had web pages that were available to non-privileged users that should not have been available. So simply put, broken access control allows attackers to bypass authorization, allowing them to view sensitive data or perform tasks that they're not supposed to because those pages were not blocked off or they were not secure. So that is the main vulnerability that has happened. And there's an example here that was in 2019. There was a vulnerability that was found, and this is it. If you wanted to go check it out, you can Google this, stealing your private YouTube videos one frame at a time. You can go and check this out, and literally you could just search for that, stealing your private videos one frame at a time. But the attacker could get a single frame from a YouTube video marked as private, and then the vulnerability that he could ask for several frames and somewhat reconstruct the video. And since the expectation from a user when making videos private would be that nobody has access to it, this was indeed accepted as a broken access control vulnerability. And this is on YouTube of all places. So you got to understand that Google backs YouTube. It's a gigantic business, and it's relatively recent. It was just 5 years ago. 2019 was 5 years ago. Holy cow. But it was just 5 years ago that this thing happened. So it could happen to anybody, even the biggest name in the game. And if that's the case, that means that you're also vulnerable to it too. So let's actually look at an EDOR challenge, which is the Insecure Object Reference challenge. So let's go check that out and see what we can exploit here. An insecure direct object reference is essentially something that is available on a site that you can access. So for example, in this case, it's the ID here that we see. And you shouldn't be able to, number one, you shouldn't be able to see it. So this link is a bad link. But then the second part that's like really crazy is that you shouldn't be able to edit this. So in this example, the person that, you know, landed on their account is Jay Clark and their ID is 111111. And then they changed their ID to 222222 and they got access to Nick Perry's account information while they're still logged in as Jay Clark over here. So this is called an EDOR vulnerability, meaning that the insecure direct object reference is something that is inside of the link that you shouldn't be able to get access to. And then when you can change anything about that link, and sometimes even things within the web page, you can change certain things just about the link or the web page, and it gives you access to certain pages and certain information and even certain functions. And those things should not be available to you. They should not be possible. So that is one of the most basic and honestly very common forms of broken access control that can happen. So what we're going to do is we're going to actually go to the website that I had to launch here. There was a virtual machine that I was supposed to launch. We're going to actually go to that virtual machine through the attack box that we have here. And then from there, we're going to go through just some of the web pages that are there and try to find this flag that's available at the bottom right here. So it's going to be in the user's notes. So I am going to wait for this thing to load real quick, and then we're actually going to run that. All right, here we go. We are logged in. I logged in with the newt and test1234 username password. This is the link that I'm on. When you launch a virtual machine through TryHackMe, they give you an IP address, and then you can either connect to it via VPN from your own machine or from the attack box that they have. So I just use the attack box. And so when you log in and when you land on the home page, this is what it looks like. You have notes, things to buy from the store, yada, yada, yada. And then we have the URL, which is the important part right here. So as we noticed in the previous example or in the documentation of this, the URL can be changed, right? So if I go from 1 to 2 to 3 to 4, whatever it is, I should be able to find other users and notes information. And so that's literally what I'm going to do. I'm just going to, cycle through all the different numbers, the ID numbers, and then see which user will actually have a flag note for me to check. So let's run it and see what we can find here. Okay, here we go. So it was actually on ID 0. So I went from 1 and I went all the way up. When I got to when I got to 5, it gave me a hint, and it said, maybe they start less than 1 or whatever the hint was. And then it said, try going less than 1. And so I went to 0, and here is our flag. But basically, the whole idea is we just cycle through all of the IDs, and then we found the information that we needed, and that's pretty much it. So that's what broken access control means. You get to access pages that you're not supposed to access. And that's literally all that means. So let's talk about cryptographic failures. Cryptography is essentially encrypting data. We did a whole video on this, and you can go check that out. When you encrypt data, that means you are taking it from clear text, which is like this, and you're just turning it into a bunch of jargon, essentially, just a bunch of numbers and letters and symbols and things like that. And so you've now encrypted the data. And you can either encrypt data in transit, which means while it's being transferred from one place to another, or you can encrypt data at rest, meaning where it's sitting in a place and then it's not moving anywhere, but it can be accessed. You can go get that data that it's sitting in resting somewhere. Either of those things are very, very important. So you have to encrypt your data, and the more complex algorithm that you use to encrypt your data, the better off you'll be. Now, what happens is sometimes the encryption is weak and people can go and decrypt it easily, or sometimes it's not even encrypted to begin with, right? So if it's weakly encrypted or it's not encrypted at all, while it's in transit, somebody, which is considered an eavesdropper, and then the attack name right there is called the man-in-the-middle attack, meaning that somebody stands in the middle of the source point and then the end point, and then that person is now able to get the data while it's being transferred in transit. And that is a big attack. It's something that actually happens all the time. And it's one of the more common web application vulnerabilities. That's why it's number 2 in the top 10. So non-encryption of data is a big deal. If you use ports that are not secure or encrypted, you are leaving yourself vulnerable. If you use weak encryption, you're leaving yourself vulnerable. Encryption algorithms have evolved throughout time, and the very first one was MD5, and then as time went by, it became more and more secure. And so if you use a weak one, which is the MD5 or the MD1, let's say, if you use something like that to encrypt your data, you're just asking for people to decrypt your stuff and break into your not just your data sets wherever they're sitting, but log in as your username and do all that jazz that they can finally do. So it is very important to make sure that your stuff is encrypted. And cryptography is the concept of encryption of data. So if there's a cryptographic failure, that means it was either not encrypted in the first place, or there was a really weak encryption that was used to go ahead and encrypt that data. So let's talk about, or let's actually go ahead and use some supporting material to actually look at some cases, some real life cases of how cryptography can end up hurting somebody. All right, we have 2 supporting material sections for our cryptography exercise. And so the first one just teaches us a little bit about the structured query language, which is called SQL. And SQL is essentially a database language. So it's really easy to store a bunch of data, large databases inside of a language like this. And it could be MySQL, MariaDB. A lot of these things use the SQL syntax or type of language. And so once you understand the general concept of how SQL works, you can essentially parse through large data sets and find the type of data that you need. And this is done very frequently for a lot of just normal business activity. But if it's not properly secured, then as a hacker, as an attacker, somebody can go and parse through that data and find really sensitive information. So an example of this would be what we're going to be doing, or what we're looking at right here. So there's something called SQLite 3, which is basically a client that makes it very easy for you to use the command line to parse through databases. And in this particular case, we've downloaded a database. So we have some kind of database file that we were able to download, and it usually ends with .db. And so if ls, I'm not going to go through basic Linux commands here, but running an ls command, they found that there was a database file, and so then used file example db just to see what kind of file it is. So when you use that file, it shows you what kind of file you're dealing with, and it says SQLite 3.0 such and such. And so since it's an SQLite database, you can just use SQLite as the command, including the database name, to be able to get some information. And so when you do SQLite 3 and then use the database name, it actually changes your command line from your user to the SQLite command. And then from there, you can start doing some really interesting things. So if you just do .tables, it'll show you where all the tables exist inside of that database. So in our example database, there's a table called customers. And then from there, you can do a pragma table info customers, and it gives you the breakdown of the columns that are inside of this table. And in this case, we see that table 0, which is the very first column, is the customer ID. Then you have the customer name, the credit card information of the customer, and the password hash of the customer. So when we're looking at this, column 0 is the ID, so 0, 1, 2, 3, etc. Column, their name is Joy Paulson, and then Joy Paulson's credit card information is this, and then their password hash is this. So having all of this information, you can now do some, nifty little hacks here against any of these users here. And all it took is for us to first run the pragma table info command on the customers. We got the different information of the table columns, and then we run the select everything. So asterisk stands for everything. It's a wild card character. So you want to do select everything from customers, right? A very, very basic SQL command. And so you want to do everything from that table, and it gives you all the information that is inside of the customers table. And just like that, you have all that information. And now you can do, again, some really interesting little hacks. So for this case, we're going to be using some kind of a hash cracker to be able to crack Joy Paulson's hash, and then probably log in as Joy Paulson and get some other sensitive data. So that was the first set of supporting material, and we're going to get the second set of supporting material, which is basically going to show us how to crack that hash. And the tool that we're using in this case to crack the hash is a website called CrackStation, which is absolutely amazing. It's super, super easy to use, and it's kind of scary how easy it is to use. You don't need to know any command line or anything like that. You just need somebody's hash. And so if you go to CrackStation, at the bottom right here, or in the middle of the page, it shows you all of the different encryption algorithms that it supports, that it can decrypt for you. And some of these things right here are very, very secure. So a SHA-512 encryption algorithm is a very, very strong algorithm. But what's important to understand here is if you have a weak password, that password is most likely stored inside something called a rainbow table. And a rainbow table is essentially a list very similar to the SQL database type of a list, where you have on one column you have the password hash, on the other column you have the clear text word associated with that hash. What we need to understand is that you can't decrypt a hash by itself. So unless you have a database of stored passwords, for example, the RockU password list, which is 15 million passwords stored inside of this text file that's available for free that anybody can get. And unless you have something like that, you can't just go and decrypt a hash. And the way that CrackStation works is that they already have a large database of password hashes that have been stored, and they also have the clear text version of that password hash. So, for example, we're going to do a MD5 hash generator, and I'm just going to show you what this looks like if you wanted to just create a weak password versus a strong password. So if I use the word password as my password, okay, and I generate that, then it gives me my MD5 as well as my SHA-1 hash for this. So if I go and copy this and I put this inside of CrackStation and then I crack this, it's going to give me the word, because for the word password, the hash value is always going to be the same. So whatever the hash value is for a certain phrase, it's never going to change no matter where you go. So that hash value is already stored inside of CrackStation. So no big deal, right? And if I change this by literally one letter, so even if I don't even change it by a letter, if I just change the first letter into a capital P and I do generate hash, so pay attention to this hash right here. We do generate hash, and then the hash value completely changes. It's no longer the same hash, and all we did was we just changed the first letter of this thing. And so if I copy this again, and if I go here and I paste it in here and run the crack hash, it's going to show me the clear text password, because password with a capital P is still a very weak password. And it goes for any variation of this. If you use $signs instead of S's, if you use a 0 instead of an O, all of those things are all stored inside of the rainbow table of a website like CrackStation. Now, if I use this as an example, so let's do, this is a strong password 1 2 3 4 5 6 7 8 9, and then we'll do this. So let's say this is my password, right? Crazy long password, and it should not be stored anywhere inside of CrackStation. So if I go ahead and take the hash value for this, so let me copy this real quick. So if I take the hash value for this and then come to CrackStation, I should get an error message. So hopefully nobody has ever used that password. Yeah, so now you get an error message, because within their database, within their rainbow table, there is no previous password that's been stored that is this long ass, you know, every first letter has been capitalized, there's a bunch of numbers in it, there's some special characters in it. So this super long password no longer, it doesn't exist in any password dictionary online. So therefore, CrackStation can't find it for us. And this is how important a website like CrackStation is, and knowing how to use it. So they're not going to decrypt the hash value for you. What they're doing is they're comparing against the data set that they already have to see whether or not that password already exists in their data set, and then if it does, they show you the result of it. So that's how CrackStation works. So now what we're going to do is we're going to decrypt this specific password hash that they gave us, the same way that we just did right here, and then we're going to look at it. And so it's literally actually the password that we used before, so it's the word password has been saved over there as a password here. So you can, this is how you use CrackStation. Now there's a bunch of different command line tools that you can also use to decrypt hashes or decode hashes, I guess we can say. And something like John the Ripper or Hashcat or Cain and Abel, there's a lot of different tools. Hydra, all these things. There's a lot of different stuff that you can use to decode or decrypt a hash value. So that's the supporting the supporting material 2 for cryptographic failure. So now what we're going to do is we're actually going to go through a challenge, and we're going to find some of the hash values that we can use and decrypt in this particular case when it's attached to this specific website right here. So let's go check that out and have some fun with that. All right, I am now on this link right here, the 1010. I just opened it up in a new window just to make it a little bit easier for us to analyze. And it says right here in the question 1, it says that the developer has left themselves a note indicating that there's sensitive data somewhere. So in order to be able to look at the developer's notes, we literally are going to just look at the source code of the page. And through all the browsers, you can do this. If you just right click on the page, as part of the right click menu, the little thing that pops up, it shows you an option called inspect or view source, something similar to those lines. It just depends on which browser that you're using, that the text or the command for that is going to change. But essentially, it's along those lines where you can either inspect the source code of the page or you can view the source, something along those lines. And then once you do, you'll be able to see what is the actual source code of the page. And then within the source code of the page, you can see what the developer has left for themselves as any kind of a note. So we're going to do that here. And then from there, we're going to try to find the developer's notes. All right, and this is what it looks like. So I'm on Mozilla, and when I did the right click, it gave me an option called inspect, and that's what it does. It shows you basically literally the source code of the page. And now we want to scan this source code that's at the bottom right here to try to find the information that the developer has left for themselves. So let's see what we can find inside of this source code here. All right, right off the bat, inside the header information or inside the head part of the code, there's just something that seems a little bit interesting, is the assets folder. So href equals assets, style CSS, home style CSS. So assets, just from here, it just stands out. Let's see what else we can find here real quick. All right, so it wasn't on the home page, but when I go to login, I just literally click the login button at the top right here. There is a note right here by the developer, and it's been commented out, so you don't actually see it on the web page itself, but it says, must remember to do something better with the database than store it in assets. So the database is stored in assets.php or assets /. So now what we're going to do is we're going to go inside of the assets directory inside of this web page and see what we can find in there. And here we go. So we are now in the assets directory, and there's a little DB file. There's a database file here that I am going to click on and see what I can find in there. All right, when we click on that link, it downloads the file for us, the webapp.db file. So what we're gonna do in this case, we're gonna literally do the same thing that they showed us in the exercise. First, we're gonna do file.webapp.db to see what kind of file that we're dealing with. And it says that it's an SQLite 3 something something database file. So then I'm gonna do SQLite 3, and then I'm gonna do webapp.db. and it's going to open, oops, I did SQLite. There is no such thing as SQLite. So SQLite 3 web app.db, and then it's going to go into SQLite for me. So now what I need to do is I need to run that same command that we had earlier, which I think it was like pragma or something like that. What is it called? Yeah, pragma. First we're going to do dot tables. So that's what we're going to do first. We're going to do dot tables to see what is inside of this thing. And so we have sessions and we have users. Those are the two tables that we got in here. Let me just bring this to the center of the screen a little bit. So since we have sessions and we have users, what we really want, based on the questions that they're asking us here, is the information of the admin user. So far this is what we got, right? So it says, what's the name of the mentioned directory? That's secret. It's assets. What is the file that's on there that's sensitive? It's a web app.database. And then now we need to find this hash value. And of course, you know that that's exactly what I'm about to do, is I'm about to run this pragma code right here, or this pragma command. So I have the name of the table that I got with dot tables. I'm going to use pragma table information and then get the user's information of that. And then from there, we are going to get the info that we need, buddy. So, all right, and so these are the columns that we have over here inside of our table users. So we're going to run our select everything from users. And there we go. I forgot to put this semicolon at the end of it, so it gave me a new line to finish it. But here it is, right? So we have the column itself is going to have a user ID next to it. There's going to be some text, and then that's basically it. So you have the information right here. You have the user ID, and then you got some text. And it seems to be that this is the hash value for the admin user. So let's go and double check that here. And that is indeed the case. That is the hash value of the admin user. So you know what we're going to do now. So we're going to go ahead and copy this hash value. And then from there, we're going to go to CrackStation and crack the darn thing. And it seems like it's an easy one. It's an easy one to crash. So because of the fact that this is kind of taking forever for me to click on it, I'm just going to go and copy it from our answers. And then we're going to go to CrackStation. We're going to paste it. And we're going to crack this hash. And look at that. That is the password of the admin. And if you actually look at your keyboard, these are all of the letters that are in the top row of the keyboard. So it starts with Q, and then it just goes Q, W, E, R, T, Y, QWERTY, and then UIOP, and that's their password, right? So it's not any word or anything that you would recognize looking at it, but when you see the pattern on the keyboard, you're like, oh, that's a pretty lazy and easy password. And just like that, that's the thing. And then so when we crack it, we got QWERTY, and so now we're gonna log in as the admin, and we're actually gonna get access to that information. So easy money. And here we go. There's the flag, just like that. And here's the flag right here. So pretty easy, right? It's not, it's kind of simple and scary how simple it is to do some of these things. And all it takes is for somebody to know a website like CrackStation, for them to know that they can right click on the web page and go view page source and then get all of the page source data that's on a screen, or do right click on the page and click on inspect, and then they get to see all of the data that's on the screen. And if your developer was lazy or they forgot to delete a comment or something that they left for themselves, that's all it takes is for somebody to get the information that they should not have access to. And I mean, there's a lot of other tools that you can also use to look at the directories that belong to a website. So we could have used Nikto, for example, to just scan this website and get the information on the different directories, and then go to that directory and then find this database file. So there's a lot of different ways that you can do this, but this one was a very, very weak website, obviously. And from there, we were able to just use our browser to go ahead and find some sensitive information. So it's really, really crazy how easy it is to do these things. And just bear in mind as you're doing this for a website or for your company, or if you're trying to hack somebody, not saying that you should, but if you are, sometimes it's that easy. So let's look at the injection vulnerability here. All right, injection comes in two big forms right here. You have SQL injection, as you already saw, we know what SQL tables look like. And so SQL injection implies to the fact that you can go to a website that has a search bar or some kind of an input field. And it could even be like the username login field or something like that. But basically a search bar typically works. And you go inside that search bar and you inject an SQL command. So you say select such and such from such and such, and that's a basic SQL command. Or you do a .tables command or something just to see what actually exists and what kind of table that they're using, anything like that. So that will, if it's a weak website and it hasn't properly been secured, it'll return information to you that you shouldn't have access to. For example, the information inside of their SQL tables. Another one is command injection. So you just type in some kind of commands. It could be It could be a JavaScript command, which is a really big deal and it's used very frequently. It could be Python. It could be a bunch of different types of command that you should not be able to inject into the website. And then when you do that, it'll return some kind of result. So it's considered a system command. And when you do that, it'll execute some kind of command on the servers and then allowing you to get access to their systems or do some things that you shouldn't be able to do on their systems. So one of the easiest ways, or some of the easiest ways to defend against this is, number one, use an allow list, which means that there's a certain number of inputs that are allowed to be placed into your server and into your search box and all of those data points where you can actually enter information. And anything that's outside of that allow list is automatically just declined and is rejected. Another one is stripping the input, meaning that if somebody puts a asterisk inside when they shouldn't, or if they put any kind of symbol inside where they shouldn't, it automatically strips that input and it doesn't allow it to go through, which means that the full command itself won't be processed. So if you're running a JavaScript specifically, if you're running any kind of code and you're trying to input that in there, it'll strip that code of all of these malicious input characters, and those characters aren't going to be processed, therefore the command doesn't run and your website is protected. So you can either have an allow list, which can be kind of lengthy, or you can just do a simple stripping of the input so that they can't input any kind of dangerous characters and it won't mess with your website or return any information that it shouldn't, or it won't process any commands that it shouldn't. So that is what injection is. So we can now look at command injection and some examples that goes into it. All right, so we already talked about command injection a little bit and what it actually does. So PHP could be one of the languages that runs on a web application. There's a lot of web applications that operate based on the PHP language. And so if somebody can get access to some kind of an input area that they shouldn't get access to and run some PHP commands, then they get some information that they shouldn't get access to. So an injection web vulnerability allows us to be able to make those calls and get those commands executed and get some information out of it. An example for this is the cowsay command, and it's called the cowsay online. I think they actually made this specifically to demonstrate this, but there was at one point that people were using it to run their websites, and it kind of turned into a big deal. I'm not sure on that, so fact check me on that and correct me on that. But MooCorp has started developing a web application, and while searching for ways to implement their app, they come across cowsay command in Linux, which does exactly that. Instead of coding a whole web application, they decide to write some simple code that allows the cowsay command from operating the system console and sends it back, sends the contents back to the website. So if you look at the code, it's like this. So it says if this thing, the variable get is set to mooing, and then mooing equals get mooing cow, etc. So I'm not going to break this down because they actually explain it over here. So it says if the parameter mooing is set, then if the variable mooing gets what's passed into the input field. So if the parameter mooing is set, so if this is set, then whatever is passed into it, the variable mooing gets whatever is passed inside of that parameter. Now, if the parameter cow is set, so if set is set cow, so if the parameter cow is set, then the variable cow gets what's passed through the parameter. So then it actually executes the full command. So this is it. So it basically checks two set parameters. So if this is set and if this is set, in that case, we're going to pass through both of those things, both of those variables, cow and mooing, and then we're going to execute it, meaning it's going to be a Perl command that says, that uses cow say binary, and it executes those things. So when you do that, then you get some really interesting results. So in this case, this is our actual search bar, and you have it says your default cow, so your version of the cow variable is default, and the parameter right here, the input right here, goes into the variable mooing. So when you actually press submit here, it runs this first portion of the command, right? So it runs this right here, and then now whatever is input here is going to be passed through to the cow variable, and whatever is here is going to be passed through to the mooing variable. So it said TryHackMe, and TryHackMe is passed, and so right here the cow comes out and says TryHackMe, right? So very, very simple, nothing complicated about it. I mean, unless you don't know anything about code and shit like that, but all you really need to understand is that this thing is connected to the cow variable and this one is connected to the mooing variable. And then whatever is chosen here gets passed to that, and whatever is chosen here, or whatever is input here, typed here, gets passed to that. And then the result is this little cow is going to say whatever is input here. So now what we can do is we can actually put some kind of malicious code in here, and this cow is going to, instead of typing out the code, it should give us some kind of a result. So for example, echo my username is who am I, my username is jdoe. And this echo command is actually just prints whatever you put into here in a string. So it says it's executing who am I, jdoe, parse the result back into outer command, which is going to be executing echo. It's kind of beyond the scope of this. You should have an understanding of PHP and how this whole thing works, but apart from that, this is really what it does, is that if you just type into a terminal some kind of PHP command, so for example, echo, and then give it a string value, so everything inside of these quotes is a string, and then we gave it a variable, which is variable who am I, and who am I is a command that you run that gives you the name of the user that you're logged into. So then when you run that, right here, for example, you run who am I as the variable, and it'll give you, again, the default is going to be our cow variable, and the who am I command is the mooing variable, and the cow, instead of printing out who am I, it actually gives you the version, or not the version, the username that you're logged into, which is in this case a website server, which is Apache. And so it literally runs that for you, and it gives that back to you. And so you can run a bunch of different types of commands in PHP. So you have who am I, ID, IP configuration, and the IP address. So this will give you the IP address of the web server or the machine. Uname A, which gives you the username information of the version of the Apache server that we're on, and processes if you wanted to list them. So these are some of the things that we're going to be running. So it says what strange text file is in the website's root directory. So what we can do in that case is we can run ls, which is a command to list things. So here we go. This is what we got over here. So I'm going to close this little piece of code at the bottom just to make this a little bit easier to process. And we're going to mess around with some commands here. So let's see what we can get. All right, very, very simple. Look at that. So all I ran was the $, and I think it should show me the commands. There you go. That's the command that I ran. So very, very simple. You just have to put a $sign in front of it and put whatever your command is inside parentheses. And ls is a command to list. And so it gave me the CSS, drpepper.txt, index.php, and JS. Those were the stuff that's inside our root folder here. And so it's asking what is the text file, and so drpepper.txt. Now it says how many non-root or non-service, non-daemon users are there? And to be able to find that, we would actually have to find the command for it. And I forgot how to do that. So let me check Google real quick. Okay, so it's actually very basic. I thought it was going to be a complicated thing, but we're literally doing a cat, which is concatenate or just print out onto the screen the contents of the etc password file. And the etc password file has a list of all of the users that are assigned to this particular web server. And when we run this, we should actually get, there we go. So we get all the information on here. And so you have root, bin, daemon, so on and so forth. And it gives you all of the users in here. And I mean, there's a lot of them. And let me see here. What do we have that is non-root or non-daemon, whatever the other one that it was. All right, so here is some information that will make this a little bit easier to understand. So the UID 0 is reserved for root. Anything between 1 to 99 is reserved for other predefined accounts, which are daemon accounts. And everything between 100 to 999 are reserved by the system for administrative and system account groups. So anything essentially less than 1,000 is something that we're looking for, or excuse me, anything over 1,000 is what we're looking for that would be considered a non-root, non-service, or non-daemon account. And this is how it breaks down right here. So if you look at it, you see root and then x00 root, da 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 da. So this would be 1, which is the username. 2 would be the password, which is going to be always an X, because inside of the etc password file, we're not going to get any kind of password information. All that stuff is inside the etc shadow file. And the third piece is the user ID. So it's between the second and the third colon is the information that we're looking for. So if we go back over here, we will see that, so you have the user, you have the X for their password, and then you have everything between the second and the third colon, and there is nothing that is above the number 1,000. So there's literally all of these right here, starting from Apache, and if you go all the way over here, nobody 65,534. That is technically, I don't think that even counts. You have 405, 209, 123, 89, 85, 35. What is it? You have 31, 25, 22, 21. So it doesn't look like there's any in here. So if we go to our answer here, the answer that we had previously was 0. So that is the correct answer. And so what user is this app running as? So what we want to do is we want to run the whoami command to see what user we're running as. So let's go do that one. And when we run whoami, it gives us the user Apache, which is the answer to this question right here. And what is the user's shell set as? And so if we go here, right here where it says bin bash, that's what the very last item on that is, which is their command shell. So when we're looking at it, we're trying to find the very last item. So we're going to go back in here, and then we're going to run the whoami command one more time, and we're just going to, not whoami, excuse me, the etc password command. And from here, we're going to look at the Apache user and then see what their shell is set as. And there we go. So we got Apache, their user information, and then sbin no login is their shell. And so sbin no login, and what version of Alpine Linux is running, and I believe that is the uname a command. So let's go and run that one. All right, when I ran the uname command, it gave me this information, but the information that we're looking for is actually not in this result. So we're going to run a different search command real quick, and it is this one right here, which is lsb release -a. So we're going to run that, and that should give us the information that we're looking for, and it is not the case. All right, we're going to test out another one, which is uname r. Let's see what this one gives us. So I think actually the previous command that we ran was the right one, the uname a, and it gave us all the information, but it was, it's not congruent with the very last time that I ran this lab, because when I ran this, I actually did it a while ago, and I think that information has changed. Maybe the server that's been applied to this has changed, So I'm going to run this one other piece right here and see if there's any other information that'll come out of this. Oh no, yeah, there we go. So 3.16.0, name Alpine Linux, so on and so forth. So 3.16.0. So it actually has not changed. It was just a different command that we ran. And I literally got that command from just going to Google and finding a bunch of different terminal commands that would give us the version. So uname_r was the first one that I ran, and then you have cat etc release, that'll give the name and version of the Alpine Linux that's running on our server. And so that is the one that actually worked for us, and it is 3.16.0. That would be the answer. So it's actually the etc release command that we have here, which is right here. So cat etc cat/etc/**release, and then you put all of that inside of the parentheses, and then you get your information like that. So there we go, and that is it for this one for command injection. So let's go look at some insecure design flaws. All right, insecure design has to do with the actual setup of the application itself. These aren't actual vulnerabilities or anything like that. It's what was done when they were planning to build the application, and they took some bad steps in the threat modeling or preparing for the application's design and creation. So it's an actual flaw that was inside of the design of it. Insecure design vulnerabilities may also be introduced by developers by adding shortcuts around the code to make testing easier, and then they never removed it. So if they disable the one-time password validation in the development phase to quickly test the rest of the app and then not put it back, that's a design flaw, an insecure design flaw. So a version of this would be insecure password resets. So this happened on Instagram a while ago. They allowed users to reset their forgotten passwords by sending a 6-digit code to their mobile device. And if the attacker wanted to access their account, they could just brute force the 6-digit code. And this wasn't directly possible because Instagram had rate limiting, meaning after 250 attempts, they would just get blocked from doing anything further. That's what rate limiting is. And if it's a 6-digit code, there's literally so many different versions. Definitely more than 250. I don't know what the number is, but it's definitely more than 250. But they found out that the rate limiting only applied from the same IP. So if somebody had multiple IP addresses, then they could go up to 250 with one IP, from 250 to 499 with another IP, and then just keep going until they found the actual version of the 6-digit code that they needed to be able to get the password of the person. So it's kind of a big flaw. It is more of a complex flaw compared to some of the other ones that we noticed, but it is still a pretty big flaw, especially for a website like Instagram. So this is one of those things that was a design flaw on Instagram's part. And no user would be capable of using thousands of IP addresses to make concurrent requests to try to brute force something. It's in the design rather than the implementation of the application itself. So what we're going to try to do in this case is we're going to go to the another version of the website that we've been using and get into Joseph's account, and then try to find the design flaw in the password reset mechanism, and then try to figure out what we can do and abuse it and log in as Joseph. And so it's going to be on the port 85 on this website. All right, so you land on the website. It asks for your username and password. I just clicked on forgot my password, and what do I need? I just need to use my username, which is Joseph in this case. And let's see what the instructions are for us to be able to reset our password as Joseph. What's your mother's, sister's, son, nephew's, neighbor's friend name? So there's a few different security questions that's available for Joseph. It could be that one. It could be your favorite color. It could be your first pet's current address. So probably the easiest one would be the favorite color. And we can just mess around with a few different colors to see what we can get. So let's do red. That was incorrect. So let's try to do blue as the other one. That is also incorrect. So let's do green as another one. Oh, that was it. So there you go. The password for Joseph has been reset to this. So that was his favorite color is green. So we are going to now copy this password and go to the login page, and we're gonna log in as Joseph. See how easy that is? This is obviously an exaggeration because it's not going to be that simple, but it's just to kind of prove the point and drive the point home. And so when we log in as Joseph, there's a note here, and if I go inside the note, it says to move private files out of the server. Okay, fine, so it's not his note. Private, let's go to private and see what we can get here. And there you go, inside his private directory, there's the flag. And there you go, and that's the flag right here. Not even cats could save you. That's it. All right, so now let's go into the next one, which is security misconfigurations. Security misconfigurations happen when security has not been properly configured. It should have been, but it wasn't. So for example, it could be a default account that has an unchanged password. Usually a system comes with a default account and it has a default password, and if they never change those things, that's a security misconfiguration. If you have a permission on your cloud services like a Amazon S3 bucket, that is it's another security misconfiguration. Unnecessary features, error messages that are overly detailed and allow attackers to find out more about the system. So if the error message gives a version of the OS that was responded, or it says that, this command doesn't work, or anything of the sort, instead of just saying incorrect, try again, that could be information that can be exploited. Not using HTTP security headers, and these are just a few of them. So you can actually go to the OWASP Top 10 website and look at security misconfiguration, and then under that you get to see a lot more results as far as the different things that could be used as security misconfiguration. So something that happened previously to Patreon in 2015 was that there's something called the console, so /console, and it can give you an interactive terminal on the web page that you can print commands into, and you can actually run those commands. And I think it's called workzook or whatever, however you pronounce this. That gives you a console that can be accessed via a URL, and so it can literally be done in in a few different ways, because it could also be presented to the user if an exception is raised by the application. In both cases, it provides a Python console that can run any code that you send to it. So if you know how to use Python, or if you know how to use the internet and Google, then you can try to find a bunch of different commands that you can run. So for example, if we go to the console that's on our webpage, we can run this command right here, which is importing the OS, and then you do a semicolon and then print onto the screen, which is os.popen, and then this command, and then read it. So that's the command itself that's being done with Python. So this is actually two commands that's being run. Number one, it's importing OS so that you can run OS commands. And then the second one is the command itself. So I'm just going to take this exact same command and I'm going to run it. And in this case, it's going to give us an LSL, meaning it's going to list whatever's inside of our terminal. So let's go into the next port on our website here and run those commands. All right, so this is the website itself. Nothing exciting to do here. So what we're going to do is we're going to go to /console, because that's the one that they gave us. And let's see what we can do. There you go. We have the interactive console here ready to go. And so I can just drop in import OS, print the command, and then we're going to run it. And there it is. These are the contents of our command here. So you have app.py, dockerfile requirements.txt templates, to-do.database. So we have a bunch of things that we can run here. So what is the question it's asking us? It says, what's the database file? So to-do.database, that's the question here. And so now it says, modify the code to read the contents of app.py, which contains the application source code. What is the value of the secret flag in the source code? So all we need to do is just read this command right here. So we want to read the app.py command. So I'm literally going to do the same thing. I'm going to drop this in here. I'm going to repaste that original command. Oh, well, I didn't copy it for whatever reason. So we're going to take this command and we're going to repaste this thing, and then it's going to be the cat app.py. That's the command that we actually want to run. And there we go. So these are the contents of the app.py file. So now what we're looking for is the variable that, what is the variable called? The variable is secret flag. So we're looking for the secret flag variable on this page. So let's try to, oh, there it is. It's literally right at the top. So secret flag, THM, yada, 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 tiny misconfiguration. And so we copy this, and that is our flag, which is just a tiny misconfiguration. So easy, like super freaking easy. But yeah, that's another one. So this is a security misconfiguration that allows for a console to be presented to somebody that has access to that link. And then if you just go to it and you know anything about Python, then you can run your Python command and get information that you shouldn't have access to. So that is security misconfiguration. Let's talk about vulnerable and outdated components, which is, I mean, this one's pretty self-explanatory. I feel like we don't even need to do this, but let's just read through it. Why not? So if your website is outdated, if your computer is outdated, any of those things, so in this case, we're talking about web applications. So it would be the website. If they're using WordPress, for example, and if they haven't updated their version of WordPress in a while, you can use something called WP Scan, which is a terminal command line tool. And it's super freaking easy to use. And it can give you the version of WordPress. And then if you look online, you can see that for WordPress 4.6, for example, there's a vulnerability for remote code execution. And then you can go to exploit database, which is a large database of exploits that are already pre-written, ready for you to use at any point. And then you can just use that exploit that's been given for WordPress 4.6 and then get into their website, right? And execute some remote code. This would be very, very bad because it doesn't require any work, very, very little work on the attacker's part, and then they have access to the kingdom. So this is what is horrible about having outdated or vulnerable versions of websites or versions of portals or versions of the what are they called, the web builders, right? These are, WordPress is technically a web builder, and it's a platform that you can use to build your website, and it's really, really common, and a lot of people use it. I use it. But if it's an outdated version, if it's an old version of WordPress, that means there's probably a vulnerability that exists, and somebody could just go find that vulnerability really easily. And so you guessed it, right? We're about to go and actually find some exploits to be able to run against this website that we got. So let's do that. This is an example exploit that is for the Nostromo 1.9.6 web server. And so on this website's home page, there's the actual version of the web server that they used. And so if you go to exploit database and then just search for Nostromo 1.9.6, then you get a list of exploits that come pretty, they're just built for you, and then you can just download any of them and use any of them. So in this particular case, it's a Python file, and if you run it, then it gives you certain things. So it says, in this particular case, when they ran it, it gave back an error, and it said that the variable right here is not defined. Now, if you know anything there is to know about Python, you can kind of just read through the Python code and see what the issue is. And it's nice because it gives you the line of the code that the error happened in. So it says in line 10, there's this thing and it's not defined. And in this case, there was a comment right here that says this line needs to be commented. And all you need to do is put a hashtag in front of it, and it will comment this out, and it won't, the same error won't be caused anymore. And so when you do that, you run the code again. And in this particular case, you also have some instructions, I think, that told you that you need to potentially use this is just the IP address and the port that you want to do, and then you use the port and IP address that you want to attack, and then you just use the ID command. So it's just the terminal command that's going to run. So you do Python, the file itself, the IP address and the port, and then you do ID, and it'll run and it'll give you back the ID, which is in this case this information. So now we have remote code execution happening, and then if that ran, that you could probably run any other code as well, and you'll probably be met with some kind of a successful output. So most scripts is going to tell you the arguments that you have to provide. They rarely make you read potentially hundreds of lines of code to figure out what you need to do. So that's one of the things that is really nice about a lot of these exploits that have been pre-made by these hackers and left on exploit database for us. So it's scary. Like, the more I go through stuff like this, I'm like, damn, dude, I can't believe that it's that easy sometimes. So anyways, this is it for this particular exploit example. So now what we're going to do is we're actually going to do a lab on this. We're going to try to find some kind of a vulnerability exploit for this web page. All right, so this is it. That's going to be our URL that we're going to go to. There's a hint here. It's a bookstore application. You should check for recent unauthenticated bookstore app remote code execution. So that's what the hint gave us. And so this is the actual web application. It says CSE bookstore, and my PHP, my SQL, procedure functions, so on and so forth. Admin login 2017. So let's click on the admin login at the bottom right here, see what we can find here. Nothing to see here. Let's see what other information that we can find that might be able to make it easy for us to find an exploit for this. Okay, so there's nothing there. I am going to just run with this, and let's go search for CSE bookstore to see what we can find on exploit.db. Okay, so there we go. CSE bookstore actually shows up, and we have multiple SQL injection, persistent cross-site scripting, authentication, bypass. These are some of the things that we can do with this. So let's see which one will end up working for us. I think I actually need to do this on the browser of this thing right here. So let's go here and do it. All right, this one actually I had to do a few different types of searches. So when you do bookstore as one word, you only get 4 different exploits that show up, and then when you split it up between when you turn it into 2 words, basically, you get a much larger list of exploits that come out. And then there's one in particular that I believe is the one that I used last time, which is this one. It's the only one that has a check mark next to it. So online bookstore, unauthenticated remote code execution, and this is the one, I believe. Yeah, so this is also the ID 47887. So this is going to be the one that we're going to use, and since I'm already inside this attack box, I'm just going to download it, and then from here we're going to modify some of the code. And what we're going to do is we're just going to read through the instructions here, and I think it should be fine. I don't think there needs to be anything that I need to really modify here, but it gives us the comments at the very top. So exploit is this, Google Doc, vendor homepage, software link, tested, CVE, NA, and that's basically it. There's really nothing else that's been listed here as far as instructions. I'm going to look at the rest of the code to see if there's anything that we need to modify, but I think this is pretty much it. So let's check it out. All right, there were no other comments to check out, so we're just going to download this thing, and then we're going to run it in our terminal on the attack box and see what we can get out of here. All right, there is my file, 47887 right here. This is our Python file, and we do need to provide an argument, which is basically what we want to apply this code to. So I think it's maybe Python 3 that I gotta use. We'll see which one it is. 47887.py, and then we want the website that we're trying to hack, which is, let's see, what was it? 10.10.2.10.84, and let me extend this thing so it doesn't die on me. 10.10.2.10 and then 84. Okay, cool, that worked. And so it says, do you want to launch a shell here? And I do want to launch shell. There we go, RCE. So if I do ls, hopefully it'll work. It'll give me something. There you go, look at that. So we have all the information and it actually listed everything that we're in. So if I do print working directory, for example, it should tell me where I am, and it is definitely working. So now what is the question? The question, where is it? Lab, right here. So it says, what is the contents of the opt flag file? So I just really need to do that. So I'm just going to do cat opt flag.txt, and there we go. And there it is, THM, but it's not my fault, but it kind of is though. And there we go, that is it. So let's move on to identification and authentication failures. All right, this is actually a big one, and I think it's very, very important to understand how this whole thing works. So typically when you log into a website, you provide your username and password, and then when you log in, you can choose save identity, right? So when you basically save your credentials into your browser, and that way your browser knows that it's you, and then the next time that you go to that website, it keeps you logged in, so you don't have to re-log in every single time. And what's generated every time when you do that is called a session cookie. So your cookies go into your cache and it gets saved, and then that way you can essentially just revisit that website as many times as you want without having to log back in. And that's, you know, my interaction with TryHackMe right now is just like that, right? Every time I go to TryHackMe, I don't have to log back in because it's already remembered me, and there's a session cookie that's been attached to my browser on this particular computer. So when that happens, you can kind of take advantage of that vulnerability. So if an attacker is able to find flaws in the mechanism, they might successfully gain access to the other user accounts. This allows them to access sensitive data, and some flaws in authentication include brute force attacks. So if a web application uses username and passwords, we can, as an attacker, we can try to launch brute force, meaning just try a bunch of different passwords using a dictionary to try to guess the username and password that's associated with it. Weak credentials, as we already visited CrackStation. I mean, it's pretty easy to crack somebody's password, especially if they're using a weak password, and you just get their hash value and go to a website like CrackStation and it gives you the password. So for example, if you use password1 or some kind of an easy ass password like that, then that's it. And then there's another one, which is the weak session cookie. So session cookies is how the server keeps track of users, and if a session cookie contains predictable values, then we can set our own session cookies and access the user's account. So there's a lot of mitigation efforts for broken authentication, and depending on what that is, you can kind of solve for it. Some of the most basic ones are to avoid password guessing attacks, to make sure that you actually have a really strong password policy, avoid brute force attacks, by doing automatic lockout as a policy, so that if somebody has 3 failed password attempts, then it locks them out, and then the attacker can no longer do a brute force attack. Implementing multi-factor authentication, so if they have their username and password, it asks, okay, we're going to send you a secret code to your email, or we're going to send you a secret code to your phone number, or maybe use Google Authenticator or some kind of a third-party authentication like that to just make sure that these people are actually who they say they are when they try to log into the system. So authentication and identification are really important. The number is 7 on the list, but it's still super important to be able to mitigate for this and prepare for this. So what we're going to do is we're going to run another exercise, and we're going to now try to log in as admin and then Darren to try to get some information from this website. All right, in this practical, we're going to be going to this web server, and there's a very interesting concept here. So that, you know, obviously there's most likely going to be a user named admin. But if it's not configured properly, if the website authentication is not configured properly, if you use admin with a space in the beginning, it'll still register you, but now because you're registering as a new user, you can assign your own password, and then it'll actually register you as an administrator and give you all the access rights of that user, that original admin user. So to actually see this in action, we're going to do this for the user Darren. So we're going to go to this website. Here we go. Learn about attacking authentication, yada, yada, yada. So we're going to try to log in as Darren, and then it's going to say no, right? Because you can't do it because whatever. I'm going to type in password as his password to see if that's his actual password. Watch it be his password. Okay, so invalid username and password. There you go. So that's not good. So I'm going to register now as a new user, but I'm going to do space Darren instead of doing any other thing. So I'm going to do space, then Darren, and then I'm going to use Darren@thm.com as the email, and then we're going to do password as our password. And we're going to register, and there we go. We have been registered successfully. So now we're going to do Darren and do password, and that's going to be invalid. So what we're going to do again is we're going to do space Darren. It sounds like a astronaut name. Space Darren, and then password, and log in. And look at that. We are logged in. And there is the content that we need for our flag right here. So where's the flag that you found? And that's the flag. And so let's try to do it with Arthur, and same process. So now that we know that it's not gonna let us do it, so we're just gonna go and log out, and I'm just gonna register as a new user instead of going back and forth and showing you all that. So I'm gonna register here, and then it's gonna be space Arthur, and then Arthur@thm.com, and then password as his password. And there we go. We have been successfully registered. So we're now going to use space Arthur and password. And there it is. So fairly simple to understand, and this was just a weak authentication mechanism for that website. So it's kind of crazy. It seems overly simplistic, but it's very, very crazy how that works. So software and data integrity failures. So let's check this out. When we refer to integrity in cybersecurity and data information security, we're making sure that whatever the software is or the data is, it's been unmodified, so it hasn't been altered or changed in any way. And the way that we do that is we check the hash value of it. So if you wanted to go to, let's go to Kali. So if we go to kali.org for Kali Linux, and then you want to download any of these Kali Linux versions. So if you go and click on any of these, so I'm going to click on ARM, and then I go here, and I check one of these things, and I didn't mean to download it, so let's stop that, and let's go here. What I want to do is right here, so I'm going to click on sum. When I click on sum, it gives me the SHA-256 sum. This is the hash value of the file that I'm downloading. And if you download this from any other place, and they say, yeah, this is a Kali ARM version that you want to download, and you run the SHA-256 sum to get the hash value of the file that you downloaded, if it's anything other than this hash value, you can be sure that that file has been altered in some way. And this is how you verify the integrity of something that you're downloading. They use this a lot, this concept of the file integrity. This is used a lot in forensics. In digital forensics, there's something called the chain of custody. And in the chain of custody, you start out with getting the copy of the evidence from the crime scene, and immediately the forensic investigator, the digital forensic investigator, creates a hash value of that disk image that they got, and they put that hash value in the forms that go along with chain of custody. And along that, the management of that piece of evidence, if that hash value has changed even by one letter, and I mean, if anything changes, the entire hash value changes, as you saw when we went through the password example at the beginning. So if that hash value has changed from the beginning hash value, that means that file has been altered. That disk image has been altered. So that's what we use to verify the integrity of data. And so software and data integrity failures typically refers to this specific example, that something has been changed inside of the source code of that software, or something has been changed by the macros of the file that you're downloading, or anything along those lines. If it's been altered in any way, then you know that the hash value has been changed, and now you have a different file that you're dealing with. So the example of WinSCP is what we can check. And so this is on the SourceForge repository, and you look at it like this, and this is just another version of what we just checked out on Kali Linux, that it gives you the hash values right here. So there's the MD5 hash value, SHA-1 and SHA-256 hash values of this. And then from there, you get to run the MD5 sum, SHA-1 sum, SHA-256 sum against the file that you've downloaded, and it should be the exact same thing that's available on their website. If it's not, that means that you downloaded an altered file, and there's something wrong with that file, and you should not open that file. You shouldn't run it. You shouldn't do anything with it. And this is very important to understand, that anything that you download, if you're not downloading it directly from the website, so if you're not downloading from the Microsoft App Store, for example, and you're downloading from something separately, you can verify the hash value of the file that you downloaded to make sure that you actually have the right file. Otherwise, it's been altered and you should not use it. So software and data integrity failures, they arise from code or infrastructure that uses software data without using any kind of integrity check. And since there's no integrity verification being done, an attacker might modify the software and data passed to the application, resulting in unexpected consequences. And two vulnerabilities are software integrity failures and data integrity failures that are relevant to this. So we're now going to look at that in a real-life example. So software integrity failures. Suppose you have a website that uses third-party libraries that are stored in some external server and they're out of your control. This is actually a common practice, and so we can use jQuery, which is a JavaScript library. If you want to use jQuery in your website, without actually downloading it, you use the following command, and you use their link for the script, right? So you use the link from their actual jQuery website to be able to use this, right? Without actually having to download it. When a user navigates to the website, the browser is going to read the HTML code and download jQuery, and then process everything that you want in your code as if you had downloaded jQuery directly to your website. Now the problem is this: if an attacker somehow hacks jQuery and they change the contents of this endpoint and inject any kind of malicious code, then that puts you at risk as well. So anyone visiting your website could now pull the malicious code, execute it, and without them knowing, something's going on their website. This is an integrity failure on software. And the correct way to insert the library in HTML code would be to use the SRI and include, which is the sub-resource integrity. And you can include the integrity's hash value so that somehow the attacker is able to modify the library, and if any navigating through your website won't exclude the modification itself. Now, this is what it should look like here. So you have the original script portion, but now you're verifying the integrity using the SHA-256 sum that has been attached to that. And now you can go and generate hashes for your library if you need it, or excuse me, you can run this on your website if you need it, but if you wanted to generate any kind of hash value, you can do that as well if you need it. So what we're trying to do in this particular case is get the hash value of this thing, HTTPS code such and such and such. So we can just go copy this and go here and then run that URL here. And we want the SHA-256, so we generate that hash, and here it is. This is the SHA-256 hash value of this. So if I copy this and come here, this is exactly it. So they actually have the SHA-256 portion at the beginning as well. So SHA-256 dash, and then the rest of that. And that is the full hash value that we got here. So that's software integrity. So let's look at data integrity in this case. All right, usually when a user logs into an application, they're going to be assigned some kind of session token. We kind of talked about this already. And it's saved on the browser for as long as the session lasts, especially if you save your username and password. Then it's going to be repeated every single time that you access that application. And then they come in a lot of different forms, specifically as cookies. They're through cookies. And cookies are key value pairs. So the user, Susan, the user is the key and the value is Susan in this example. And then there would be password equals yada, yada, yada. And so if you were creating a webmail application, you can assign a cookie to each user after logging in, and a subsequent request, the browser would always send the username and the cookie so that that web application knows what's going on. And this would be a terrible idea security-wise because cookies are stored on the browser, and if the user tampers with the cookie and changes the username, or if a hacker tampers with the cookie and changes with the username, they could potentially impersonate someone else and read those emails. The application would suffer from a data integrity failure, and if somebody wanted to hack into anybody's system, they could just sniff your traffic. And this is why they say don't check your bank account or don't check your email when you're connected to a public Wi-Fi at a coffee shop, something like that. And a lot of people do this, by the way, because if you do that, if you use the public Wi-Fi at a location like that, somebody could be sitting in that cafe, and they're they're sniffing the traffic using Wireshark or TCP dump, and then they can capture that value from your cookies and then use that information to impersonate you and go into your information. I've talked about this with a lot of my friends. One of my friends actually recently, or a couple of months ago maybe, he got hacked and they got into his bank account and took money. It was crazy. There was like a really, really crazy situation, and he called me immediately. He's like, yo, what do I do? And I was like, you need to immediately change your password, because I knew that he uses a bad password, and he uses it on all of his stuff, on his email accounts, on his computer login. And I just knew, I'm like, bro, you can't be using this. And I told him multiple times prior to that, and he still didn't listen to me until he finally got hacked. And then that was the case where it's like, okay, well, you got to use strong passwords, man. This is like it's not even a question at this point. If you use a weak password, you're just asking for it. So a solution to this is an integrity mechanism to guarantee that the cookie hasn't been altered. And we could use some token implementations and the cryptography to provide proof of integrity without you having to bother with it. And something like that is called JSON web tokens. JWTs are simply tokens that allow you to store key value pairs and provide integrity as a part of that. And the idea is that you generate tokens that you give users with certainty that they won't be able to alter the value pairs and pass that integrity check. And it comes in three parts. So you have the header, you have the payload itself, and then the signature. And the header is the JWT, so the type is JWT, which is the JSON web token. Algorithm is going to be HS256 in this case. The payload itself is the username and the password. Excuse me, I think the EXP is the expiration maybe for this. And then you have a signature that's been attached to this, and it comes in three pairs, and so that's how you verify the integrity of it. The header contains metadata indicating it's a JWT, and HS256 is the algorithm. The payload contains the data, and then the signature is similar to a hash value to verify the integrity of that payload. And we can use this online tool that they gave us to go ahead and encode or decode base64 and try encoding the header of the following token. So we're going to encode the header of this token, which is this piece. And so I go here and do this, and the encoding would be this. So if I decoded this, it gives me that. So it's JWT algorithm HS256. So yeah, it's a decode, not encode. The signature contains binary data, so even if you decode it, you won't be able to make much sense of it. If we use the payload to decode, then you'll get username guessed, expiration, same thing. So there it is. So this is decoding the, that's so crazy, decoding the base64 information. So JWT and the non-algorithm. So you just have a header and then you have a payload, and there is no signature that's been attached to it. And it's very similar to the other piece. It's just that there is no actual signature attached to this. So if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and the payload, modify them, and then encode them back. And then you remove the signature part but kept the dot at the end, this little piece at the very end of it. So it sounds simple. So let's go and actually do this on our web application here. So we're going to go to our portal right here, and we're going to use the 8089 port and get some cool information here. All right, so here's our web portal here. So we're going to try to get logged in as guest. And so it says invalid credentials. You can also log in as guest with the password guest. So it already gave us the password for a guest. So application as guest, what's the account password, yada, yada, yada. So guest. So now what we're going to do is we're actually going to log in as guest, and save that. And then so we're going to save ourselves. Hello guest, only the admin user is allowed to get the flag. So now what we want to do is we want to follow the rest of these instructions. So it says if you're logged in, you should now have a JWT stored as the cookie in your browser. So we can look at the developer tools, and we can also do that by clicking right-click inspect. And then we'll be able to look at it either if we're on Firefox, it's under storage. If you're on Chrome, it's under application. So in this case, I am on Firefox, so I'm going to click on inspect, and then it'll give this information for me here. And then right here at the bottom, I'm gonna click on storage, and then it has it saved right here. So the name for me is JWT session, and this is the value that's been assigned to it. And notice how there's a dot here, and then there's another dot here, right? So what we got here is the first question. It says, what's the name of the website's cookie containing a token? It's JWT session. So what we're going to do is we're going to modify the token so the application thinks that we are the user admin, and then get the flag that's been presented to us. So in this case, what I need to do is I need to get this information. So if I click on this, I should be able to go in there. There we go. So I have this whole thing, and I'm going to try to get the full thing. There you go. And I'm going to copy this, and we're going to go on that one website that they gave us here, which is, where is it? This tool right here. So I can paste this. There we go. So this is the full thing that I copied. So what I'm going to do is I'm going to remove the first portion, and I'm going to remove the last portion. And now we have username guest, and that's it. So now I want to do is I want to change this username to admin, the output string. So I'm going to copy this part, and I'm going to go to encode, and I'm going to paste it, and now I'm going to change it to username admin. So this is what's the base 64 version of that is going to look like. So we're going to copy this, and I'm just going to use like an online text editor to make this happen. So online text editor, and we'll do edit pad here, and there we go. So this is the new thing that we got. So what I need is now this thing one more time. Copy, go here, paste that. So now what we want to do is we want to replace this portion with the new info that we got. So we're going to copy this, and we're going to paste it instead of this portion right here. So this, it's basically between the two dots, and now we have this. So now I'm going to go copy this whole thing and go inside of my browser, and we're going to do Control-Alt to highlight that whole thing, and we're going to paste it in here and press enter. All right, so here's what we're going to actually modify here. We're going to remove the signature, because the error that I got is that either the token or the signature is invalid. And I know that I modified this part correctly, but the one part that I'm going to change now is change the algorithm from HS256, which is what was over here. I'm going to change it to none, and then we're going to just remove the signature at the very end of it. So we're going to go back to our encoder decoder thing right here. And so this is what I had. So I'm going to take this piece. I'm just going to take that out altogether. I'm going to keep this piece of information like this. I think I might be able to even do these in one line, like so. Oh, there you go, just like that. So I can change it in one line as such. So now what I'm going to do is I'm going to take this whole thing and copy this, go here, put that in here. It should, it did not separate it by dots. So what if I put a dot here? No, so it's not going to work like that. So we're going to separate them by 2 lines. Nope, it's not going to work either. So we're going to just remove this piece because I already have this piece. And I'm going to change this to none. And this will be the new information. So I'm going to copy this, and I'm going to go to my notepad here, and I'm going to paste it here. And now I have new information. So we're going to keep that dot at the very, very end. And we're going to go back down here. And we're going to change the value of this to our new value. Press enter. And here we go. Fingers crossed. Refresh the page. There you go. Just like that. It worked. THM, don't take the cookies from strangers. So essentially what we did is we went logged in as guest. We got the token. That's so crazy how it's so scary how easy this shit is. We got the token value here, and it came in 3 sections, which it looked like this. It had 3 different sections separated by these dots, right? And so we removed the very last piece, which is the signature, and then we changed the header from the algorithm HS256 to none, and then we changed the username to admin, and that's it. That's all we did. And then we pasted the new value after we encoded it with base64, and we were able to get our cookie. So that is that for data integrity failure. So let's go to security logging and monitoring failures. All right, so when applications are set up, everything needs to be logged. If not, I mean, it has to be logged, and usually it is logged. We actually did a video, the last video that came out was on logging and auditing and all that. So logging keeps track of everything that has happened, so that when you do an audit or when you're trying to do an incident response or trying to figure out what happened in any kind of situation, you just go review the logs to see what's going on. And usually there's a status code that's attached to it. There's timestamps, usernames, API endpoints and page locations, IP addresses. All of those things are inside of the log, each of the log items. Like each line item inside of a log, usually, especially for web pages, has this information. So what type of HTTP requests they were making, the timestamps associated, usernames, endpoints, and the IP addresses, the source IP and the destination IP addresses. So all of that information is usually inside of the log. And it's important to ensure that they are all stored and secured, and multiple copies are stored in different locations, just in case somebody gets access to it or they wipe your systems. So after a breach or incident has occurred, you refer back to these things for incident response. If there are multiple unauthorized attempts for a particular action, then it's logged in. Failed login or any kind of failed word that shows up inside of your logs, that's kind of a clue as to see what's going on. Requests for anomalous IP addresses or locations. There's an entire directory and list of anomalous IP addresses, and a lot of different, MITRE has them. There's another one that was really, really big. I forget the name of it right now, but there's a lot of websites that collect anomalous IP addresses. The FBI, Federal Bureau of Investigation, has anomalous IP addresses. And it could be something that has been done to attack your system. So it can indicate that someone else is trying to access a particular account. It can also have a false positive rate because somebody could be using somebody else's IP address to do this. Automated tools, particular automated tooling can be identifiable. So using a user agent header or speed of request, these can mean that there's an automated tool that's being used. It can indicate an attack is being, obviously, so common payloads in web applications. It's common for attackers to use payloads, and detecting the use of these payloads can indicate whether or not somebody's trying to do something shady. Detecting suspicious activity is not helpful just by itself, so you got to have something to either rate the impact level or have some kind of remediation. So certain actions will have a higher impact than others, and they need to be responded to sooner. So if it's more severe, you have to take care of that before you take care of the less severe ones. Very, very basic. So what we're going to do is analyze the provided sample log file, and it should be inside of this thing, download task files. Hopefully it's already inside of the attack box that I'm in. Otherwise, I got to find a way to transfer it. So let's see if I can find that. All right, so I downloaded the log file on my own computer, and it's a small one, thankfully. So what we can see is the status code, the specific flag that's been attached to it, the IP address, and the username that's been attached to it, and the timestamp, and then the page that they tried to visit. So you have the login page in all the cases, you have the username in all the cases. 200 status code means that they were successful and it was all okay. And then this is the IP address that they used, right? So in this case, you have 401.401.401, which means it was an error, it was not accepted, and it was an unauthorized request by this specific IP address trying to do admin, administrator, anonymous, or root. And it all happened very, very quickly, right? So it all happened at this specific time, 5 seconds apart. So you can tell that they're doing some kind of a brute force attack using admin, administrator, anonymous, and root login IDs here. So that's the log file that we're looking at. So now in this case, if we go here, it says what's the IP address of the attack that the attacker is using, and that's the IP address that we already established right here. And what's the type of attack? It's a brute force attack. So that one is pretty simple. And last but not least, we have server-side request forgery. And this is a little bit of a complicated one. It took me a while to kind of grab this or to wrap my head around it. So hopefully this time around it'll be a little bit easier. And for this one, I'm actually going to read through all of this instead of trying to paraphrase it. So this type of vulnerability occurs when an attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the contents of the request itself. These vulnerabilities often arise from implementations where our web application needs to use third-party services. So for example, if a web application uses an external API to send SMS notifications, which is texts, to its clients, for each email, the website needs to make a web request to the provider's server and then to send the content of the message to be sent. Since the SMS provider charges per message, they require you to add a secret key, which they pre-assign to you to each request that you make to their API. The API key serves as an authentication token and allows the provider to know to whom the bill should be sent. So basically, who do they need to charge? And the application looks like this. So you have the URL. Inside of the URL, there's SMS followed by the question mark, and then the server, which is the name of the server, .sms.thm, and the message is hello. And so it's going to send the message hello, and it first sends the request. So get the message, the full block right after the / right here. It sends a get request, including that whole thing. It gets sent to the mysite.com, which is the actual domain itself, and the query is built, and this is what the query would look like. So it's going to be on the server SMS THM, API send, and then that's the message, and then forward it to the SMS provider using their API key. So this is what that would look like. It's another get request, and then API send, that's the message, and this is their API key. And so following all of this, we can understand where the vulnerability itself lies, and it exposes the server parameter to the users, which defines the server name of the SMS service provider. And if the attacker wanted, they could simply change the value of the server to points to a machine that they control, and the web application would happily forward that request to the attacker instead of the SMS provider. As a part of the forwarded message, the attacker would obtain the API key, allowing them to use the SMS service to send messages at our expense, and they would need to make the following request to the website. So first, they go to the website, server is going to be the attacker's server.thm, and then the message is whatever, and then it would make the request to attacker.thm API send the message. And then you can just capture the contents using netcat and whatever that this would be their specific server. So attacker.thm could be their IP address or anything of the sort. And if they have a netcat listener going on their port 80, which is the HTTP port, it would just receive that information because that's where they're sending it to. And then this is the information that they get, right? So the connection received, get request, public docs, the host is this, the user agent is all this information about the user agent. And this particular example is very basic, but it's essentially the concept is how this works. So what we're going to do is we're actually going to run this, and hopefully this time around it'll be a little bit easier for me to actually complete this. So what we're going to do is we're going to go to this web portal. We're going to find a simple web application. We'll see an admin area, and that's going to be our main objective. So follow the instructions to try to gain access to the restricted area. So I'm going to go to 8087 on our IP address, and here's the website. And so we're going to find the admin area in the menu. Admin interface only available from localhost. Okay, so explore the website. What is the only host allowed to access this, which is localhost. Check the download resume button. Where does the server point to? So let's go back to our previous portion, and let's go to, it's in the home page where we can do download resume. So if we click on download resume, it's going to point to file root download PDF. So this is actually pointing to the local host, as it says. So where does the server parameter point to? Securefilestorage.com. Is that indeed the case? Oh, you know what? Instead of clicking actual download, I think I'm going to do this. And let's see. We're going to do an inspect on that button and see where it goes. So there it is. And that's the button right here. So that's actually it right down here. So it points to download server securefilestorage.com, etc. So that's where it's pointing to. And so that's the answer right here. So now using server-side request forgery, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? So what we got to do here is we got to point this to our server. So I'm going to copy this value and I'm going to change it to my server. And there it is, but I do need to put this portion at the beginning of it. So we do need to put the actual web page at the beginning of this whole thing. And we're going to put it at the very beginning right here. That's going to be the full link. And what we need to do is change the server. So from this, it's going to actually point to my attack box. And so what I need to do first is I need to create a netcat listener the way that we had it in the example that we got. So we're just going to do netcat LVP, and I'll do port, 80? We'll just do port 80. So netcat LVP port 80, that's already in use. So I'll do netcat LVP port 8087. Is that already in use? No, that's fine. So 8087, so that's already listening. And so now I got to come up here and do 10.10.176.126 as the actual .com right here. So HTTP 10.10.176, what was it? 176, 126. Let's see if that works. It worked. Look at that. Hey, it actually worked. Okay, that was not that bad. And there's our API key. I'm just an API key, and there it is. So this was not that bad. I don't know, maybe it was just so far over my head last time that I had no idea what I was doing. But it seems to be way easier, way easier this time around, right? So that is it. So you just make sure that you have that portion correctly configured, or you just basically copy this entire value right here. You put it in front of the actual URL right here, and then you change the part where it's after the equal sign. You change equals to this entire piece right here, securefilestorage.com. You take that whole thing and you turn it into your attack box IP address, which is this particular case, or your computer's IP address at whatever port your netcat listener is running on. which is in this case port 8087. And just like that, we got our flag and everything else was good. So very, very excited about this one. I'm very happy that that was actually done. So this was actually the beginner, kind of like an introductory to OWASP Top 10. We actually have 2 more rooms around OWASP Top 10, API Security, Top 10 1 and Top 10 2. So we're going to do an entire other set of videos just around this concept, and it should be fun. Honestly, I'm very, very excited about it. All right, what are the best practices for API authorization and authentication? What even is an API, right? And how do you identify authorization level issues? How do you handle excessive data exposure so your systems don't crash and you don't go through denial of service? And how do you take care of the lack of resources that can happen, the rate limiting that needs to happen for a website and an API to run successfully? These are some of the questions that we're going to be answering in our video today, and we're going to be using a cool little API website here to actually make some API calls and take advantage of some vulnerabilities, and so where we can get information that we should not have access to, and we'll do some fun API hacking in today's video. All right, OWASP API Security Top 10 Part 1. I think this is basically what we're in right now. So if we were to review this whole thing one more time, and I don't want to accidentally lose my zoom, so we're just going to go right here. So first we need to look at the best practices for API authorization and authentication, identification of authorization level issues, handling excessive data exposure, and lack of resources and rate limiting issues. The prerequisites for this are how websites work, HTTP protocols, methods, principles of security, and OWASP Top 10 web vulnerabilities, which we did in the last video, I want to say. So the OWASP Top 10 was the last video. Let's verify that. No, actually it's not. This is a whole other thing. Look at this. This is a crazy freaking video, or crazy room, I should say. So severity 1, severity 2, so on and so forth. So this is a pretty robust room just by itself, and it's a 2-hour room, but it is an easy room, so I guess that's something that we can revisit later. But I did do another video on the OWASP Top 10, which is the one that came out right before this one, which also goes into the top 10 OWASP vulnerabilities or the attacks that can be done for the year of 2021, which is the most recent release of the OWASP Top 10. Principles of security we definitely did earlier on in this pathway. HTTP protocols and methods we did, and how websites work is a very, very basic one. So I never did a video on this, but you can go check this out as well. I think this is another one of the free rooms that's available on TryHackMe. And nope, it's actually a subscriber only room. But I mean, you can go and check these things out. So, HTML, JavaScript, sensitive data exposure, HTML injection. These are all very, very basic concepts for web development or websites in general. So if you don't know what those things are, you're always more than welcome to go check them out. But this is basically, these are the prerequisites for the room that we're about to jump into. And just understanding what the Open Worldwide Application Security Project, which is OWASP, and just what it stands for, what it does, what they do, which they essentially just release a top 10 list of vulnerabilities every few years. I think every 2 or 3 years they'll release a new one. So the most recent one happened in 2021, and that's the one that we did the last video on. The machine that we're going to be working with is a Windows machine this time around, and I've already started it. I think by now, since the IP address has been populated, yeah, we already have this. So I'm just going to open this up in a new window so that we're ready for the next piece. And so let's actually jump into understanding APIs. All right, the first thing that we got to do is just understand what an API actually is, and how it works, what you can do with it regularly if you were doing it, with good intentions and stuff like that. And we'll look at some recent data breaches that actually happened through some really popular services. So API stands for Application Programming Interface. It's middleware, and it facilitates communication of two software components using protocols and definitions and requests and stuff like that. The API context, the term application refers to any software having specific functionality. So it doesn't have to actually be a app in a way that you have apps in the App Store. It could be a web application, which is a web portal, or the app that we're talking about when we download apps. But essentially anything that you can use that has a specific functionality, and the interface refers to the service contract between two apps that make communication possible. So you can have Google Chrome and the Microsoft portal. Those could be the two different applications that are communicating between each other. The API documentation contains all the information on how developers have structured these responses and the requests, and the significance of this is the API is a building block for developing complex and enterprise level applications. So you can use the API of Google Chrome, the API of Microsoft 365, Office 365. You can use the API of ChatGPT. You can use the API of Instagram. You can use the API of Facebook. You can use the application programming interface of any service that has something like that available that you can use to develop enterprise level applications or to develop applications for yourself. And I've done this several times. So this is something that you should actually be familiar with just for your own purposes. You don't necessarily need to be a super advanced programmer to understand what API does and how to leverage API. And I do recommend that everybody kind of at least wraps their brain around what this whole thing is and what they do and how you can use those things to your advantage for your own life. But of course, if we're looking at it as a penetration tester or a cybersecurity professional, it has its own context and its own layers on that side. So LinkedIn data breach happened in 2021. 700 million LinkedIn users were offered for sale on one of the dark web forums, which was scraped by exploiting the LinkedIn API. The hacker published a sample of 1 million records to confirm the legitimacy of the breach, containing full names of the users, email addresses, phone numbers, geolocation records, profile links, work experience information, and other social media account details. And the things like their work experience information and various social media details are usually public, and you can get those at any point. But things like their email addresses and phone numbers, people don't usually publicize that stuff. And so if something like that was done through a web scraping attack, then that's actually a pretty decent list. Then you have the Twitter data breach that happened in 2022, where 5.4 million Twitter users were released for sale on the dark web by exploiting a 0-day, which means it's never been done before, and it's a brand new exploit and vulnerability on the Twitter API that showed Twitter's handle against a mobile number or an email account. And then you have the Pixlr data breach that happened in 2021, and it's an online photo editor app that impacted about 1.9 million users. And there was usernames, email addresses, countries, and hashed passwords that were released from Pixlr, which could be pretty gnarly, especially if you have private photos that you don't want people to see and they get leaked. So these were some these are famous. Like LinkedIn is a very famous application. Twitter, which is now X, it's a very, very famous application. So stuff like that getting leaked and getting hacked into as recent as 2021 or 2022 is it's pretty big deal. So what we can do now is we can approach the concept of security for APIs. But first we have some questions. So in June 2021, how many million records were as a sample posted by the hacker, which is 1 million, and the API documentation, is it trivial and not used after API development? And it is not trivial, it's used all the time. And so that would be no, it's not trivial. And so we do understand the basics of APIs. So now let's jump into the first vulnerability, which is broken object level authorization, also known as BOLA. Generally, API endpoints are utilized for common practice of retrieving and manipulating data. BOLA refers to the EDOR reference, so the insecure direct object reference, which we talked about in the last video, which was like the general video on OWASP Top 10, which creates a scenario where the user uses the input functionality and gets access to the resources that they're not supposed to access, that they shouldn't have authorization to access. Usually these things are done through programming in models. So model, view, controller architecture at the code level of the the application, right? So the absence of controls to prevent unauthorized access can lead to data leakage that we just talked about, and even an account takeover completely. So users or subscribers in the database play a critical role in an organization's brand reputation, and if that data is leaked, then it's a brand reputation impact, it's a financial impact. So there's a lot of big impact that would be associated with something like that actually happening. So what we are going to do is we're going to go through our Windows browser or Windows machine, and we're going to open up the Chrome browser and do the Talent API Tester application. And what we're going to look at is this scenario. So we have Bob, who's working as an API developer and developed this endpoint that will allow applications or developers to request information by sending an employee ID. In the virtual machine, we can request by doing a GET request and going to this specific link, which is basically the link at localhost on port 80, and then the MHT, which is the company name, and then this is the API itself. So that's the link to the API. And so when we look at that, then we should be able to get some kind of a response, which is in this case a 200 OK response, meaning it loaded properly, and the issue of the API call, so on and so forth. So I'm gonna first actually go and load this thing. Oh, it's already here. So it's already actually been loaded for us. And so what we're doing in this case is we're submitting a GET request. So we're submitting a GET request to this particular URL, and 127.0.0.1 is the URL for your local host. On every computer, 127.0.0.1 is the URL for the local host. So we're going to send this, and let's see what we're going to get. And so here we go. We got the response here. I said OK response, and let's see the request headers that we got. And these are our request headers, and there's no content here though. So let's see what I need to do. I think I need to maybe change this. Instead of 127.0.0.1, I need to change it to localhost at 80. So we're going to do that. Well, no, I mean, it gave me the same information. So let's see what we got here. In this particular screenshot, if we were to look at 200 OK, in the body there should be John Scott and the flag associated with a user 1. Oh, you know what? I think I didn't do that part. I think that part's missing. User 5 there's nothing here. So if we do user 1, that might be the thing that we should be looking at. So if I send that, there we go. Now I got it. There we go. So that's the flag for user 1. We probably need this to answer our question here. So that's it, really. I mean, on the local URL at MHT API rule, this is the API specifically itself, right? So this location is their company, and then this specific portion, this specific portion is the actual API call that's being made, or the API link that's being used, and then when we change this number, we get various users to come out as our response for the API. So the problem is that it's not validating the call to confirm whether it's valid or not. It's not checking for any authorization. So the solution is so that Bob will implement an authorization mechanism that he can identify who's making the calls to access employee ID information. It's done through access tokens or authorization tokens. And in this example, the authorization token would be done so that only the headers with valid authorization tokens can make a call to that specific endpoint. And if we add a authorization token and call this right here, only then you'll be able to get the correct result. So moreover, the API call with the invalid token will show a 403B forbidden. And in our particular case, I mean, it showed us the access. So that part seems like it didn't really bother us. So that should be fine. So suppose the employee ID is an integer with an incrementing value. Can you check through the vulnerable API endpoint the total number of employees in the company? So it seems like we had no issue with our authorization here because it actually allowed us to do it. So let me see. Let's see if we can find the total number of employees by just changing the ID at the end here. Okay, after the third one, no more users came up. So I guess we can kind of conclude that there's only 3 employees, and one of them was a tester. So there you go. 3 is the right number. So what is the flag associated with employee ID number 2? And that was, I think her name was Alice. So let's see. It is Alice, and this is Alice's flag. And we can copy that and go here and paste her flag real quick. And then what is the username of employee number 3? And the username of employee number 3, oh, I see, their username is Bob and the name is Tester. So Bob is the employee ID username. There we go. This is the API. That's basically the API that we were using in this case. The API endpoint, I should say. So let's go to vulnerability number 2, which is the broken user authentication, which is BUA. So let's see what that means, what that stands for. All right, so authentication is a very important part of an application actually working properly, and especially an application that actually has sensitive data. So broken user authentication means that the API endpoint allowed the attacker to actually access something either because there was an invalid implementation of authentication or there was no authentication. So absence of security mechanism like authorization headers and tokens and stuff like that. So in a situation where the attacker acquires the capability to abuse the API, it eventually ends up in a data leak, data deletion, modification of the data, or even the complete account takeover by the attacker. So hackers have created special scripts to this, and they can profile or enumerate users on a system through a specific endpoint, and that can lead to any user to take another user's identity, which, but I mean, it means a lot of really crazy things. So in BUA, in broken user authentication, the attacker can compromise the session or the authentication mechanism and easily access sensitive data. They can pretend to be someone authorized and can conduct an undesired activity that is only limited to that authorized person, including the account takeover entirely. So now what we're going to do is we're going to go back to the API, but now we're going to API rule number 2 with user login v. And the endpoint is going to return a token which will be passed on as the authorization token, and then the user details to show the specific employee. Bob successfully developed the login endpoint. However, he only used the email to validate the user from the user table and ignored the password field. An attacker can only require the victim's email address to get a valid token or account takeover. And so we can test this by sending a post request to the local host MHT API rule 2 and then user login v with email and password in form parameters. And so this is what it's supposed to look like in this case. And then when you get a proper response, it brings back their token, which is not good. So the vulnerable endpoint received a token, which was forwarded to their details. And then to fix this, we'll update the login query logic and use both email and password for validation. The endpoint API rule user login s is a valid endpoint as shown below that authorizes the user based on password and email in this particular case. So what we're doing is we're going to send a logic query in this case that both uses the email and the password. And what's the difference right here? Because this one also says email and password and it has it checked, so I don't see a specific difference here. So API rule 2 user login v, API rule 2 user login s. I see. So user login s probably stands for secure versus user login v, which stands for vulnerable. I gotcha. And then in this case, it will return an unauthorized access. So mitigation for this particular thing is so ensure the complex passwords with higher entropy, which means that the randomness of the data is high. So if it has a high entropy, it means that there's higher random data, and it's not 11111, right? It's like a random series of characters and letters or phrases, etc. So the repetitive stuff would not be random. It's very useful to identify compressed and packed malware, so on and so forth. So passwords with high entropy do not expose sensitive credentials in GET or POST requests. enable the strong JSON web token, which is JWT, which is what we also covered in the last OWASP video. Ensure the implementation of multi-factor authentication where possible, account lockout, or a CAPTCHA system to mitigate brute force. So MFA, where you basically send somebody a secret code to their email or their phone number, lock them out after a certain amount of time if they do incorrect passwords, and a CAPTCHA system to make sure that it's not a bot that's being logging in or a script that they used. And then ensure that passwords are not saved in plain text in the database to avoid further. So encrypt the passwords basically. So now let's go and access the second API endpoint. And we're going to use the, I would say the vulnerable one. So it's API rule 2 user login v. So that's the first thing that we're going to do here. So API rule 2 user, and then it's going to be login v. So if I enter this thing, let's see what we can find. Oh, I got to do a post request. That's what I did wrong. So let's do a post request. There we go. Okay, so we got a 401 unauthorized situation here for API rule 2 user login v. And let me see, I think I need to actually add a form parameter. Maybe that's the thing that was missing. Yup, there it is. So I just added the form parameters here. Email, which is the email they gave us. Password, which is anything. And look at that, the vulnerable website gave us the token. Not good. So this is the token that we need for our answer here. And so to which country does sales MHT belong? And what does the hint give us? The hint says get a valid token from a vulnerable endpoint and pass it to, I see, the user details. Okay, so we're going to get a valid token and pass it to the user details. So what we do in this case is we take this, copy, and go up here, and we're going to replace this email, and then, whoops, let me just click send here. And so there we go, we got the valid token in this case. So now what we're going to do is we're going to take this thing, I'm going to copy this, and I'm going to send it to passwords, and then I'm going to go to user details, and let's see if this works. Okay, there we go. So once I changed it to a GET request up here and went to user details right there, the post request, or the parameters for the post request went away. And then all I needed to do was create a header right here, so authorization token, and I just pasted in the authorization token, and there it is. Joyce from sales is in China. So let's go and input that here. And just like that, we got that answer. So is it a good practice to send a username and password in a GET request? That is not a good practice. So just like that, we were able to complete this thing right here. So not bad, we're making some good progress. So vulnerability number 3, which is excessive data exposure. I mean, that kind of just gives away all the information that we need, doesn't it? But let's read through this and let's see what this is. All right, excessive data exposure happens when you disclose more than the desired information to the user through some kind of an API response, right? So this was one of the things that we used, I think, in the SQL injection that we did in one of the videos on SQL injection. It can also happen through server-side request forgery, where the server just responds with information that gives away some kind of details about the login process that we shouldn't have any access to, and then we have more than the desired information, right? So that we can go and continue trying to attack that system. But in this case, so application developers tend to expose everything considering the generic implementation without considering the sensitivity level. They leave the filtration task to the front-end developer before it's displayed to the user. Consequently, an attacker can intercept the response through the API and quickly extract the desired confidential data. The runtime detection tools or general security scanning tools can give an alert on this kind of vulnerability. However, it cannot differentiate between legitimate data that's supposed to be returned or sensitive data. So what an attacker can do, they can sniff the traffic and easily access confidential data, including personal details such as account numbers, phone numbers, access tokens, and a lot more. and the APIs respond with sensitive tokens that can be later on used to make calls on the critical endpoints. So that is a big deal. So what we're going to do, again, we're just going to keep using the same thing, but now we're going to API rule 3 and comment v and then the ID that fetches all the information available for a comment from the database. And Bob assumed that the developer would filter out the information while showing the company's main site. So comment v1 gives us, the Android 12.0, the latitude, the longitude of the person, and their username, etc. So I mean, their device ID gives away some things that we can use for an exploit using Metasploit, for example, because if you know somebody's device ID and version, you can use a Metasploit hack or a Metasploit exploit, that's designed for Android 12.0. Metasploit has so many different device exploits. So you can, as long as you know that, then you can go ahead and try to mess with their device if you have their username or if you find their email address or something like that. The latitude and longitude gives their geolocation, so you could punch this in and see what city or state they're in, what country they're in, and you can get more sensitive information that way. So if we do this against the vulnerable version of the API, we would get the details. If we do it against the secure version of the API, we should get nothing. We should just get their post ID and the actual first post. Notice how the username is also gone in this case. So it just has the text of their first post and just the post ID itself. So never leave sensitive data filtration tasks to the front-end developer. The front-end developer is the person who just builds the GUI and the user interface. The back-end developer is the person who is writing the code and building the code. So ensure time-to-time review of the response from the API to guarantee that it returns only legit data and checks if it poses any security issues. Avoid generic methods such as toString and toJSON, these are Python methods that can be used that will convert something into a string or convert something to a JSON. And they're generic, meaning that they're not only commonly used and can be easily exploited, but they're also easily predictable to see what the results are going to be. There's a lot of stuff. There's a lot of issues with generic methods, and you can even hack the specific method itself to mess something up. I think they call that like a third party. So anyway, using API points testing through various test cases and verifying through automated and manual tests if the API leaks additional data. So these are just some mitigation measures that you can use to make sure that you're securing against information, excessive data exposure that's being released. So we're now going to go to that endpoint and going to go to post ID 2 to try to find their device data. So the endpoint is rule 3, comment v, and then their ID. All right, so their device ID is a BlackBerry for user 2, my bad. So post ID 2. It's an iOS, so it's a Apple phone, or it could be an Apple device in any case. It could be a laptop or pad. iPad. And then the username value for post ID 3, and I was just there too. And here we go. We got user ID is hacker hashtag exclamation. Oops, wrong place. And then, should we use network level devices for controlling excessive data exposure instead of managing it through APIs? I'm going to say no, we should not do that. All right, there we go. Making some good progress here. So let's look at the fourth vulnerability, which is lack of resources and rate limiting. Lack of resources and rate limiting refers to the amount of bandwidth essentially that's being used. So lack of resources means that the web server or the application doesn't have enough resources to support what's happening. Rate limiting means that you don't have a load balancer or you're not limiting the usage of something. So the frequency of the requested resources or the file sizes, which badly affects the API server and leads to a denial of service, meaning the service is no longer available, or non-availability of service. Consider a scenario where the limit is not enforced on the API, so a user, usually an intruder, can upload several gigabyte files simultaneously, or make any number of requests per second, such as API endpoints, and such API endpoints will result in excessive resources utilization and computation and storage, so on and so forth. So a really common example of this is if you're trying to upload something to Google Drive, and recently I actually ran across this. I was trying to upload a file that was like 300 megabytes or something like this. It was a CSV file, and it was a very large data file, and it didn't allow me to do it, so I had to split that file into multiple smaller files using a website called Split CSV, and then I was able to upload the thing. So when you do that, just things like Google or Gmail is also a really good one. When you try to upload something or attach an attachment that's bigger than 25 megabytes to your email, it gives you an automatic thing that says you have to use Drive to do this. And then you have to use a completely separate service, right? And this is all part of load balancing or rate limiting, so that the service itself doesn't crash, and on the receiver side, on your side, so on and so forth. So nowadays attackers use attacks to ensure the non-availability of service for an organization, because it'll cost somebody money. So let's see, how much money does Microsoft make through their website per day? Let's see if we can find that information. So check this out. How crazy is this, right? So Microsoft makes more than $100 million per day, or about $4,600 per second. So if you can crash their website or their systems for a day, you're costing them $100 million per day. How insane is that? If you crash it for a couple of seconds, you're costing them thousands of dollars, which to them might not seem like a big deal. To Microsoft, maybe $100 million in a day isn't that big of a deal, because there's 364 other days that they can make that money back. But that's a really insane attack if you think about it. All you have to do is just like crash their system. You don't even need to have usernames and passwords or anything like that. You just upload a bunch of data that you're not supposed to upload, and large files, and you make a bunch of requests through some kind of a botnet, and then from there you can crash their systems, their website availability for a day, or their server availability for a day, the Azure server availability, or you know what I mean? Like, these types of things don't require usernames and password. It just requires that you understand how to upload massive amounts of data or send massive amounts of traffic to actually crash their systems. And then all of a sudden you cost them $100 million a day, which is insane when you think about it. The attack primarily targets availability, the availability principle of security, because we're doing a denial of service type of an attack. And it can also tarnish the brand's reputation or cause financial loss, right? So obviously, as we discovered, Microsoft can lose $4,600 a second or $100 million a day. So if we use the API here, and we're going to go to Rule 4, which is send OTP, the one-time password, to a vulnerable website, which is going to send a 4-digit numeric code to the user's email address. An authenticated user will use that one-time password to recover the account. And in this case, the company purchased an email marketing plan that does 20,000 emails per month for sending marketing password recovery emails. But Bob realized that he had successfully developed the login API, but there must be a forgot password option that can be used to recover the account. So what we're doing is we're going to send a post request to API Rule 4, send 1TP OTP to the vulnerable endpoint, and then we're going to just send the email for test@gmail, so on and so forth, and it'll send us a message saying that the 4-digit one-time password has been sent through the email. And then if we go ahead and get that information, let's see what this GIF is going to show to us. I see. So if you do it again, it'll say that is this on the secure side? Okay, so on the secure version of the API, it'll say, yeah, okay, we sent it to you, but if you do it again, it'll say you just requested one, so you got to wait 2 minutes. That's what it's doing. So ensure using CAPTCHA to avoid requests from automated scripts and bots. Ensure implementation of a limit. So that's what that whole wait 2 minutes kind of thing is. It's like it's setting a 2-minute limit so that they can't keep sending that request over and over and over again. How often a client can call the API within a specific amount of time. Ensure to define the maximum data size on all the parameters and the payloads, which is the maximum string value, the length of the string, or the number of array elements. So can rate limiting be carried out at the network level through a firewall? I think you can actually do that, yeah. What is the HTTP response code when you send a post request to this secure using the email address, this right here? So let's go and do that. So we're going to send a post request to API rule 4, and it's send 1 TP. Is it for the vulnerable or the secure? On the secure one. Okay. So it's going to be this, and then we're going to send it without a password. So I'm just going to send it for the email, and let's see what we get here. Success is false. The message is invalid email. So it's a 200. So the response code was 200. The message key after sending this using the email address sale@mht. So let's see what the message key in this case is going to be. Oh, you know what? Whoops. I did address HR. So let me actually do @HR by itself and see what that gives us. Well, it also says 200 and it's a invalid email. So let's see what sales@mht is going to give us. It's also 200, invalid email, success is false. So invalid email is for both of those things. And we are now moving on to vulnerability number 5, which is broken function level authorization. Okay, so basically this is what they're talking about, is the function of the person and whether or not somebody in sales, for example, should be able to access the data of an administrator or a domain admin by impersonating that person. So if a complex access control policy with various hierarchies, roles, groups, and a vague separation between regular administrative functions leading to severe authorization flaws, then you have the advantage of these issues. By taking advantage of these issues, the attacker can easily access the unauthorized resources of another user and the functionality of that person, right? So broken function level authorization reflects the EDOR permission, the object something. Man, I can't believe I forget that freaking thing. What is it? The insecure direct object reference. That's what EDOR stands for. God. Okay, so EDOR, insecure direct object reference. I could have just clicked on this, by the way. And, my God. Anyways, most probably an intruder can perform administrative level tasks, and APIs with complex ruler roles and permissions can span the hierarchy, are more prone to this attack. So the attacker can target the authorization and non-repudiation principles of security. Broken functional level authorization can lead an intruder to impersonate an authorized user and let malicious actor get administrative rights to perform sensitive tasks. So if we continue with our API and go to rule number 5, users vulnerable to fetch data of all the employees from the database, and Bob added another layer of security by adding a special header, which is admin in each request. The API only fetches employee information from the database if admin is set to 1, which is true, and authorization token is actually existing. The authorization token for the HR user Alice is this. We might need to use this in a little bit, so I'm just going to copy this. And so there it is. Authorization token admin is set to 1, which is true, and then we are making a GET request to users for rule number 5, and now we have all the users here, and admin is set to 1 right here. So we now, if we looked at the secure version of the website, it's going to be 403 forbidden, and you are not an admin. Even though we set the flag to admin at 1, it still did not allow us to do that. So the secure version of the website apparently has verified that the user that's running this is not actually an admin, even though they have the authorization token and they set the admin header to 1. So ensuring proper design and testing of all authorization systems, and denying all access by default, which is deny all, and then doing an explicit allow, where you explicitly allow specific users to do it. Ensure that the operations are only allowed to users belonging to the authorized group. Make sure that to review API endpoints against flaws regarding functional level authorization, and keep in mind the apps and group hierarchies business logic. So mitigation measures, these are some of the things that we can do. So what's the mobile number for the username Alice? So we're going to end up using this specific thing for user Alice, and then we're going to do set up an isAdmin, and the API endpoint is rule 5 users vulnerable. So let's do that. Okay, there you go. So I had to change this to get, go to the use API rule number 5 at users vulnerable authorization token. I pasted it here. I set the isAdmin to 1 right here, and then we submitted that, and now we have access to all these people right here. And so the mobile number of Alice is right here. Got Alice's info. I got them digits. I got Alice's digits. What you know about that? And is it a good practice to send isAdmin value through the hidden fields to forms, yay or nay? I'm gonna say through the hidden fields in forms. I'm gonna say that is a good practice. Oh, it's not good practice. And so what's the address flag of the username admin? Let's go check that out. There is the flag of the username admin. And this is it. This is the last one, just like this, and we're done with this room. Hey, look at us making progress here. All right, so that was it for the OWASP API security top 10, room 1 or part 1. If you found this information useful, if you found this room useful, this video useful, I would recommend that you go ahead and check the rest of the website out and follow us at Hank Hacks Hackers, and like and subscribe and turn on notification bell, all that stuff. If you click on the search button right here, you get to search through the contents of the website or on the page, the channel. We have over 130 videos right now on ethical hacking and cybersecurity. And I would love to see you in our comment section and as a part of our community. It would be very, very awesome to have you. It's your boy Hank Hackers, and at Hank Hacks Hackers, your favorite network and system attacker / protector. I will see you in the next video. Love, peace, and chicken grease. If no one else loves you, Hank loves you. Talk to you soon. All right, how are you going to identify security misconfiguration? What does a denial of service attack actually mean? And how do you prevent a denial of service attack against your API? And of course, how do you ensure proper logging and monitoring? This does sound kind of boring, but it's actually super important. And these are the things that we're going to be talking about in today's video, which is the part 2 of the OWASP API security sections. And yeah, let's dive into it. This is a really, really fun room, and we're going to wrap this up, and we're going to go on with the rest of our software security modules. All right, as a part 2 to our API security for OWASP, we're just going to jump real quick just for the recap of it. So in the last video, we did the first 5 principles. Now we're going to do the next 5 principles for API security, or the remaining principles. I think it's only 3 actually. So identifying security misconfigurations, preventing denial of service, and ensuring appropriate logging and monitoring. Same prerequisites do apply for this particular room, and the rest of it is pretty simple as far as just getting started with this thing goes. So let's look at the 6th vulnerability here, which is the mass assignment vulnerability. All right, this one's actually not easy for me to grasp. So I'm actually going to read through this because I read through it already, and I just want to reread it just to make sure that I understand it. So mass assignment reflects a scenario where the client-side data is automatically bound with server-side objects or class variables. So client-side data meaning coming from us through our web client or our computer, and it's automatically bound with the server-side objects or class variables. So hackers exploit the feature by first understanding the application's business logic and sending specially crafted data to the server, acquiring administrative access, or inserting tampered data. So they first understand how the logic of the application works. Then they send specially crafted data to the server that will allow them to acquire either privileges or insert tampered data, like poisoning or inserting malicious data. This is widely exploded in the latest frameworks like Laravel, CodeIgniter, etc. And consider a user's profile dashboard where they can update their profile, like their email, name, address, and the username of the user is a read-only attribute and can't be changed. However, a malicious actor can edit the username and submit the form. If necessary filtration is not enabled on the server side, on the model side, it will simply insert and update the data in the database. And so what they can do is they can tamper the data or escalate privileges from a regular user to an admin by doing this. And we're actually going to check out the API website that we used in the last video as well to make some requests here. And so the rule is rule number 6. It's a user, and rule number 6 / user is basically the endpoint, and we're going to be sending post requests. And with the post request, we are going to send, what are we sending here? The table has a credit column with a default value of 50. Users will upgrade their membership to have larger credit value. And Bob has successfully designed the form and used the mass assignment feature in Laravel to store all the incoming data from the client side to the database as shown below. So this is the information that could be sent through the post request. And so the content type itself is the application X form. It's like a form, obviously. There's the name, username, and password, and then the credit parameter that comes default by 50. But then I guess if you know how to manipulate this, then you can give yourself as many credits as you want. And then the response itself will say that it's been created, and it gives you a successful response, including the number of credits that you have in the situation. There's no filtering that's happening on the server side. And the mass assignment feature, it's also inserting credit values in the database, which the hackers and attackers can update for themselves or manipulate that data. So the solution is so that we need to ensure filtering on the server side, which will just be on the endpoint user S for secure, and ensure that the default value of the credit should be inserted as 50, even if more than 50 is received from the client side shown as below. So same thing, there's the updating the same or sending the same type of information, but then once it creates the user, it just keeps their credit value at 50 instead of updating it to 110. So the mitigation for this type of vulnerability is, before using any kind of a framework, we need to understand the backend insertions and updates and how they're carried out. And in Laravel, fillable and guarded arrays are what are used, and so you can mitigate the above scenario by using those types of arrays. And so avoid using functions that bind an input from a client to code variables automatically, and allow list those properties only that need to get updated from the client side. And it's a good practice to is it a good practice to blindly insert and update user provided data in the database? That would be no. And using our secure API, insert a record in the database using the credit value as 1,000, and I already marked it correct because it didn't require any kind of an answer. So what would be the return credit value for performing question 2? I'm just going to guess 50, yeah, because that's what the content said. But we'll actually do that exercise just so we can see kind of what it looks like when you do use the secure endpoint. So I'm going to open this up, and we're going to go into full screen mode just to make it a little bit easier. And it should already load our API emulator for us. And so we're going to API rule 6, user secure. So here we go. Okay, and we're going to make a post request, and this is the content type. And so we're going to create a new, what are the users that we're going to, so name, username, password, and credit. So we'll do name, username, password, and credit, and we'll do sending 1,000. So let's send that. I already created it for us, and our credit was actually 50 instead of 1,000. So that is a secure API endpoint. So very good. Let's move on to the next one, which is going to be the security misconfiguration vulnerability, vulnerability number 7. All right, security misconfiguration basically means incorrect and poorly configured security controls that were placed and implemented, and so it put the entire API at risk. It put the entire security of the API at risk. And a lot of things can end up to this particular vulnerability, including improper or incomplete configurations for your default configurations, and then publicly accessible cloud storage, which is not good. So you don't want publicly accessible cloud storage. It needs to at least be some kind of a hybrid or some kind of a private cloud storage. And then cross-origin resource sharing, which I actually don't know what it is. So let's see what this is. Cross-origin resource sharing is an HTTP header based on the mechanism that allows a server to indicate any origins, which would be the domain or the scheme or the port, other than its own, from which a browser should permit loading resources. So CORS also relies on a mechanism by which browsers make a pre-flight request to the server hosting the cross-origin resource in order to check that the server will permit the actual request. In that pre-flight, the browser sends headers that indicate the HTTP method and headers that will be used in the actual request. The example would be a front-end JavaScript code served from domain whatever using the fetch method to make a request for the data JSON, and browsers restrict cross-origin HTTP requests initiated from scripts. For example, fetch and XML HTTP request follow the same origin policy. This means that a web application using those APIs can only request resources from the same origin that the application was loaded, unless the response from the other origin includes the right CORS headers. So you send a get header to the web server, get layout, you send a get request for the main page, which is what the / is. So you send a get request to the main page of the web server, and then you send a get request for the layout custom style sheet of the web server, and then you get an image from the web server. And the main one, the very basic one, it defines the origin that it needs to be used. And then when you do the get image PNG, should have the same origin request. So it should be coming from this same origin, which is always allowed. Now, if you get the image PNG from a different origin, cross-origin request, which is controlled by, of course, it is not allowed. So that's what this means. So if you have your first request, which is the main page, the original domain name, domaina.com, for example, and everything else that you do on this particular website should be making that same request from that same domain / whatever the other data is, other endpoints or other resources are. And if the request that you're trying to make, so it could be image.png or any name, any file, essentially. You could be using that same file name, but if the base domain itself, the main domain, is not correct, then the cross-origin, the CORS, would be set off and it wouldn't allow you to do it. Sorry for the noise in the background. I have certain people that just roll through my block, and it's so funny. We have like a really basic neighborhood, which is calm and usually normal, no noise happens, and then all of a sudden you have these cars with these mufflers that it feels like the person just added the loud muffler just to be annoying because they're trying to compensate for something, and they just roll through here, and it's the most annoying shit, especially when I'm recording, like, because I know the microphone picks these things up, and I'm like, dude, that's freaking obnoxious. So that's what CORS is. So rereading this piece right here, several factors can result in security misconfiguration, including improper incomplete data configuration, default configuration, publicly accessible cloud storage, the CORS, now that we know what that is, and error messages displayed with sensitive data. Intruders can take advantage of these things to perform detailed reconnaissance and get unauthorized access to the system. Security misconfigurations are usually detected by vulnerability scanners or auditing tools, and thus can be curtailed at the initial level. API documentation, a list of endpoints, error logs must not be publicly accessible to ensure safety against security misconfigurations. Typically, companies deploy security controls like web application firewalls, which are not configured to block undesired requests and attacks. Okay. And the impact would be that these types of misconfigurations can give intruders complete knowledge of the components of the API. First, we can bypass security mechanisms, then stack, trace, or get other detailed errors, and that can provide the malicious actor access to confidential data and essential details, further aiding the intruder in profiling the system and gaining entry. So practical. If we use the same API tester, company MHT is facing serious server availability issues. Therefore, Bob developed an API for Rule 7 for pinging. And so this is the vulnerable ping endpoint. And it shares details regarding the server health and status. He designed the endpoint, however, he forgot to implement any error handling to avoid information leakage. So if we can make a GET request to our local host API Rule 7 using just a ping endpoint, we'll be able to get certain information about the server that we're accessing, including the location of the docs right here, including this specific one is the path to their controller, and the authentication vulnerability object, or the vulnerable authentication object, which is this specific endpoint. And then you have the string, so it shows the value, the size value of this thing, and then it obviously shows the vendor. So there's a lot of information that's being disclosed here. In the case of an unsuccessful call, the server sends a complete stack trace in response containing function names, controller and router information, file path, and we can use all this stuff for profiling and preparing for specific attacks. The solution is to just create an endpoint which is secure, that carries out error handling and only shares desired information. So if we make that same ping request, it doesn't say anything. It literally says success is not successful, so it's false. The network server, yada, 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 and please contact the administrator at this email address for further queries. So limit access to the administrative interfaces for authorized users and disable them for other users. Disable default usernames and passwords for public-facing devices like routers, web application, and routers come with default usernames and passwords. And a lot of times it's like admin. So the username and password is admin, password is admin. It's like, or admin password, something like that, Disable directory listing on set proper permissions for every file and folder. Remove unnecessary pieces of code snippets, error logs, and turn off debugging while the code is in production. So is it an excellent approach to show error logs from the stack trace to general visitors? That is not an excellent approach. What we're going to do is we're going to go to the secure version of API Rule 7 and see what we can get. And let's see. So if we go to Rule 7 and go to ping_s, and instead of doing a post request, we're going to do a GET request. And if we run this, it says 500 internal server error. So it would be 500. And what is the error ID number in the response message? The error ID number in this case is 1401. And there we go. We were able to go through our security misconfiguration. So injection, this is kind of a fun one. So injection vulnerabilities, what is that? Injection attacks are probably among the oldest API web-based attacks and are still being carried out in real-world applications. Injection flaws occur when the input is not filtered and is directly processed by an API, thus enabling the attacker to perform actions without authorization. The injection may come from SQL, operating system commands, extensible markup language, so XML, or various other types of language, JSON, JavaScript, all those things. Frameworks offer functionality to protect against this through automatic sanitization. However, applications built in custom frameworks like PHP, are still susceptible to these types of attacks. So, injection flaws may lead to information disclosure, data loss, denial of service, complete account takeover, and they can cause the intruder to access sensitive data or even create new functionality and perform remote code execution. So, we're now going to go to Rule 8, User Login. And we're making a post request in this case. And this is a very common JavaScript code that essentially says or 1 equals 1, which always ends up sending true. So 1 always equals 1. And you get an authorization key from an account as shown below. So when you submit or 1 equals 1, which would be the password in this case, so it could be the quote right here is ending the previous command that was sent in, which could just be blank or anything else when you get some kind of a response from an API. So when you do that, it ends that the previous block of text or string that came in here. And so it ends that one, and then you say or 1 equals 1, which always ends up being true. 1 always equals 1. So if it's blank or 1 equals 1, then let me in. That's basically what we're saying here. And so in this case, it is blank or 1 equals 1. And if either of those things are true, then we should get access to the system, and we do get access to the system, and we get an authentication key. But if we went to the login secure version of the API endpoint, it says success is false, incorrect username or password, and that's how it should be. So ensure to use a well-known library for client-side input validation. If the framework is not used, all client provided data should be validated first and then filtered and sanitized, and necessary security rules to the web application firewall. Most of these things, most of the time, injection flaws can be mitigated at the network level, and make use of built-in filters like frameworks like Laravel, CodeIgniter to validate and filter data. So can injection attacks be carried out to extract data from the database? Yes, of course. Can injection attacks result in remote code execution? Yes, of course. So what is the HTTP response code if a user enters an invalid username or password? In this particular case, it should be a 5, what is it? What's the response code? Oh, it doesn't show us, so we have to actually do it. So let's go and use the secure endpoint here. So this is API, what is it? It's Rule 8, User Login S. So that's what we're doing. And then we're going to send a post request here, and we'll delete this thing, and we'll delete this thing. And I mean, these shouldn't exist. So if I send it, it'll say 403 forbidden. That's what the code is. So 403 forbidden is the response of the API. All right, so let's move on to the next one, which is improper asset management. Improper asset management happens where you have two versions of an API. So for example, API 1 and API 2, and everything's been switched to version 2, but the previous version was not deleted. So somebody could easily guess that the older version doesn't have the updated or the latest security features because it's old, right? That's why they did the update. So plenty of obsolete features of the version 1 make it possible to find vulnerable scenarios which may lead to data leakage and server takeover via a shared database, because typically when you update things, you only update the security or certain parts of the system, and all of the data gets transferred over exactly the same. So it's essentially about not properly tracking the endpoints, and potential reasons could be incomplete documentation or absence of compliance within the lifecycle of software development, which we're going to get into in the next couple of rooms. And properly maintained up-to-date API inventory and documentation are more critical than hardware-based security controls for an organization. So this is a big deal. The older or the unpatched API versions can allow the people to get unauthorized access or even complete control of our system. And if we look at the vulnerable version of this, so, or the old version, right? So API Rule 9, version 1, user login. It can return more information like balance address something against a user. So if we do Alice with, I don't know if this is a bad password or if their actual password, but if we do this, it sends their information, and I guess we're supposed to actually get that information. That's why they blocked it out. If we do version 2 and try to send that same information, it only sends their username and their ID, which would be all we want. So mitigating this would be access to previously developed sensitive deprecated API calls must be blocked at the network level. APIs developed for research and development, quality assurance, or production must be segregated and hosted on separate servers. And the documentation of all API aspects, including authentication, redirects, errors, the course policy that we just learned, and rate limiting, they need to have documentation of all of those API aspects and adopt open standards to generate documentation automatically. So is it good practice to host all APIs on the same server? That would be no. Make an API call to version 1 with username Alice and that password. So we're going to do that. And what's the amount of balance and what is the country for Alice? So let's copy this password and we're going to rule 9 version 1 user login, and we're going to make a post request. And it's Alice for the username and the password is this thing. Wait, what? I thought I copied this password. There we go. And so we're going to send that information. There we go. $100 or 100 whatever. Well, it's USA, so $100. 100, and the next thing is USA. There we go. Easy money. Now finally, vulnerability 10, insufficient logging and monitoring. All right, as the name implies, when somebody tries to attack your system and when you try to track them, there isn't enough evidence because of there's not logging or monitoring being done, or if it's, it's bad logging and monitoring, whatever, that is a big vulnerability. So a lot of organizations focus only on infrastructure logging, like network events or server logging, but they don't do API logging and monitoring. And information like the visitor's IP address, endpoints accessed, input data, and along with timestamps allows us to identify threat attack patterns. And if logging mechanisms are not in place, it would be challenging to identify the attacker and their details. So the latest web frameworks can automatically log requests at different levels, like the error, the debug, and information levels. And these can be logged in a database or file that can be sent to a SIM like Splunk for detailed analysis. And Splunk will then send you notification if it notices certain types of patterns going in place, and then it says, hey, this looks fishy, check this out, right? So continue to use this thing, and we're going to go to rule 10 logging, and we're going to make a GET request in this particular case, and it gives us our information. So message, abnormal activity has been detected, the IP address is this, the browser is this, which is our user agent in this case, and then timestamp, and all of those things has been logged. So ensure that the SIM system, ensure the use of the SIM for log management, keep track of all denied accesses, failed authentication attempts, and input validation occurs, and format imported by the SIM, and enough detail to identify the intruder, and then handle logs as sensitive data, and ensure their integrity at rest and transit, and implement custom alerts to detect suspicious activities as well. Should the API logs be publicly accessible so that the attacker, no, it should not be publicly accessible. What's the HTTP response code in a successful logging of user information? And I'm going to say 200 because I think that's basically what the success response code is. Yeah. But let's just do it anyway. Why not? Let's actually do this thing. So we're going to make a GET request to rule 10, and logging is the API endpoint, and we're going to send that. And there we go. Hi, an abnormal activity has been detected by you on this thing, yada, yada, yada. So same exact thing, but I already know what a success response or what a response code for a successful request is, because that was a part of the HTTP basics room, right? And there we go, just like that. We finished our OWASP Top 10 Part 2 of the OWASP API Security Room and Module. If you found this information useful, I do invite you to go ahead and like and subscribe and turn on the notification bell and find all the good videos that we have on here. We're currently at 139, and I'm going to be adding 2 more, or actually, I don't know, by the end of this weekend, I'll probably end up adding 5 or 6 more to the publishing queue. So there will be a lot of stuff that you can go and click on search and just start searching through the content and find whatever you need. And the channel is on ethical hacking and cybersecurity. So there's a lot of stuff that you can get access to. And I'm probably going to update this picture as well. This has been around since the very beginning of this, and I like it, but I think it's time for an update. So yeah, that's pretty much it. It would be awesome to see you in the comment section. I do respond to all the comments that come in, and if you have any questions that are pretty juicy, I'll even create a video for you for your comment and question. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video. Later. All right, in today's video, we're going to be answering a lot of really important questions. The first one is, what is SSDLC and what are the different levels and what are the different pieces of SSDLC? And then how do you implement the different parts of SSDLC? It's such a tongue twister to say. And then what is a risk assessment, right? What are the different pieces that go into a risk assessment? What is a threat model? How do you do threat modeling? What's the purpose of threat modeling? What is secure coding? What are the different steps of ensuring that the code of a software is actually secure? What are security assessments? How do you run security assessments? What are the different steps of a security assessment? And what are the various SSDLC methodologies? I almost want to give it away, but I can't, because then it would give away everything else in the video. So, and finally, the last piece of it is that we're going to play a nice little game, and I'm going to open this up and I'm going to close it real quick because I don't want you to see the flag right there. But we get to play a game where it's like an old school arcade game, and we control this rocket that goes through space, and we have to choose the different steps that we're going through just so we can get the flag at the very end. And this is what we're going to be talking about in today's video. So SSDLC, let's talk about it and let's see what we can learn today. All right, the Secure Software Development Lifecycle, SSDLC, is a development lifecycle. It's a testing lifecycle that was done to go through debugging, making sure you find all the flaws, all vulnerabilities, and everything that usually is discovered late in the game, making it much more expensive and time consuming to fix those things. So if you can do it during the development of the software, then you're going to end up saving a lot of time, energy, and money. In a lot of cases, security testing wasn't considered during the testing phase. So the end users would end up reporting bugs after the deployment of the software itself. And so the SSDLC, the Secure Software Development Lifecycle, aims to introduce security at every stage of the software development lifecycle. So the reason why it's so important is the relative cost of everything, right? So if we were to look at this graph that we have here, it says the relative cost of fixing defects during the design phase is 1, and I think it's 1 time. So like 1x essentially. So during the design phase, if you want to fix it, it's 1x the cost. During the implementation phase, it's 6.5 times the cost. During the testing phase, it's 15 times the cost. And then during the maintenance phase is 100 times the cost, which essentially means it's actually running. So if it's in the maintenance phase, it's actually running and operating. And so it's 100 times more expensive to fix something while it's running versus with the 15 times more expensive during the testing phase. Maybe we can kind of zoom in on this and make it a little bit bigger. It's 100 times more expensive to do it during maintenance and operation versus 15 times more expensive during testing, and then literally it's just 1 time as expensive when you do it during the design phase. So it's pretty important. This is a pretty important concept to wrap our heads around. And you may not necessarily want to be a software developer, but you do need to understand how to fix software in the design and implementation and testing phases because of security flaws, specifically security vulnerabilities. and things like that. And this is where we come in. You have to go and partner up with the development team to help them approach the design and implementation and testing phases according to the best security practices. So apart from faster development and low costs, integrating security across the software development lifecycle helps discover and reduce vulnerabilities early on, which reduces the business risk massively. And introducing security at all stages could be architecture analysis during the design, it could be code review and scanners during the development stage, and conducting security assessments, which is penetration testing, before the actual deployment of it. So in a waterfall model, this type of testing is carried out at the end of the life cycle, right before production. And in an agile model, we can implement secure by design, meaning during the design phase, you can start implementing security principles. So if the pen test results in errors like an SQL injection in the waterfall scenario, mitigating the bugs would entail doing another cycle to fix the bug, meaning you got to go from the top again and redo everything. So it requires redesigning, applying the changes, and retesting, and making sure that it's actually been remediated. In the agile model, discussions on whether to prevent flaws such as parameterization during the planning phase can avoid having to roll back and go back to the beginning and then start everything all over again. So agile seems to be the best approach to software development security. So the summary is that it's a constant concern, security is, improving software quality and security constantly, boosting education and awareness is important. Everybody needs to know each phases of the security recommendations and requirements. Flaws are detected early before deployment, reducing the risk. Costs are reduced and speed increases if there is early detection, right? So if there is early detection and resolution, then cost is reduced and speed increases and business risk is reduced. Brand reputation is maintained and there is less damage to it, and fines and punishments and all these things could all be prevented as a result. So the question here is, how much more does it cost to identify vulnerabilities during the testing phase? And we saw over here that it's 15 times more expensive to do it during the testing phase. So that is just an introduction to the secure software development lifecycle room that we're in right now, so that we can actually jump into the implementation of it and everything else. So let's talk about implementing SSDLC. All right, the big part to implementing SSDLC is to understand your security posture. And the first thing that you have to do that is to perform a gap analysis that determines what policies and activities exist in your company and how effective they actually are, and if there's any gaps in between your policies and procedures, and how to fill, what needs to be done to fill in those gaps. So for example, ensuring policies are in place, meaning what the team does, with security procedures, which means how the team executes those specific policies. Then you would create a software security initiative by establishing realistic and achievable goals with specific metrics for success. So you got to measure the actual practical things that somebody can do to make sure that you achieve those goals. And the example of this would be a secure coding standard, playbooks for handling data, and tracking the project management tools or tracking those specific steps using project management tools. And you want to formalize the process. After starting a program, it's essential to spend an operational period helping engineers get familiarized with it and gather feedback before enforcing it. And then when you do a gap analysis, every policy should have defined procedures to make them effective. So when it becomes formal, it means that it's kind of becoming set in stone, and it is now the new procedure that you're going to be implementing from now on. And then you would invest in security training for the engineers, as well as any appropriate tools that would be applied to that, and making sure that people are actually aware of the processes and the tools that will come with those processes to make it operational, and invest in training early on before establishing and onboarding the actual tool that's going to be used. And these are just a few steps in understanding the overall security posture of the company that you're in. And then once you have that, you can look at the overall secure development lifecycle, which is what we're looking at here, right? So this is a big image, and we're going to be referring to this process a lot through the rest of this room, which kind of pretty much just covers like the step-by-step of what's going to be done and how it's going to be done. So during the risk assessment phase, or excuse me, risk assessment is done during the planning phase, and then there's another risk assessment that's done during the defining of the requirements, and then you have threat modeling that's done during the design and prototyping phase, and then you have code scanning and code review that's done during the software development phase, code scanning and review again that's done during the testing of the software. Then you have the secure configuration that's done during deployment, and then security assessments that are done during the operational and maintenance phase of the software development lifecycle. And if we were to look at this and get a little bit more information, because this is important, I really want you to kind of grab this and wrap your head around it. So during risk assessment, which is during the early stages of software development lifecycle, it is essential to identify security considerations that promote a security by design approach when functional requirements are gathered in the planning and requirements stages. So for example, if a user requests a blog entry from a website, the user should not be able to edit the blog or remove unnecessary input from those fields. So this is a risk assessment. This is the risk assessment phase that's done during it's a risk assessment activity that's done during the early stages of SDLC, which is the planning and the defining of the requirements. Then you do threat modeling, and we did a video on threat modeling, so you should go check that out if you haven't seen it already. And threat modeling is the process of identifying potential threats when there's a lack of appropriate safeguards. So if there is not enough safeguards or no safeguards, then you need to be able to identify the threats that are going to happen by modeling what an attacker would do. And it's very effective when following a risk assessment. And during the design stage of SDLC, a threat modeling focuses on what should not happen. And in the opposite of that, in contrast to that, design requirements state how the software would behave and interact. So, for example, ensuring that there's a verification when a user requests their account information. So verifying that the user is who they are. And that's just a simple thing that we do all the time when we're checking our accounts, bank accounts or anything like that. But you don't really think about what had to be done to test those things. And in the last video, we talked about what happened to LinkedIn and a Twitter where they were attacked and information about accounts was released. And these are things that you don't really think about unless you're a security engineer, especially if you're a software developer. Like software developers, I'm sure they have an idea of making sure security is a priority, but they don't see the things that we see. They don't have the perspectives that we do as ethical hackers and penetration testers. So it's important to understand that you need to go into all of these processes with a very, very critical mindset and threat model, or model any kind of threats that could be potential against your specific endpoints or softwares that you're dealing with. So code scanning and review. So code reviews can either be manual or automated. Code scanning or automated code reviews can leverage static and dynamic security testing. Static means that it's just happening while it's sitting there at rest. Dynamic security testing is done while it's running. And these are crucial in the development stages as code is being written. So you look at the code while it's just sitting there, and that would be static code standing, and then you run the code, and then you look at how it performs and how it runs, and during that phase, that would be a dynamic security test that you're looking at what potential vulnerabilities exist. And then you have security assessments. So penetration testing, vulnerability assessments, they're a form of automated testing that can identify critical paths of an application that may lead to exploitation of a vulnerability. These are hypothetical, as the assessment doesn't carry simulations of those attacks. So pen testing, on the other hand, identifies these flaws and attempts to exploit them to demonstrate the validity, the validness. I don't think validness is a word, but the validity of those vulnerabilities. And pen tests and vulnerability assessments are carried out during the operations and maintenance phase of SDLC after a prototype of the application is released. So these are the methodologies that apply to the processes that we're going to be doing in task 5, and it'll help us navigate and understand what we're doing when introducing risk assessment, threat modeling, scanning, and testing and operational assurance. So we're going to be looking at a lot of these things in detail in the next few minutes. So the first question here is, what should you understand before implementing secure software development lifecycle processes? And that is the security posture of the company. And then during which stage would you perform a risk assessment? And it's done during the planning and requirement phases, the early phases of the software development lifecycle, the planning and requirement phases. And then what should be carried out during the design phase? And during the design phase, we're going to be doing threat modeling. So these are some of the questions to just confirm that we wrapped our head around this information. And so now we're going to jump into a risk assessment. What is a risk assessment? And let's see what we can learn here. All right, a risk assessment answers a really big and important question. It's, what's the likelihood of a threat being exploited? What's the likelihood of the impact and the possibility, and how much could it actually affect that resource or the target that is going to be attacked? So you're assessing the risk that's available. So if a vulnerability exploited after a new version of the software is published, or design flaws and poorly reviewed code can increase the risk of these scenarios. So if you publish something new and there is a design flaw in it, or the code wasn't reviewed properly, then the risk is very high in that situation, and that can actually be exploited. So risk management is an important pillar to integrate into software development lifecycle to mitigate risk in a product or service. And when you are doing an assessment, it's very similar to a vulnerability assessment. You're looking at what kind of risk is available in this particular case. How likely is it that we're going to be attacked? That's essentially what that means. So it's used to determine the level of a potential threat, and identifying any risks in that process can be reduced or eliminated by applying appropriate controls during the mitigation process, the risk mitigation process. And usually a risk assessment is followed by threat modeling, which will be explained in our next section. So when you do a risk assessment, the first step is to assume that the software is going to be attacked, and then consider the factors that motivate the attacker. So assume that there is actually going to be an attack. Don't even think that there might not be an attack. There's definitely going to be an attack. And so what would be the factors that would determine what the attack is in that case? So, do you have bank accounts, and would somebody want to transfer money out of those bank accounts? Do you have sensitive data about your intellectual property, and would somebody want to steal your data and use your intellectual property or sell your intellectual property? So what would be the motives behind the attack that would be done against your system, depending on what the process or the function of your system is? And then you would list out the factors such as the data value of the program, the security level of the companies who provides resources that your code depends on if you're using a third-party company, the client's purchasing software, how big is the software distributed? So is it a single, a small work group? Is it a worldwide release? And then based on these things, you write down the acceptable level of the risk. So a data loss may cause the company to lose millions, especially if they require to pay fines with the General Data Protection Regulation by eliminating all the potential security bugs in a code, and it can cost $40,000. So the company and some other stakeholders have decided that if it's worth it or not, and you got to communicate those trade-offs. So if you wanted to fix whatever the vulnerability is that would cause data loss, it would cost $40,000. Is it worth it to spend the $40,000 to fix that thing? Because if you lose the data, or if something happens and there is a privacy issue, you can get fined and you can get sued by your customers for a class action lawsuit, and it can cost a lot more than $40,000. So everyone needs to understand what the risk is and what the implications of that risk are, what the costs are, And then from the perspective of brand reputation, if it causes damage to the company's image or their reputation, it costs the money more, it costs the company more in the long run than spending this little $40,000 to fix the code. So it's very, very important to understand the trade-offs, right? So is it $40,000? It's a lot of money, sure, but compared to millions of dollars, right? In the last video, we talked about how much money Microsoft makes in a day, and they make $100 million in a day. So if there was a glitch in their software and it cost them $40,000 to fix it, would it be worth it? Yeah, absolutely. So these are some of the things that you look at when you're doing a risk assessment, right? So the first step is to understand that you're going to be attacked and then what the motivations of the attack are, and then what is going to be the cost to the company if something like that happens. Then you evaluate the risk. So the next step is to evaluate that risk, like the worst case scenario of what happens. So if they actually do get in and they get into your system and get your data, what is the possible, like the worst possible case scenario that could actually happen? And then you would do this by doing a ransomware attack. That could be one simulation that would give you an idea of what the worst case scenario is. And so what's the value of the data that's being stolen? The user's identity, credentials to gain control of endpoints on your network, or assets and data that pose lower risk, any of those things. Another factor would be to consider the difficulty of a successful attack. If it's easy to attack you, then it's probably really important to fix this. If it's easy to attack you and the data that's at risk is really sensitive, you have to fix it. If it's complicated to attack you and the data is super low value, maybe it's not that big of a deal. But if the data is really big, if its data is really valuable and it's easy to attack you, then you really need to fix that. So if an attacker can get access to your company's tool for giving feedback to colleagues or running retrospective meetings, it would have a low impact than assessing the product environment monitoring and alert systems, right? So if the monitoring and alert systems in your environment are at risk and they're about to be attacked, that is much more critical than the tool that you use to give feedback to your employees. You know what I'm saying? So the high level of risk is not acceptable, and it's best to mitigate it immediately. So a vulnerability that can be exploited by anyone running a pre-written attack script or using botnets to spread scripts to compromise the network, those things need to be fixed immediately. Users affected are a vital factor. So who your company's users being affected, your customers being affected, all of these things are very, very important to consider. And then we have the third step. So some attacks only affect one or two users, but a denial of service attack affects thousands of users. Going back to the Microsoft example, they make $100 million a day. If their website is down, if a denial of service attack is successful against Microsoft, and every day that website is down, it's $100 million that they're losing. A week goes by, that's $700 million that is just lost. That's pretty crazy when you think about it. So thousands of computers may be infected by a spread of worms. The last factor is the accessibility of the target. So if the target accepts requests across a network, or if it accepts local requests, whether the authentication is needed for the connection, or if anybody can do it, these are all variables to consider. And it'll have more of an impact if the attacker accesses a production environment versus a sandbox environment, which is a controlled environment in a local playground that you can't really do much outside of that sandbox. So these are all variables to consider when you are doing a risk assessment, right? So what's going to be the cost to fix it? What is the actual motivation of the attacker? And then you have the worst case scenario of what is actually at risk here. How easy is it to access those things? How complex would the attacker how complex of an attack would they need to run? And then if they do get into your system, what is the actual damage that they can cause? And then who is actually affected? So the users that are affected, is it just going to be one or two users, or would it be thousands of users, millions of users who are affected if something happens? And all of these things are different variables to consider for doing a risk assessment. So you have two general types of risk assessments. You have a qualitative risk assessment and you have a quantitative risk assessment. The most common type is qualitative. And qualitative is when you assess and classify a risk into thresholds like low, medium, and high. And systematically, you examine what can cause the harm, meaning you have some kind of a checklist or some kind of a list of parameters that you use to examine what can cause the harm and what decisions should be made to define or improve control measures. And then all types of risk assessment, there's some kind of a priority level. So high is the most urgent and low is the least urgent. So even though there are no actual numbers associated with this, the formula is very, very simple. The risk itself, the severity of the risk, if it's high, low, medium, it's, the risk itself equals the severity, which is either high, low, or medium, times the likelihood. So how likely is it? How probable is it that we're going to get attacked? And then if we do get attacked, how bad is it? So that's essentially what you're looking at. How probable, how likely is it that we're going to get attacked? And if we do get attacked, how bad will the damage be? And what's going to happen to us if this happens? And then when you have an understanding of that, then you would say that this is an important risk, or if it's not. So if it's really likely that you're going to get attacked and it's really high severity, it's very severe what would happen to you, that's something that you need to address right away. If it's not likely or very, very low likelihood that you're going to get attacked and the severity is low, then it's something that you can probably, accept that risk, right? It's called risk acceptance. That could be something that you could do. So that's qualitative risk assessment. Quantitative risk assessment is used to measure the risk with actual numbers, right? So instead of low, medium, and high, you would actually have numbers that represent what happens in these different categories. And then when you carry out a quantitative risk assessment, when you do something like this, you use tools to determine the severity and likelihood, like a vulnerability scanner, right? It actually gives you, Nessus is like a really popular one. It gives you a quantitative response. It actually is like a combination of quantitative and qualitative. So it'll say, it's high and it's, 8.5 severity kind of a thing. So if, as an example, if we were to use a service with assigned business criticality levels, right? In that case, you can say that if a bug affects a business critical service, so an authentication service, something that verifies who a person is and gets them to log in. If that authentication service gets hit, or the payment infrastructure, the way that you collect payments or the way that you pay people, if one of those things gets affected, then you assign 5 points to one of those things. And this highlights why it's vital to understand the posture of the company and the processes that they use, right? So if you know what different processes that they use, and then you do your risk assessment and you find out that, this particular thing that we use, our payment collection system, it's at risk because you know that there's a payment collection system. So when you know these things, you can actually make the proper judgments. And then measuring risk and priority with the endemic equation to a company's services, and it has really amazing results. So this is what that means, right? So this is the likelihood, right? So if it's really, really certain, so let's see if we can make this a little bit bigger. So the likelihood is right here. So at the very, very top, it's very rare, and the severity is insignificant, has very little impact. So it's a level 1, has not a big deal. You could probably even let that go. But if it's really certain, meaning that it's most likely you're going to get attacked, and the severity is death in this case, so it's really freaking bad, then it's a 25 point risk, which means that you need to take care of that right now. So obviously 25 would be the worst score. 20 is the next one. 16 and 15 are pretty serious and you need to address them. And then the ones in the middle right here, you would do, you meet with the stakeholders, you meet with the executives. Well, I mean, with all of them, you meet with the stakeholders and executives, but the way that you present these things will probably be different. And you say, hey, you know what, this is a level 1. It's really honestly not that big of a deal. You could probably even let it go, but if you want to fix it, we could totally fix it. This is a level 25, and if you don't fix this, you are going to die. Your business is going to crash and burn, and it'll be horrible. So you need to put the proper language and proper wording to make sure that they understand that this is a really big deal and it needs to be fixed. So Risk assessments are better performed at the beginning of software development lifecycle during planning and requirement phases. So if a customer data gets exfiltrated by an attack, that could be one thing. Once the system is developed, you can perform quantitative risk analysis. So one customer can sue for $20,000 if the data gets leaked, and we have 100 customers. So the annual rate of the occurrence is 0.001. So the annual loss expectancy would be 20,000 times 100 customers multiplied by 0.001, which makes it $2,000. That's the worth of this specific risk. And so as long as the company's compensating security control costs less than $2,000, then we're not overspending on security, right? If the cost of this was 200 and the cost for the security control was 2,000, then you'd be like, all right, we'll accept that risk. Does that make sense? So this is how you kind of calculate this whole thing. We also did a video on this to try to calculate the risk of, or the calculating the cost of a risk. And it was actually at the beginning of our security engineer pathway. I think it was in the security risk management. That's where it was. So in the risk management video, so if you can go find that on the channel, you'll see that we'll go and do the risk analysis, where it gives us, again, kind of very similar to what we just looked at, and then it gives us a formula to single loss expectancy, the numeric example of it, and how to calculate the numeric example of something like this. So we actually go pretty deep into this formula that we just used right here to get this value, so that you can understand how much something will hurt if it hits the company, and then how to calculate whether or not it's worth it to fix that thing. So the question is, what is a formula to assign a qualitative risk level? The formula to assign a qualitative risk level is this: risk equals severity times likelihood. And I'm just going to paste that. Or actually, I think I just need to do severity times likelihood. So severity times likelihood. And then which type of risk assessment assigns numerical values to determine the risk? And that is quantitative risk assessment. And there we go. We got our risk assessment out of the way. So now let's talk about threat modeling. Modeling threats. All right, threat modeling is best done. So the best time to do threat modeling is before any code is written. So you model all the threats before you actually write the code, so you can write the code with all of the threats in mind. So threat modeling is a structured process to identify potential threats and prioritize the techniques to mitigate those threats, so that data or assets have been classified as valuable or something like that are taken care of and they're protected. When performed early, it brings a great advantage, which means potential issues can be found early and solved, saving the fixing costs down the line. As we established earlier, right? The earlier you do this, the cheaper it is to fix the stuff. So there are a lot of methods to do this, and not all of these methods have the same purpose, and some of them are more customer focused, some of them are focused on risk or privacy for the company. So we can combine all of those things to understand potential threats better, and it's essential to analyze which aligns more with the project or the business that you're in. And these are some of the models right here. You have Stride, Dread, and Pasta. And again, this was something that we actually did inside of this room. I don't know if it was in this room or if it was in the other one, but we definitely did a video on this because I remember those acronyms, Stride, Dread, and Pasta, and all those things. And so if you want to go find them, you can just look for Stride, Dread, or Pasta inside the channel. So if you go, this is our channel right here, and if you click on search right here, and if I just do Pasta as a search, there you go, threat modeling, simulating real attacks, hacks, and security. So there you go, the threat modeling video will show you everything there is to know about those different approaches. So STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation or escalation of privilege. It's a widely used threat model developed by Microsoft, which evaluates the system's design in a more detailed view. And we can use this to identify threats, including property violated by the threat and the definition of it. And the system's data flow diagram is going to be developed in this model. So each node is applied with the STRIDE model. Identifying security threats is a manual process that tools are not supported and should be carried out during the risk assessment. Using data flow diagrams and integrating STRIDE, the system, entities, attack surfaces like known boundaries and events that become more identifiable. STRIDE stands for spoofing identity, tampering with data, repudiation, information disclosure, denial of service, and elevation of privilege, and it's built upon the CIA triad, which is confidentiality, integrity, and availability. Security professionals that use STRIDE are looking to answer one question, which is what could go wrong with the system? So this is what it is, right? So this is the security development life cycle. So spoofing the identity, implemented in here, tampering with the data, implemented, repudiation, which means can somebody deny that they did this, right? So if they can't deny that they did it, that means you have good repudiation measures in place. But if they can deny it, that means you don't have good repudiation. Repudiation means to deny something. So I didn't do it, and it's like, well, no, we have proof that you did it. We have your username. We have the computer that you used, all that stuff. Disclosing information, which is data exfiltration, data breach, all of that. Denial of service, and an elevation of privileges. So we have another rundown of all these things. So spoofing is impersonating a user, which can be done in a lot of different ways, and it goes through the authentication principle from the CIA triad, and it could be ARP poisoning, so the address resolution protocol, the IP poisoning or IP spoofing, ARP spoofing, and of course DNS spoofing. And then tampering means modifying data, and you're looking at the integrity of the data. How strong is the data? How real is the data? And that's the principle of the CIA triad, that tampering deals with. Repudiation, as we just talked about, not taking responsibility for the events. It violates the principle of non-repudiability. For example, the attacker clears all the logs that could lead to leaving traces. So you can't say we have evidence that you did this, right? That's for repudiation. So not taking responsibility. Information disclosure, so violating confidentiality and data breaches is an example. Denial of service, we've talked about this. They can't access the service, so it goes through the availability principle of the CIA triad. And then elevation and escalation of privileges to gain unauthorized access, and it is for part of the authorization principle of the CIA triad. Then we have DREAD, the DREAD model for threat modeling. And there's 5 major questions, and obviously it's the whole acronym thing. Like these are all acronyms, right? So what is the damage potential? What is reproducibility? How easy is it to reproduce this? How easy is it to exploit this thing? Who are the affected users? And how easy is it to discover what's going on? It's also created by Microsoft, and it can be an add-on to the previous thing that we talked about, which is STRIDE. And it ranks threats by assigning identified threats according to their severity and priority. In other words, it creates a rating system, and it's score-based for their risk probability. So without STRIDE, DREAD can also be used in assessing and analyzing and finding the probability by the threat. And then these are the breakdowns of it. So damage refers to the possible damage that the threat could do. So it's a scale of 0 to 10. 0 means that there's no damage, 5 means information disclosure, 8 means user data is compromised, 9 is internal or administrative data compromised, and 10 means unavailability of a service. Then reproducibility means the complexity of the attack and how easily an attack can replicate and reproduce that threat. 0 means that it's impossible to copy, 5 means it's complex but possible, 7.5 is an authenticated user can do it, and 10 means the attacker can reproduce very quickly without any kind of authentication. Exploitability refers to the sophistication or how easy it is to attack you. 2.5 implies that it requires an advanced skill set to attack you because it's not very easily exploitable, and that means that they need networking skills, programming skills. 5 means that they can use various tools to do it, and 9 means that they need a very simple web application to do it. 10 means they don't need shit. They can do it through a web browser, and they can do it very easily. Affected users is the number of users that are affected by that vulnerability. So 0 means that there's nobody that's affected by this. 2.5 means an individual user could be affected by this. 6 would mean a small group of new users. 9 would mean significant users like admins. And 10 would mean everybody's affected. And discoverability is discovering the vulnerable points in the system. So how easy it is to find out what your vulnerabilities are. The threat would be easily found in a case of compromise. So 0 means that it's very hard to discover it. 5 means that it can be discovered by analyzing HTTP requests. And 8 means it can be easily found and it's public, that you can find it easily. And 10 would mean it's visible in the address bar, meaning the link up here, it's actually visible. And we talked about this in the last video that we did on the EDOR, right? The identifying the insecure direct object. There you go. Insecure direct objects. That's what EDOR would be. And then we have PASTA, so Process Attack Simulation Threat Analysis. And it's risk-centric. It focuses to align technical requirements with business objectives, and involves the threat modeling process for analyzing threats to finding ways to mitigate them. So everything in between as well. And on a strategic level, and the perspective of the attacker is what PASTA kind of looks at. It identifies the threat, enumerates the threat, and then assigns a score to the threat. And it can help anybody, especially the company you work with, you yourself, to find suitable countermeasures to mitigate the threat. And it's divided into 7 stages. So you define the objective, define the technical stage, decompose the application, analyze the threat, find the vulnerabilities and weaknesses, model the attacks, and then risk and impact analysis. So during define objectives, the first stage, you just look at the structure and defining the objectives of the attack. And it makes the end goal a whole lot easier to understand, and ensures that the relevant assets are threat modeled. So whatever you need to actually attack, you model your threat around that. And then the defining of the technical scope is where you look at the logical and physical infrastructure to see what can be done. So mapping the attack surface and any dependencies from the environment, and then decomposing and analysis. So each asset will have defined trust boundary that encompasses its components and the data in it, and mapping the threat vectors for a payment service, and evaluating which components underlying the service can be leveraged for an attack. And components can be libraries, dependencies, modules, or any service that's attached. All of those things could be found during the decomposition analysis stage. And then you have the analysis of the threat. I can't believe I'm like mispronouncing these things. Threat analysis. So it's the looking at the extracted information from threat intelligence, and then used to identify which application is vulnerable and which vectors are used to attack it. So a customer or public-facing application can be susceptible to distributed denial of service and unauthorized data alteration, stuff like that. Then you have the vulnerabilities and weakness analysis, which looks at the web application's vulnerabilities and their security controls, and looks at, finds security flaws in the application, looks at the vulnerabilities and lists them, and it's highly recommended to add mitigation to the identified threat in this stage. So when you actually find out what the vulnerabilities and the weaknesses are, you try to list mitigations for it. So when you describe a past incident involving the exploit of a mail server, and then you learn some kind of lesson or mitigation from it, the thorough testing before implementation or hardening the server, all of these things could be examples that you found from previous analysis. And now if you found them, you add the mitigation immediately and you say, this is how we're going to fix this. And attack, exploit, enumeration, and modeling. We look at the possible threat landscape and the attack surface of the application. We then look at all the attack vectors and the different nodes that could be attacked, identifying the exploits that could be used, all the attack paths that could be taken, and it simulates all the enumerated information that's been extracted from all the previous steps, and it helps security professionals determine the extent and probability of successfully launching identified vulnerabilities, and lastly, the impact of the risk. So analyzing that based on the data from the previous stages. All the scoped assets that have been affected are analyzed, and finally, based upon risk analysis, recommended steps to mitigate the risk and eliminate all the residual risks, and then documenting all of those things during the last phase right here. So what threat modeling methodology assigns a rating system based on the probability of the risk. And so based on the probability of the risk, I think it's going to be the stride, right? I think it's dread. Yeah, it is dread. So the dread model right here tells us what can be done based on probability. So in other words, it creates a rating system that is scored based on risk probability. That's the dread model. What model methodology is built upon the CIA triad? And that is the first one that we were looking at, which is the stride model. Oops, there we go. And then what threat modeling methodology helps align technical requirements with the business objectives? And this is the one, I believe, align technical requirements with business objectives is PASTA's goal right here. So PASTA. Every time I do this, I really crave pasta because I just keep saying pasta. So there we go. That was our threat modeling. So now let's look at secure coding. According to Verizon and research that they did in 2020, 43% of data breaches were on web applications, and everything else or some other security breaches resulted from vulnerabilities in the web applications. So there was attacks on the web applications and then vulnerabilities in the web applications. So looking at secure code review in the phases of secure software development lifecycle, especially during the implementation phase, will increase resilience and security of the product without bearing any additional cost for future patches. So secure code review is defined as a measure where the code itself is verified and validated to ensure probabilities. I mean, the name itself, just secure code review, kind of implies that we're going to be looking at the code itself. So it requires that you understand code at the very least, or you need to understand how to ask questions about the code. So it's important to just understand coding and finding out how you can mitigate and remove those vulnerabilities and flaws. So having the developers be aware and proactive in reviewing the code during development can result in faster mitigation responses and fewer unattended threats. Reviewing code is a crucial step for developers, and it prevents any setbacks on the release and issues exposed to the users. As shown in our previous task, the cost of the project itself and effort to put in are cheaper in the long run than the cost of applying code reviews and analysis. So by implementing this approach, the organization will also be compliant with the standards set by government bodies and certifications. It can either be done manually or automatically. Manual code review is where the expert analyzes the check and secure code by going line by line to identify vulnerabilities. And it's a high quality manual code review that requires the expert to communicate with the software developer to get hold of the purpose and functionalities of the application, and the analysis output will then be reported to the developers if there's anything for bug fixing. And then we have code analysis techniques, right? So static analysis examines the code without running it. Dynamic analysis looks at the code when the program is running. And static analysis detects bugs at the implementation level, and dynamic analysis detects errors during the program running. And automatic static application security testing, which is SAST, so static application security testing is SAST, automatically analyzes and checks the source code. So static application security testing, it's a white box testing method that directly analyzes the source code. White box means that you have everything that you need to know and you have permission to do it, and so you are essentially analyzing the code. Many people tend to develop an application that could automate or execute processes quickly and improve performance and user experience, thereby forgetting the negative impact an application that lacks during that thing could cause. So why is it static? Because the test is done before an application is live and running. So You can help run all these things before the code is actually merged or integrated into the software and before you run it. So it's important to do this. It's important to do both, right? So you want to do static testing and then you want to do dynamic testing. So static testing uses a testing methodology of analyzing a source code to detect any traces of vulnerabilities that could provide a backdoor for an attacker, and usually analyzes and scans an application before the code is compiled. The process of SAST, static testing, is also known as white box testing, and once a vulnerability is detected, the line of action is to check the code and patch the code before the code is compiled and deployed. White box testing is an approach method that testers use to test the inner structure and how it integrates with external systems. Then you have a bonus, which is SCA right here. So software composition analysis is used to scan source code for vulnerabilities, which is SAST. And another type of testing that goes along with this is SCA, so software composition analysis. And it's used to scan dependencies for security vulnerabilities, meaning libraries that you would use or external tools that you would use. And it helps the development team track and analyze any open source component that's been brought into the project. And it's now an essential pillar in security testing because modern applications are increasingly composed of open source code and code that you can get from GitHub, for example, right? So nowadays, one of the biggest challenges developer teams have is ensuring that their code base is secure as applications are assembled from different building blocks. Then we have dynamic application security testing, which is a black box testing method that finds vulnerabilities during runtime, and a tool to scan any web application to find security vulnerabilities, and it's used to detect vulnerabilities inside the application that has been deployed to production. So it's after it's actually been released and deployed and compiled, right? So DAST tools will always send alerts to the security team assigned for immediate remediation. And it works by simulating an automated attack on the application, mimicking the attacker. And the goal is to find unexpected outcomes or results that the attacker could use to compromise the application. And since these tools don't have internal information about the application or the source code, they just attack the same way that a hacker would, with the same limited knowledge and information, which is why they call it black box. So white boxes, you know everything. Black boxes, you don't know everything. And so you're just attacking everything that you possibly can. And DAST is a tool that can be integrated very early into the software development lifecycle. Its focus is to help organizations reduce and protect against the risk that the application could cause. It's very different from SAST because DAST uses black box and it conducts vulnerability assessments outside since it doesn't have access to the source code. And it's typically used during the testing phase of software development lifecycle. Then you have IAST, which is interactive, and it analyzes the code for security vulnerabilities while it's running. It's usually deployed side by side with the main application on the application server, and it's an application security tool designed for web and mobile applications to detect and report issues while running. Before somebody can fully comprehend the understanding, the person must know SAST and DAST. So IAST was developed to stop all the limitations in both SAST and DAST, and it uses gray box testing, which is a combination of white box and black box. And it's you both know and don't know, right? So you know everything, as well as meaning that the code, the tool itself is looking at the source code as well as attacking it from the outside as if it doesn't know. And it occurs in real time while the application is running, and it can identify the line of code that is causing the security issues because it has access to the code, and it offers remediation. It checks the source code, but the post-build stage like SAST, which occurs during development, but at the post-build stage, So it looks at the source code, but at the post-build stage, meaning it's already been compiled and it's being deployed. And agents, IAST agents, are typically deployed by the application server. When the DAST scanner performs its work by reporting vulnerability, the deployed IAST agent will now return a line number of the issue with the actual code itself. And the IAST agents on the application server can actually be deployed during functional testing by a quality assurance tester. The agent studies every pattern that the data transfer inside the application follows, regardless of whether or not it's dangerous. And if the data is coming from a user and the user wants to perform SQL injection by appending an SQL query to a request. The request will be flagged as dangerous. So RASP stands for Runtime Application Self-Protection, and it's integrated into the application to analyze inward and outward traffic and end user behavior to prevent security attacks. And it's different from everything else because it's more security focused when compared to the other tools that are known for testing. So it's actually looking at security issues. And it's deployed to a web application next to the main application while running to monitor and analyze the inward and outward traffic immediately. If an issue is found, the alert is sent to the security team and immediately blocks access to whoever's making that request, essentially acting kind of like as an intrusion protection system almost. And when you deploy this, it'll secure the whole application against different attacks, and it does not just wait to try to rely on specific signatures of known vulnerabilities. It's a complete solution. So RASP is a complete solution that observes every detail of the different attacks and knows the application's behavior. When you want to choose a tool, it's complementary. So it's not like you just choose one thing. So DAST identifies runtime issues, right? SAST is identifying vulnerabilities while the code is being written. DAST looks at application responding to an attack, providing insight. AST enables DevSecOps and supports continuous testing, monitoring, assessment. IAST helps prioritize and alert the vital critical risks. And then all of these things, again, could just be compiled together. They could be complementary. They could be used, all of them. You don't have to just use one. That's kind of the big point here. It's like, I mean, there's no reason, there's nobody putting a rule in place saying that you just have to use one of these things. So if you were to look at it in the timeline of the development of the software, this is what you would do at the very, very beginning while you're developing the software. During the development phase, you would do SAST and SCA, and then during integration, you would do SCA, and then when you're going through acceptance, you would do SAST and DAST, so the static and dynamic, while you're trying to finalize and accept the thing. And then before putting it into production and actually sending it out, you would do all of them, so static, dynamic, and integrated. And then finally you would do RASP, which is the runtime application. So during runtime, it does self-protection. So it's a good thing to kind of have an understanding of, that you would do static while it's being developed. You look at source code analysis while it's being developed. While you're being integrated, you look at source code analysis. While you're trying to accept whether or not this thing is actually going to be sent into compiling and production, you would now start doing dynamic analysis, and you run the code in a controlled environment, as well as static analysis. And then right before it actually goes into production and it's live and running, you would do all of them. You would do static, dynamic, and the combination of the two. And then finally, while it's actually running, you do runtime analysis. And none of these things are limited, right? So it's like you can use all of them. So here are our questions. So is it recommended to use SAST, static analysis, at the beginning of the lifecycle? And yes, it is recommended to use this at the beginning of the lifecycle. Which type of code analysis uses the black box method? And that would be dynamic, so DAST. And then which type of code analysis uses the white box method? And that is SAST, static analysis, because you get to actually see the source code and you see what you're attacking. So let's look at security assessments now. All right, so security assessment, as the name implies, is we're looking at potential security vulnerabilities of the software that's being deployed. And usually this is either a penetration test or some kind of a vulnerability assessment, or probably both, right? So a company employs and authorizes external security testers to attempt to break into a network and systems legally. So you give them permission to penetrate your systems. That's a pen test. And you typically hire a company or a person that really specializes in that. And that's actually what I'm trying to be. That's just super fun, in my opinion, to just get paid to attack somebody. It's the greatest thing ever. So the first thing, like the basic thing, is to just do a vulnerability assessment to find vulnerabilities. You don't validate them or try to attack them. Typically, you just look something, you use a tool like Nessus or something. OpenVAS is Open Vulnerability Assessment Scanner, Nessus, which is, like, I guess has been renamed to Tenable. And then the ISS scanner. These are just scanners that attack your ports, or they don't attack your ports, they scan your ports and services on the system to just find vulnerabilities. And there are other things that can be done, which is service versions of something against the database of vulnerabilities. And the result is a report with a list of the vulnerabilities. And you have typically high, medium, low, which is quantitative, or an actual CVSS score. So Nessus actually does both. So it gives you high, medium, low quantitative, as well as the CVSS score, the Common Vulnerability Scoring System score. So, like, 8.5 or something, you know what I mean? Penetration testing is where you actually attack the thing. So you do a vulnerability scan. As you're doing penetration testing, you'll do a vulnerability scan. And then once you have the vulnerabilities, you actually try to attack them and penetrate them. So trying to escalate privileges after a vulnerability is found. Some vulnerabilities can be lower risk and can be used to leverage to cause more damage. And the tester can provide a thorough report with suggested countermeasures to mitigate the vulnerabilities. And it makes it easier to just understand the perspective of the attacker, because that's literally the job of a pen tester, is to attack the system as if they were the hacker. So the pros and cons of the two are as such. So vulnerability assessments, it's quick identifying because you're just running a scanner. It's part of a pen test, so it's literally as if you were going to run the pen test. And if you're limited on a budget, you just run the pen test, like you just run a vulnerability scan and you have an idea of what's going on. What the con is that typically there's a big report that comes out of this thing, and it depends on the tool that you're using. So when you use an open source tool, you probably won't get as much as if you used a paid enterprise tool. Then the real life scenarios for those vulnerabilities aren't actually considered. So if it's a low risk vulnerability, so this is what we were talking about right here. So a vulnerability can be a lower risk vulnerability, but it can be used as leverage to cause more damage. And that's what the job of a pen tester is they look at the vulnerability and they're like, oh, this, I can kind of get my, dip my toe in the pool, so to speak, with this little vulnerability. But if I do, then I get access to these other vulnerabilities and I can actually attack the system. And a vulnerability scanner doesn't do that. A vulnerability assessment doesn't do that. They just show you, hey, this is kind of low risk or whatever. But the pen tester looks at that same vulnerability and is like, you know what I could do with this? I could do this, this, and this after I take advantage of this thing, and now I'm in their system and now I'm doing some serious damage. So that's the pro of a pen test, right? So the tester shows organizations what an attacker can do. That's what a pen tester does. The vulnerabilities could be used against that organization by the attacker, the actual risk, right? With that little thing that you think is not a big deal, it can actually be leveraged by a pen tester. And then you can show all of the results that you got to the customer, but it can be expensive because you have to actually hire somebody to do this. And pen testers get paid a lot of money, buddy. Requires extensive planning and time to carry out. So it actually does take time to do it. And a lot of times pen testing, like a real big pen testing against a company, does physical pen tests as well as logical digital network pen tests, meaning like they'll try to actually get into your building. They'll send somebody to pose as, a honeypot or something. Like there's so many things that you can do to do a pen test. A really good show for this is Mr. Robot. If you haven't seen it, it actually has like very good examples of what a pen test would be and how you can attack an organization in a lot of different ways, social engineering attacks, everything. So they cover all the bases in Mr. Robot. Really great show. So now, which form of assessment is more budget friendly, which is the vulnerability assessment? And which type of assessment identifies vulnerabilities and attempts to exploit them, and that is a penetration test, or penetration testing, I guess. When do you typically carry out vulnerability assessments or pen tests? And we would do this during, let's see. So it says we would do it at the end of the software development lifecycle and the operations and maintenance phase. So let's see if that's actually the answer. And it is operation and maintenance is the phase. And just like that, we have looked at security assessment. So now let's look at security software development lifecycle methodologies. All right, before you do any of this stuff, you need to first build with security in mind, and you need to introduce testing focused on security, okay? So you need to test with focus on security, and you need to build with security in mind. If you are doing those things, if you have those two prerequisites, then you can look at the methodologies for the software development lifecycle, and then you can look at SSDL, which the first S stands for the secure software development lifecycle. So Microsoft Security Development Lifecycle has it's a methodology for SSDL. The OWASP Top 10, which were the last three videos actually. We did an overview of the OWASP Top 10, then we did API Security Parts 1 and 2, which should be live. By the time that you see this video, those two things will be live. They're already scheduled to come out. And then we have software security touchpoints. These are methodologies for SSDL, Secure Software Development Lifecycle. Microsoft SDL is secure by design, so it focuses on the whole software lifecycle by design, so from the very beginning. Security by default, software systems are constructed to minimize potential harm caused by attackers, meaning the software is deployed with the least necessary privilege, so trust no one, right? Secure in deployment, which means after you've actually, or while you're running it, it's accompanied by tools and guidance supporting users and administrators, and of course communication. So developers are prepared for occurring threats by communicating openly and timely with users and administrators. This is Microsoft's security development lifecycle. It's a collection of mandatory security activities that are grouped by traditional development lifecycle phases, and it's collected to assess training effectiveness, and metrics in the process are used to confirm the compliance of the process, post-release metrics for future changes, and there's a heavy emphasis on understanding the cause and effect of security vulnerabilities. And the development team must complete the mandatory security activities to comply with Microsoft's security development process. And you can implement this by these following practices, all right? So I'm not going to read all of these details right here. You're more than welcome to pause this and read this, but you want to provide training, you want to define security requirements, define metrics and compliance reporting, perform threat modeling, establish design requirements, and define and use cryptography standards, which is encryption standards, and then manage the security risk of using third-party components. If you're using open source components, if you're using somebody else's code, even if you're buying the code and it's not open source, you just want to make sure that you understand what the vulnerability of those third-party components are as well. Use approved tools, perform security testing, which the stuff that we just talked about, perform security assessments like vulnerability assessments and pen testing, and establish a standard incident response process. So formal response process, just in case anything happens, what are you going to do? What's the series of steps you're going to take? Then we have the OWASP's software security development lifecycle. And it's a collection of mandatory security activities, again, by traditional software development phases. Data is collected, in-process metrics are used, post-release metrics are used. They place heavy emphasis on understanding the cause and effect, and a development team must complete the 16 mandatory security activities to comply with the Microsoft SDL process. So that's actually a part of OWASP's process as well. And this is what it looks like over here, where you have the high level of security analysis, security risk analysis, base training, and agreement and priority. So the project definition is all gate 1. And then you have the controls selection, which is the before you actually design. So the preliminary design, the initial design, so to speak. Then you have the security design review, where you're actually looking at the source code itself. You're doing the static analysis of the code. And then you have pen testing, which is once it's actually up and running and you're doing deployment, and you hire somebody to come and attack the software itself. And OWASP aims to build security quality gates to support quality and secure software made through the pipeline. and they actually use Microsoft security development as well as their own series of processes as well. So the main question that they're trying to answer is how well are we doing and where do we want to get to? So where are we at right now and what's the goal? How secure do we want to be? And this is a great questions to ask. OWASP is a very big organization when it comes down to this specific process. So another critical security model is building security in maturity. And then it's a study of real-world software security and reflects the current state of software security, and it can be described as the measuring stick to understand your security posture by providing a comparison of other companies, and then you compare yourself to them. So it doesn't tell you what you should do, but rather what you're doing wrong. And there's hundreds of organizations that are actually involved in this, and we can go check it out here. So it's part of the OWASP process as well. So this is actually part of OWASP as well. So now, here are the questions here. So what methodology follows a set of mandatory procedures embedded in SSDLC? And it is Microsoft, what is it, SDL, SCL, or SDL? There you go. What maturity model helps you measure tailored risks facing your organization? What maturity model? Oh, interesting. All right, it's actually inside the paragraph that I skimmed over. So the maturity model, there's a couple in here. So we have OWASP's SAM, so Software Assurance Maturity Model, and that's the one that's actually used to tailor the organization's specific risks. So SAM is going to be the answer for this one. And then which one is used as a measuring stick? And this is the one that I actually did read, which is the BSIMM. So BSIMM is the measuring stick to determine the security posture, that they tell you what you're doing wrong, but not what you should actually do. And so now I think we actually get to do an actual exercise here. So we have the secure space lifecycle where we're going to view a website and try to retrieve a flag. So let's go through this thing and have some fun. All right, here we go. So secure space lifecycle. We need you to help to get S2D2 out into space. The only way we can do this is by flying the rocket through the correct security stage portals of the software development lifecycle. Use the left and right cursor keys to move your spaceship. I get to play a game. This is cool. Okay, so let's see. Where I kind of want to zoom in. I feel like I should, but let's see if. Oh no! Oh no! Wait! No! Damn it! I forgot. I'm trying to get settled here, man. Okay, all right, so the first one. What security procedure would you choose for the planning and requirements stage? Okay, so we're going to use the left and right arrows. No. Okay. What security procedure would you choose for the design and prototyping stage? Prototyping design would be threat. No? All right, here we go. I feel like this is the one. This is the one. We're going to win this one. This is the one. Okay, first one, planning and requirement, you do risk assessment or risk management. And then what would you do during design and prototyping? You would do threat modeling during design and prototyping. And then what would you do software testing? The first step of software testing is going to be SAST, okay? And then the second part of software testing, so SAST was static, which is the first part. The second one is DAST, which is dynamic. And then the third part of the software testing is going to be the code review itself, okay? And then we're going to do the first part of developing operations and maintenance, which is going to be the security configurations, so security config. And then the second part of this would be the assessment, security assessment. That's it. Okay, thank God. And that was the last question. My God, I did that so many times. That's so fucking crazy. Okay, so there we go. Do a barrel roll. Let's see if this actually copy paste for us. There we go. Do a barrel roll. That's it. And we got it. Ladies and gentlemen, that was That was so annoying. No, but we won. I mean, we won the game. At least they made it a game, so it was kind of fun. Now I noticed this guy right here, freaking Chewie. Now I know why this thing was here the whole time. Or, you know, they can't use Chewie Star Wars, so they had somebody that kind of looks like Chewie. Anyways, that was it for Secure Software Development Life Cycle. And we can move on to our next video for the next one, which is going to, we're actually making some pretty good progress here, which is SAST for Static Application Security Testing. And then we have Dynamic Application Security Testing, Weaponizing Vulnerabilities, so on and so forth. So we're making good progress here, but that was it for Secure Software Development Lifecycle. All right, if you got any value from this video, or if you want to get more videos like this one, make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. We are currently on 140 videos, and it's going to keep going. I'm telling you, there's videos already that have been scheduled to publish, and we're just going to keep going and going and going. So if you found any value from this, I do invite you to join our community, and I do respond to all the comments, so make sure you drop all your questions in the comments. We would love to see you in the comments. And yeah, it would just be really awesome to have you as part of the community. What is SAST, and what the hell does it have to do with software security? What are the different types of static analysis? I kind of gave it away. We have the manual code review and the automated code review. What does that even mean? What are the code review tools? For example, SemGrep that we're going to talk about, and as well as Psalm that we're going to be talking about. So we're actually going to go through some of these code development tools, and then from there, we're going to actually analyze some code. This looks pretty freaking intimidating if you don't understand code or anything like that. So I hope you actually do stick around with us, because we're going to learn a lot of good stuff in our video today. All right, SAST, Static Application Security Testing, is the subject of the video today, and this is going to be our outline here. So we got the intro, the code review, manual code review, automated code review, rechecking the application with SAST tools, and SAST in the development life cycle, the development cycle. So let's jump into this stuff. In order to actually pull this off, there's some prerequisites that you need. So you need to understand what vulnerabilities are, as shown in the OWASP Top 10. And there's obviously a room for OWASP Top 10, and of course a video attached to the OWASP Top 10 that's already on the channel, so you can go check that out. Then there's the OWASP Top 10. I guess these are, what is it? The various rooms for it. Yeah, so there's both of these. So there's the regular OWASP Top 10 video that we did, and then there's the API security parts 1 and 2 that is also available for the OWASP Top 10. So you need to know all of those things. You need to know web vulnerabilities, all the API stuff, as well as just a general understanding of the OWASP Top 10, and then just a basic understanding of software development lifecycle, which there's also a video of that, so you can go check that out if you want to. The SDLC room is what we did the video on. Not this particular room, but it was a part of the process that we did right here, the secure software development lifecycle. We already did this particular room. So as long as you understand what those things are, you should be good. If you haven't seen those videos, I would recommend that you go check those out before continuing on with this one, because we're specifically going to be talking about static application security, and we've touched on static application security and dynamic application security, as well as the kind of like the hybrid version of both of those things in previous videos. So in this one, we're going to be doing a little bit more of a deep dive into static application security testing, and these are our objectives, just to learn how we can apply SAST to find weaknesses in real-world applications, the pros and cons of using static testing, as well as how we can implement it in a development life cycle. So that's kind of the overview of what we're going to be talking about in this room. So let's talk about code review in a general aspect, in like a general approach, what code review is, before we go into manual versus automated. All right, code review. I mean, it's kind of common sense to think about. If you're looking to secure an application, you want to first look at the code itself. And when you have access to the source code, it's considered to be a white box approach, meaning you actually have access to the source code so you can analyze the source code. If it was black box, you don't have access to the source code, but you can attack the application itself and try to, find different vulnerabilities for the application. But when you have the code, it's considered to be white box. So when you have access to it, you can really go into the nitty gritty, like the deep dive into everything about the code itself, about the application, and kind of look at it behind the scenes or under the hood, so to speak, just so you can see really where a lot of vulnerabilities may be without having to spend time testing or pen testing. And as we covered in previous videos, a cost of a defect or a cost of a vulnerability gets significantly higher as you go through the software development lifecycle. So if you catch it early on, it's obviously much better to be able to do. And static application security testing is done in the design and coding phases. And then when you go from coding to testing between these things, now you start doing dynamic, meaning the code itself needs to run. The application is going to be running and you're going to be doing dynamic testing. And then when it's fully running and you're in maintenance mode or operation mode, then it's going to be the most expensive to fix any kind of a defect if you discover it at that time. So it's best to do a really, really good job in these initial two phases so that you keep the costs low, right? So then to be able to pull that off, we need to be able to use manual and automated tools. And manual code review, as the name implies, is you sitting down line by line and reading the code and trying to find specific vulnerabilities in the code. Obviously, it requires that you understand code and you know what the hell you're doing. Otherwise, it'll be kind of useless for you to try to do manual review. And if you don't understand code, then the next best thing is to use an automated tool to be able to find those common vulnerabilities for you so that you can go ahead and try to find secure approaches to it or try to find patches to it. Even if you understand code, it would just save you a lot of time if you actually use these automated tools instead of doing it line by line. But I mean, I would say a good security engineer or a good software developer that's focused on security would do both of those things. So there's a lot of stuff, especially if it's like a really big application, there's a lot of stuff that a human can miss. So it's almost mandatory, I would say, to use a lot of the automated tools and probably some of the ones that we're going to be talking about in this video as well, to use those tools to catch the things that you may have missed and just speed up the process so that you can more focus on remediations and fixing of the vulnerabilities instead of trying to find the vulnerabilities. So that's a really, really big deal. We have a couple of questions for this particular section where it says, is automated code review a substitute for manual reviewing? That would be no. So you do want to also manually review because you can also be looking at the source code from a different perspective, from a different lens that maybe the tool that you're using isn't looking at that code with. So that's a very, very important thing to understand. And then what kind of review is going to run faster? Obviously, it's the automated review. And what would be more thorough? That would be the manual review because you're going line by line looking for different vulnerabilities. So that's code review is as a whole. So let's look at manual code review. Just to give us an idea of what manual code review actually looks like, there's a machine that we're going to be using for this room with some of the source code inside of this specific folder. That's essentially what all of this, these couple of paragraphs at the top are saying right here. And it looks like we're going to be looking at SQL injection vulnerabilities. So to be able to find SQL injection, first you need to understand what SQL is, which is a query language. It's a structured query language for managing databases. And so there's a database engine, which is MySQL, and then the function inside of that engine are as such. And when you're inside of the specific folder, so we're going to change our directory into this folder, we're going to search for MySQL query inside of this specific file that we have just to see what we can find. And the options that we're using here R is for recursive searching, that goes and searches through all of the files that are inside that directory instead of just one specific file. And then the N option indicates that we want to find the number of the line that the pattern that we are looking for is in. And so when you run for something like that, you can see that there's a single instance of this specific string that we're searching for. Anything that's inside of the quotations is what we're looking for. And it's found on line 18, as it implies right here. So database.php is the file. Inside of database.php on line 18, the result variable has this thing, right? So when you understand that context, then you can kind of do more thorough of a review. That was the word that they were using. So if we actually open up this file, then we get to look at some of the deeper the pieces of it, just so we can see what's going on inside of it. And this is a lot of stuff. So instead of reading through this, I'm literally just going to go start that machine, and we're going to start reading through each one of these things piece by piece, line by line, so that we can actually look at the code directly instead of looking at various instances of the code. And our machine is up right here, so I'm just going to open up this terminal, and we're going to cd into this specific directory first. And there we go. So if we do a list function, a simple ls, it'll show us all the stuff that's inside of this thing. So what we want to do now is we want to search while we're in here. We want to just run the search query that they had right here, right? The grep search query. And there we go. It gives us exactly that result, right? So we were able to grep for that specific string, and it told us that, you know, inside of the db.php file, which is this file right here, we were able to find the variable that has that string that we were looking for. So easy enough to do a search like that. So if we actually go open this freaking file now, so I'm gonna do, let's see if I can do nano, probably db.php. It should be able to open that file for me, and there it is. And it's going to be on line 18. So assuming that this is line 1 at the top right here, 2, 3, 4, 5, 6. There you go, 18. Line 18 is result MySQL query, yada, yada, yada. And that's what it is. And it's inside of this function for DB query. And it shows us some interesting things about it. And it's literally the only thing that's inside of this piece right here. And as we just saw, the MySQL query string that we were searching for is nested inside of this function right here that does a database query. So if we do a search for DB query, it'll show us all of the files that is inside of, which in this case is hiddenpanel.php on lines 7, 20, and 23, and attached to these variables. So it shows us that it's doing a query against the database query itself. So, it's showing us that it's doing the database query inside of these hidden panels that are inside of this particular application. It's not as the name implies, it's not a visible panel. And these database queries are attached to the various result variables. So we can analyze the context of each of them, starting with the line on, or the call on line 7, and the one on line 7, which is the very first one right here, for the first result variable. It's saying select ID, first name, last name from my guests, where the ID has the equal of this particular string right here, which is the guest ID, right? So what's going to happen in this case is, I guess this particular one, it was an SQL injection, because they're doing a query. They're doing an actual query right here where they're trying to pull the information of this thing. So it says whatever is passed in the guest ID parameter via the get method, that's right here, is going to be concatenated to a raw SQL query without any input sanitization, enabling the attacker to change the query. And this particular piece right here is where if you sanitize the input inside an application, what you can prevent from happening is from somebody actually doing their own version of an SQL query inside of your application to try to pull data. So when you sanitize input, it doesn't allow them to use SQL queries. If you don't sanitize the input, then they can put whatever they want in it. And then they can make any kind of a command, in this particular case, getting the guest IDs for all of the guest IDs. It's going to get all of the first name, last name, and IDs for those things. So it's kind of important to do the input sanitization piece right here. If we do a similar process for the other two types or the other two uses of the database query that we found on lines 20 and 23, we'll find these results right here. And in this particular case, ID log text from logs, where the ID is this particular, actually no, this is a regular expressions parameter right here, and they're getting the log ID for that specific piece. And in this one, it's the ID name from this particular table, where the ID has these regular expressions, so it's just numeric characters. This one is alphanumeric, as you can see right here. This is just numeric characters, and they're getting the art ID. So if we were to look at their explanation here, so on SQL2, which is this piece right here, is passed through a filter that only allows characters that are either alphanumeric or double quotes. While double quotes may seem like a possible vector for SQL injection, they don't pose a threat in this case, since the SQL sentence encloses the string passed through the get method between single quotes. An attacker would have no way to escape from the string in the SQL sentence. We can be sure that this line is not a vulnerable line. And this is kind of getting like advanced. This room is technically an intermediate room. It's no longer a beginner room or an easy room. And you would need to understand how SQL injection works and how SQL poisoning works to be able to really understand what this sentence means. So if we're going to break it down a little bit more, if we were to review it just one more time and kind of take our time with it. So the alphanumeric or double quotes is this piece right here. So you have alphanumeric right here, separated by a comma or double quotes. So these are the two sets of characters that could be replaced, right? So reg, replace. And so in this particular case, it's saying the characters are either alphanumeric or double quotes, while double quotes may seem like a possible vector for SQL injection, because you can use double quotes to separate comments or commands, specifically not comments. You can separate commands using double quotes. They don't pose a threat in this case, since the SQL sentence encloses the string passed through the log ID. So the SQL sentence encloses the string, meaning in this particular case, it's been enclosed, and the get log ID command right here has been already enclosed with the quote, the single quote, right? So you have the quote right here, then there's a double quote, and this whole thing inside of this double quote goes all the way. So let's see, it goes all the way to here, and then you have another single quote that closes that out for us. So it's an interesting to consider, right? So you have single quote, double quote, and it goes all the way, and then you have double quote, single quote. So this is the entire piece right here. And so since this piece is all enclosed inside of the sentence, you have this last quote that matches this first quote. And so this full thing is a complete sentence, I guess, in this particular case. That's how they're referring to it. So it's a complete sentence. And so since the quotations are set up correctly and everything's designed in this query correctly, it's not a vulnerable query. So that's what we need to understand. So a single character could ruin an entire line of code. If you've done any kind of coding, literally a comma in the wrong place or a quotation in the wrong place can break the entire query or the entire software or the program, the script that you're running, whatever it is, a single character could destroy everything. So as long as you have all that stuff figured out and designed correctly, if the syntax is designed correctly, you should be fine. So in this case, they don't pose a threat in this case, since the SQL sentence encloses the string that's passed through this thing between single quotes. Since the attacker would have no way to escape from the string in this sentence, they can be sure that this is invulnerable. And to escape from a string, you would use either a single quote or a double quote to be able to run some kind of an injection attack. That's what escape means, and it's done through the usage of quotes at the end of a specific query. So if this was not a secure query or a secure sentence, you can escape it. So for example, if this last quote was missing right here, you could be able to escape this whole thing using the quotations, and then after this, you can run your own injection attack after the fact. And it seems complicated. It is complicated, honestly. If you really do need to understand PHP and SQL languages to kind of understand what just happened there. But the more you watch something like this and the more you do exercises like this, the easier your head will wrap around concepts like this. So it's not easy if this is your first time looking at it, which is why it's important to watch all the preceding videos to this kind of video. But if you do understand PHP and if you do understand SQL, you should understand what we just talked about. The query on SQL3 is even more restrictive, allowing only numeric characters to go through the get art ID, and the preg replace function is called with a third parameter that is set to 1. If we refer to the manual page of the function, we will learn that the third parameter indicates the maximum number of replacements that can be done. Since it's set to 1, only the first character that isn't a number will be replaced with an empty string. Any other character that are passed through it without being replaced enable SQL injection. This is a vulnerable string. So only the first character that is not a number will be replaced with an empty string. Any other character that are passed without being replaced can be any kind of SQL injection that you can have, which makes this specific variable, in this case, it makes this one vulnerable. And that's it for our manual reviewing. This particular application was a very straightforward one, a very basic application. A real application is going to have a lot more files and many more lines of code, therefore making it much more complicated. But it should be pretty obvious that manually reviewing large code bases can quickly become tedious, obviously, just based on what we just went through, especially if you don't understand PHP languages or SQL or anything like that. It just becomes a big pain in the ass, honestly. So what we're going to do is we're going to go and use some nice tools to automate some of these things for us. So there's a bonus exercise here that says using manual code review to find out the type of vulnerabilities in the provider project. The following questions will guide you through it. So locate file inclusion, LFI attacks, local file inclusion LFI attacks are made possible by the misuse of one of the following functions in PHP. So require, include, require once, include once. Answer the following questions using grep to search for LFI vulnerabilities only on the .php files in the directory HTML for our project. So what we're going to do is we're going to search for those particular strings, I guess, which of the mentioned functions is used in the project, include the parentheses at the end of the function name. So I'm just going to create another grep command here, and we're just going to search for these various things. So let's see what we can find. Okay, so that one returned a result for us, and let's just go and do require as well. Oh, that one returned a result for us too. So require returned a big ass result, and so did include in this particular case. Um, wow, look at that. Yeah, so I am going to run the include one more time because I think the include one was the only one that gave us the PHP files right here. So it's login PHP, gallery PHP, hidden panel, view, so on and so forth. So the include, let's see if that is indeed the one. Yep, that is the one. So how many instances of the function found in question 2 exist in the source code? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 instances. And of only one of the function instances is vulnerable to local file inclusion. Remember that for LFIL to be present, the attacker must be able to manipulate a part of what is sent to the function. So the vulnerable instance must contain some reference to a get or post parameter or manipulate inputs. Which file contains the vulnerable instance? So what we're looking for is something that has a reference to a get or post parameter in the input, and what line in the file is vulnerable to LFI. So I am going to now search through each one of these files. It's going to take me a minute, but I will go ahead and edit that out, and from there we'll try to find our specific file. Okay, so actually just kind of skipping through the manual search of everything, it's asking us to find the one that is, it has a get command inside of it, and none of these, with the exception of this one specific file, have a get command inside of it. So this actually makes it a little bit easier for us to search for this. So that's actually the view.php file, and the line of that is line 22. And just like that, we were able to find the answer. I kind of cheated because I looked at the phrasing of the question, and they kind of gave us the answer inside of the phrasing of the question. We were supposed to look for this get request right here, and none of these have a get request other than one particular line. So that one kind of made it a little bit easy, so we can kind of cheat that one. So now let's go actually into our automated code review so that we can actually use some of these tools to make this process a little bit easier for us. Okay, so here's where it's going to get a little bit interesting. We're going to be using automated tools, right? Static Application Security Testing, SAST, refers to using automated tools for code analysis. It's not to replace manual code review, but to provide a simple method to automate simple code checks and quickly find vulnerabilities. It complements other techniques such as dynamic application security testing, which is going to be our next video, or software composition analysis, and to provide a holistic approach to application security during the development lifecycle, because this is the cheapest part of the lifecycle to fix any kind of a problem. Just as with any other technique, it has its pros and cons. So pros, it doesn't require running instance of the target application, so you don't have to run it. It's great coverage for the application's functionality. It runs fast, and as opposed to other dynamic techniques, which means you're running the application itself. The tools report exactly where vulnerabilities are in the code, and they're easy to integrate in your CI or CD pipeline. And the cons are source code of an application is not always available if you're using a third-party app for analysis. For example, if you're trying to find security vulnerabilities, so you can't always find source code. It's prone to false positives, as with any other type of assessment. You can't identify vulnerabilities that are dynamic in nature, meaning it requires for the app to be running to be able to find those vulnerabilities. And SAST tools are mostly language specific. They can only check languages that they know. So if you want to check PHP, you need to have a PHP tool. If you want to check Python, you need to have a Python tool, so on and so forth. Under the hood, so while most of the tools are different, or every tool is different, most of them will perform two main tasks: transform the code into an abstract model and analyze the abstract model for security issues. So instead of you just having to look at lines of code and trying to find it inside lines of code, it's going to transform the code into a model that is relatively easier to work with compared to just looking at source code. and they represent the code using something called the abstract syntax trees, AST. But some tools may have other equivalent properties. This allows for easier code analysis. It's crucial for later analysis, as many features of programming language that isn't correctly translated into AST will probably not be analyzed for security issues effectively. And then once it has the abstract model, it'll analyze it for security issues. During this particular room, we're not going to be going into modeling in detail because this is a really big topic. You could do an entire course on this topic. So we're going to be looking at specific analysis techniques that are commonly used by static analysis tools. So semantic analysis, it's a type of analysis that is compared to grepping, meaning searching, for potentially insecure functions while doing manual code reviews. It aims to find flaws concerning the use of potentially insecure code. Examples of this includes what we did when we searched for this specific query piece where the get or post parameters are directly concatenated into the query string, and this was the result that we got. Or not this wasn't the result that we got, but it was similar to what we got when we ran it. Then you have the data flow analysis, and where these are situations where potentially dangerous functions are actually in use, but it's not clear whether or not a vulnerability is present just by analyzing the local context around the function. So this particular function, which was the big function that, I think this was the first one actually, when we did the grep for this particular piece, it brought us this entire function, or it brought us this line, excuse me. And then when we looked at the db.php file, we saw that that was the function that it was nested in. By looking at the code, it's hard to say that there are any vulnerabilities. So we had to do a second search for this piece, and then we found the file that actually had the vulnerabilities. Data flow analysis is going to trace how information flows from inputs that the user can manipulate to potentially vulnerable functions, just as we did when we manually analyzed the provided application code. In data flow analysis terminology, data inputs will be referred to as sources, and potentially vulnerable functions will be referred to as sinks. And if data flows from a source to a sink without sanitization, then we have a vulnerability. Going back to the DB query, data flow analysis would have to find all of the usages and trace it back to any tainted input, which is the source, to see if anything is sent to it, and it ends up as part of the query executed by MySQL query, which is the sink. So this is the source and this is the sink. And then this is what it will look like in the actual URL of the API or the application itself. So the guest ID equals 1 tainted runs to the SQL variable, which is also tainted, which runs to the database query, which is also tainted, which runs to the MySQL query. And this is literally going through the whole thing that we found. It's actually in a previous task, so I'm not going to go. You can just kind of review back. You can go back in the video to find it, but it was that original source code that we found, that it was doing a query to find the guest IDs and pull the ID, the first name, last name, so on and so forth for that. And so if somebody goes to the API of the application and at the end of the call just puts guest ID equals 1 for whoever this person is, it's going to pull all that information from that guest ID, because none of these things were sanitized, and being all of them are tainted. So opposite of sanitized is that it's tainted. And then it pulls the information that the person would want, the attacker. Then we have control flow analysis. It analyzes the order of operations in the code in search for race conditions, use of uninitialized variables or resource leaks. As an example, we look at this piece of Java code right here, and if the command property isn't identified, the call to system get property will return null, meaning nothing. Calling the trim method from a null variable will throw an exception on runtime. So this thing, calling this on this is going to throw an exception on runtime. So during the runtime, it's actually going to run an exception. And oh, you know what? I just noticed that there's also these nice little icons that I guess represent all of these things. So semantics would be searching specifically for each individual line of code. The data flow, as the funnel implies, we're going through the flow of the data. Control flow would be going from this to this to this. And if it's not defined, if CMD is not defined, it's going to return null. So if, for example, if this isn't defined, then this will return null, I guess. Or if this isn't, I'm not understanding this part actually. I don't know which flow where that runs through. And then you have structural analysis, which seems to be the most complete. It analyzes specific code structures of each programming language, and it includes following best practices. We're declaring classes, evaluating code blocks that we never execute, which is dead code, correctly using try and catch blocks, and other issues related to using insecure cryptographic material, which could be weak keys or IVs. IVs, I wonder what that stands for. So this is a piece of code that would be detected by structural analysis. And in this case, we have an implementation of an RSA with a key size of 1024. So this is the, I think it's real secure algorithm. That may be the wrong breakdown of that acronym. But the key size is 1024 and considered insufficient by today's standards because there's much larger keys, much more secure cryptographic algorithms. So this would be the entire piece. So you have the entire thing that's going to come from structural analysis. And then the configuration analysis goes and looks at configuration files. So searching for an application configuration flaw rather than the code itself. As an example, applications running under Internet Information Services will have a configuration called web config. PHP will hold all the configuration options in a file called PHP ini, and most applications will use some configuration file. By checking configurations, the tool will identify possible improvements. Here's an example of 2 configuration directives in PHP that would probably raise an alert on SAST tools as they facilitate some attack vectors for remote file, RFI, SSRF, server-side request forgery. I know that what that is. Remote file inclusion. I want to say that might be that. And so let's see. Allow URL include on, allow URL fopen on. These are some configurations, some permissions that may trigger or trigger an alert inside of the SAST tool. So not every SAST tool will implement all the analysis techniques that we discussed, but it's good to have them as a reference to compare different solutions that exist, meaning different tools that exist. So some of these questions, I don't think we have to look at any code. I think it's just based on the material that we just read. So does SAST require running an instance of the application for analysis? It does not. What kind of analysis would likely flag dead code segments? And that's going to be this particular one, which is the structural analysis that looks at dead code. And so we're going to go over here. And what kind of analysis would likely detect flaws in configuration files, which is configuration analysis. And finally, what kind of analysis is similar to grepping the code, which is the very, very first one at the top right here, which is semantic analysis. All right, there we go. We got our automated code review. So now we can kind of go through, I would hope, the tools that we're going to be using and do some actual code review using tools. And yeah, we're about to use a couple of these tools, and we're going to be going through the simple app folder that's on our desktop in this practice machine. So Psalm, PHP static analysis linting machine. It's so funny, like almost everything in cybersecurity is an acronym for something else. And I wonder what came first. Did the acronym come first and then this thing came up first? It's just it's so funny. Sometimes they're like, dude, they had to design this whole name just so it can turn out to be this kind of acronym because it seems just too convenient for the names to be matching. Anyways, whatever. So we're going to use Psalm, which is a PHP tool, as the name itself just implies. It's already installed on our machine, which is nice. You can always go ahead and download it or use their website to download it. We're going to go to the project's directory, and the Psalm XML file is going to be at the root of the project, and this is the config file, which I guess is going to be the one that we're going to be working with. Error level resolved from config file, the XMLNS domain or the URL for it, or the XSI, and then this is the root XMLNS. XSI schema location is at that URL. Find unused baseline directory, yes. And then the project files are going to be going for everything inside of the HTML directory, I believe, and the vendor directory. So we're not going to go too deep into this, but you can see that the error level parameter, which indicates how strict the Psalm is going to be running with issues, the lower the value, the more issues will be reported. There's also a section called project files where the files to be scanned are indicated, which we already established. So we're going to be going inside of the simple web app, not the HTML folder that we were already in. And then we're going to run Psalm. And from there, we should be able to get some kind of error, I guess, and see what we'll find. It's going to only run structural analysis over the code and shows us programming errors that need our attention. In the previous example, it reports the condition on the if clause is always false. In this case, the programmer mistakenly used the assignment operator equals instead of the comparison operator, since the assignment operator always returns the assigned value. So it's basically saying that instead of checking to see if something is false, it's going to actually assign it as that value. So that's not good in this case. Since the assignment operator always returns the value, 0 in this case, the condition will always evaluate as false, and it'll automatically cast to false in PHP. So it's supposed to use a comparison operator, not an assignment operator. The default test will search for issues with variable types, variable initialization, and other safe coding patterns. While these are not vulnerabilities, it'll make recommendations so the code follows coding best practices, which is always good. It also offers the possibility to run data flow analysis using the taint analysis flag. And the output for this is going to be much more interesting because it's going to pinpoint security issues, which is always a good thing. And this is what it will look like in this case. So tainted include, detected tainted code passed to include or similar, the get no known location, get image, concatenated, yada yada yada. For each error reported, Psalm will show you a complete trace of the data from the source get to the sync function include. Oh, good. Okay, that's what that looks like. Okay, so this whole thing is one thing right here. We have a typical local file inclusion vulnerability, and the get parameter image is concatenated directly into the file name passed in the include function. Data flow analysis usually gets the most interesting findings from a security standpoint. However, other structural findings are equally important to fix, even if they don't directly translate into an exploitable vulnerability. So structural flaws can often lead to business logic errors, and it's going to be cost intensive. So it's going to be expensive to fix. That's probably an easier way of saying it. It may not necessarily be a security vulnerability, but it can crash at some point, or it can be a pain in the ass, really. False positives and false negatives. So a false positive is a vulnerability that doesn't actually exist, that was assumed to exist, and so you got a false positive, meaning that this is a vulnerability, you need to go check this out, and it was never a vulnerability. A false negative means that there is an actual vulnerability and it was never brought up by the tool. So when you have situations like this, I would say it's just best to use multiple tools against some source code to see which one catches what thing and which one misses, So they may present themselves, the tool can't correctly process it, so they can also be introduced if we don't use the tool correctly. As a quick example, when we manually review the code, we found 3 possible instances of injection. Still, we discarded one of them as a character filtering, and leaving us with 2 confirmed SQL injection vulnerabilities. If we check SOM's output, we notice that only a single instance is reported. The first one, lines 6 to 7 of the hidden panel, which means that there was a false negative. So since it didn't detect one of the vulnerabilities that we found manually, that means it gave us a false negative in this particular case. So let's comment out lines 6 and 7 hidden in the panel and see what happens. And by commenting, it's not Python, so you would have to comment with the /. And if you do that, we should have no more errors. However, if we execute, it says that now it'll report a different tainted SQL error corresponding to one of the 2 queries. So let's see, hidden panel PHP 1987, hidden panel PHP 665. So it's showing us a completely different one. And why didn't it? That's actually my question too. It's like, so why didn't it detect it the first time around? It can be found if you check the first line of both errors. Both show line 18 of DB as the source of the problem. For some vulnerabilities, they're the same and related to how you call MySQL query on line 18 of DB. In other words, it expects you to apply a fix on the DB file as well, as it doesn't understand the code. Defines DB query as a wrapper to any database queries. Before continuing, make sure to uncomment 6 and 7, and which is this particular line right here, these 2 lines. We can use annotations to give us more context. DB query should be considered a sink, so we get an error if any tainted input reaches that via the query parameter. To do so, add the following comment on top of the DB query, which defines what's going on right here. So this comment it explains, right? So the SOM taint sync is SQL query and SOM taint specialize. Annotation tells SOM to check the query parameter for tainted inputs of the SQL. Now SOM will issue a tainted SQL error every time a tainted input reaches the database query. We also need to add the SOM taint specialize to tell SOM that each invocation of the function should be treated as a separate issue, and it depends entirely on the input that it receives. So you would get both of them separately, and after rerunning it, we should get all of the instances as expected, and now you have a much bigger result. Look at that. So you'll get a 3rd error repeating on one of the previous ones because MySQL inquiry is still considered a valid sync. SOM's has a built-in list of default syncs, so you should still have the original alert on top of the new ones. And if we compare the results with the manual review, you'll notice that there are some differences. So manual review, these various parameters we've established as this type of a result. SOM made this one. So this one was the same. And this one, in this case, is a false positive because SOM said that it was vulnerable when we determined that it wasn't vulnerable. And in this one, it said that it's not vulnerable when we determined that it is vulnerable. So therefore, this was a false positive and this was a false negative. A certain level of false positive and negatives are always expected. As with any other tool, you must manually check the report for any errors. SAST is an excellent complement to manual reviews, but should never be considered as the replacement of a manual review. In my humble opinion, this is really, like, you really need to understand coding. This can't be done by somebody who doesn't understand coding and various coding languages. There's, as they mentioned right here, you can't just assume, you can't use specific tools as a replacement for manual reviews. You need to be able to understand the language enough that you can manually review something, specifically in these situations too. Because it's one thing for SOM or any tool to say that this is a vulnerability and it ends up being a false positive. It's a whole other thing for it to not detect a vulnerability and it says, oh yeah, there's no problems here, and then there's actually some kind of a weakness there, and then you miss it because you don't understand the code, and that ends up being a big hazard down the line. So question, what type of errors occur when the tool reports a vulnerability that isn't present in the code? That would be a false positive. And how many errors are reported after annotating the code as instructed in this task and rerunning SOM? So we actually have to do that. So let's go and check this out right here. Just based on this output right here that we got on our screen, I'm gonna just venture a guess of 2 because I only saw 2. And let's see, that is incorrect. So we actually have to go and annotate this thing, and from there try to find that answer. So let me go and do some of that work. I just read through it instead of doing the code itself. So let's do the exercise. Okay, so actually just running the very first piece right here, we can see that there is definitely much more, many more results that came out than the stuff that we see on the screen. And it actually shows us right here that there are 9 errors that were found when I just ran this very basic command at the top right here. So now let's make some modifications to this to see what we can find specifically for the annotation. So I'm going to go to the portion with the annotation, and from there we are going to find the answer to our question. Okay, so before making the annotation, actually I want to do a test of the results just to see what we're going to get. So I'm going to run the command, and I'm going to do no cache, and then we're going to use taint analysis, and let's see what we get here. So we got 7 errors that were found without making the annotation. So now that we have this result, now I'm going to go and make the annotation inside of the db.php file right here. So let's go inside of the HTML directory, and we're going to nano into our db.php file, and we're going to come down to the portion where we want to make the annotation right there. So here we go. I'm going to create a new line, and here we go. Okay, there we go. That's all I got. So SOM taint sync SQL query, SOM taint specialized, SOM taint sync SQL query, and SOM taint specialized. There is our annotation. So now what we're going to do is we're going to save this, and we're going to exit out, and then we're going to run our command one more time actually. So I need to get out of this directory and go to the last directory, and then we're going to run our command one more time with the taint analysis. Let's see what we get. Okay, so last time we got 7, and this time we got 9. So let's see if 9 is the answer. And it is. Look at that. We figured it out. We got it. Just to give you guys a heads up, I am not great at PHP coding. The coding languages that I'm most fluent with are HTML, XML, and Python. PHP is a learning curve for me. I can conceptually wrap my head around what's being talked about here, but I just want to kind of be transparent and honest with you. I really, there's a lot of stuff that I still need to learn about PHP, which is why I mentioned at the very beginning, or not the very beginning, at least previously, maybe a few minutes ago, 5-10 minutes ago, that it's important to understand the language itself. Otherwise, you're going to miss a lot of possible vulnerabilities. So that was that. So now we're just going to look at static analysis in the development lifecycle as a whole. Static analysis is one of the first tools to appear during the development lifecycle, meaning during the coding stage, because you don't need to have a functional application to use it. You don't need to be able to run the application because you're literally just looking at the source code. And this is the secure software development lifecycle. We already did a video on this, so you can go check that out. It goes into much further detail than what we're just going to be covering right here. But These are the phases of the secure software development lifecycle. You have 8 specific phases: the development phase right here, and then the operation phase right here. And depending on the case-by-case situation, depending on what your specific software is and the application and what you're going to be doing, it can be implemented in one of 2 ways. So you have the CI/CD integration. Each time a pull request or a merge is made, the tool is going to check the code for vulnerabilities, and checking pull requests ensures that the code that makes it to merges has gone through at least a basic security check. On some occasions, instead of checking every single request, executing SAST scans only at merges can help prevent slowdowns in the development pipeline, because it avoids making all developers wait for the full scan. Then there's the IDE integration. Tools can be integrated into the developer's favorite IDE instead of waiting for a pull request. This way the code can be fixed as early as possible, saving the time further ahead of the project. And one of the greatest things that you can see, for example, I'm going to actually pull up PyCharm, because PyCharm is an IDE. And what it does, and let's see, I'll just open up a file here. We'll do this one, whatever. We'll just open up this one. Let's see. I need to open it. I need to bring it onto our screen here. So we're going to bring it over here. And here we go. So this is our tool, right? What the recommendation right here, the IDE integration. What this does, and this is for Python language specifically. This is not for PHP. But what you'll see here is that there are these little squiggly lines that are underneath all of these pieces, and none of these things are really big errors, okay? So if I make a big error, so let's just right here, I'll do print error. You see how there's a red line under it? That is a real problem. That's something that, and then especially when we go here and then this little light bulb pops up and it says import this name locally, create a parameter called error, rename it, so on and so forth. So it actually does real-time problem resolution for you if you have made some kind of an error, right? So if I want to go to reference what? If I want to reference, let's say, this thing, I'll just reference this list. So if I want to reference that list for myself, I can do the proper, and this is another cool thing, is that it'll like help you autofill these things for you, right? So you can either give you the thing that you're looking for, but if I misspell it, it'll again give me some kind of an error, and then it's not going to run, and it's going to say, hey, you need to fix this, and then you click on the light bulb and it says create it or rename it, so on and so forth. So this is what it means when they say integrate with an IDE. PyCharm is an IDE for Python and also for a lot of other types of documents. So you can work with CSV documents, you can work with text documents, you can work with HTML documents, so on and so forth. So it's not just inclusive to Python itself, but it's designed for Python specifically. And it'll help you do problem resolution and error resolution in real time. So what you can do is you can integrate various tools for PyCharm. So you can integrate a tool for Python. Let's see, we can actually even search for that just to see. Okay, look at this. Just a simple Google search, right? So I searched for Python SAST tools that can integrate with PyCharm. And then right there, the Google AI found this for us. So we have PyLint. By installing PyLint via the command line, you have Codana, you have Bandit, SemGrep, so on and so forth. And I actually might start using these things just for my own coding exercises as well, because it's useful. It's useful to have something that'll be like, hey, you might need to check your code for whatever, and it integrates with your IDE, so you don't have to make a request, as they said right here. So a pull request. You don't need to make a pull request to check the code for any kind of errors. It can just do it as you're developing your code. So I think that's very useful. That's kind of cool. And I would recommend you do it as well if you're thinking about going into software security and checking source code and stuff like that. I would highly recommend that you do something like that as well. So you may want SAST running on both the developer's IDE and your CI/CD pipeline, which would be valid, and CI, continuous integration and continuous development. That's what those things stand for. Yeah, there you go. Okay, so you may want SAST running on both the developer's IDEs and your own pipeline, which should be valid. For example, the tools may run basic structural checks or enforce secure coding guidelines, while the integrations may run more time consuming data flow taint analysis, and your specific setup will depend on what you actually need. We can go to the DAST room, which is the very next room that we're going to be doing. So that'll just be in the next video. For example, integrating a DAST tool into a Jenkins pipeline, and it's pretty similar, so we're not going to repeat any of those things in this particular video. Integrating SAST in IDE, so you have SOM that can be integrated, you have semgrep, and I think semgrep was also one of the things that showed up in our Google search that can be integrated. Let's see, directly from the marketplace. There it is. So I'm actually going to open this up in a new tab. It usually opens it up in a new tab for us, but this time it didn't. And now we're stuck with our window looking all kinds of busted. So I got to get out of this and then get myself a position where I can zoom back out. So let's see. Okay, here we go. And then we're just going to open this up in a new tab. And this is the semgrep website if you wanted to use semgrep to integrate into your IDE. And this is the one for SOM. And the tools will work similarly by showing any problem detected directly in line with your code. And look at this. This looks very similar to what we just saw on PyCharm, right? So it actually shows you the errors in each file. It shows you where they are, and it gives the same type of red squiggly line to help you notice where the error is. And then if you click on it, it'll actually give you the breakdown of the error so that you can go ahead and fix it. We can also check the complete set of issues by clicking the errors indicator right here, and it gives you all of your stuff in a line by line format, a line item, and it's right here. Python also has the same thing. So let's see if I can go back to my file. Did I already close my file? I think I already closed the file. But Python actually has a very similar, PyCharm, excuse me. PyCharm also has a very similar thing right here where it gives you this little button that you can click on that will show you all the errors and all the potential errors and all the really bad errors. So having the IDE check for problems allows you to produce cleaner code as a developer, contributing significantly to the overall security of the final application. Using both of these, we can go ahead and answer the questions right here. So I guess we actually have to go ahead and try to figure this out. So for this task question, we'll analyze the old version of Reci.php, a small open source app. Before continuing, make sure to open the Code Workplace icon on the desktop. It'll open a VS Code Workplace and where the project is. So on the desktop, let's see what we're looking for. Okay, so I opened this inside a new window because it would be too much if we tried to look at it in half the window. And it did take a few minutes to load. So if you're doing this on your own, you got to give it a couple of minutes to fully load everything. And here's the number of problems right here. So it says there are 27 total problems that have been detected in our workspace. So now how many problems are detected in the show recipe inc PHP file? So let's go and find that one, which is right here, show recipe inc PHP. And there are 8 problems in that file. And so we're going to open it, and there are 2 types of problems being reported. One is identified as tainted SQL string and refers to the SQL injections. What other problem identifiers are reported? With write the ID reported by semgrep. So we're going to open this particular file, And inside of this thing, we have these things. And so let's see, we're looking at the ID. And so let's see. I see. So this one right here, this is the semgrep tainted SQL string. And so in this case, semgrep echoed request would be the other one. So we're going to type that in. And what type of vulnerability is associated with the problem identifier on the previous question? What type of vulnerability is associated with it? And the vulnerability is cross-site scripting. So that is our vulnerability that is associated with the echoed request. Look at that. Just like that, we just finished our room here. So not bad. This was pretty informative. And I personally learned a lot. I think I actually have to go through this a couple of times just to really wrap my head around it. And I'm glad I actually got a chance to record this video. These videos, believe it or not, these videos help me just as much as they help you. So I hope you found this useful, honestly. If you did find it useful, I would very much love for you to join our community. Our community has actually been growing pretty steadily, and honestly, I'm really happy about it because it just in the last day or two, we got a large surge of subscribers that came in just because of some of the compilation videos that have come out. So I'm very happy to see the community is actually growing. I would love to have you as a part of the community, and I answer all the comments that come in, and if they're really robust comments, I do make videos to respond to those comments. So it would be amazing to have you as a part of our community, and I really hope that you get a lot of value out of it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video. Later. What is DAST, Dynamic Application Security Testing? What is that? What do you do when you do dynamic application security testing? What are spiders and crawlers? How do you scan for vulnerabilities? Authenticated scans, checking APIs with ZAP. What is ZAP even? And we actually have it right here. So we have ZAP, the attack proxy, which is an open source tool, and we're going to learn all about this tool and how to actually use it. And then we're going to learn about the documentation for scanning with ZAP and using Jenkins and a bunch of cool things to actually get some really good information for you for dynamic application security testing, which is actually a very big deal when it comes down to the software development lifecycle. So I hope you're excited for it. This is going to be a really good one, and let's jump into it. All right, DAST stands for Dynamic Application Security Testing, and it is the counterpart to static application security testing. And for this particular video, there are some prerequisites that you need to know. So you need to know how websites work, how HTTP works, and this is all like super basic. So you can literally just go and Google or search on YouTube for some really basic videos on how websites work, how HTTP works, for example, HTTP methods and status codes, headers, cookies, all that stuff, and the OWASP top 10. There is a video on this on our channel, so you can just go and check that out. So if I actually went over here and searched for OWASP top 10, there should be multiple videos actually. So there's OWASP top 10 regularly, but then there's the OWASP top 10 API videos as well. So there's several videos on the channel for OWASP. So these are prerequisites that you got to know. And then the objectives for this video are very straightforward. We're going to learn how dynamic application security testing is going to be applied to find weaknesses in real world applications, the pros and cons of using DAST instead of any other type of technology, and of course, the automated tools that we can use for dynamic application security testing. So that being said, let's actually jump into kind of the details of this so we can understand what DAST actually is and how we can do it on a general scale. All right, what is DAST? Dynamic Application Security Testing is the process of testing an application, and specifically dynamic refers to the application running. So, I mean, you're more than welcome to pause this and read through all of these things. But the whole idea here is that we run the application through the implementation process and while it's running. So we're no longer looking at source code the way that we did when we were doing static application testing. And it's a little bit more advanced in the software development lifecycle. There's manual DAST, just like there was manual SAST, and then there's automatic DAST, just like there was automatic SAST. So manual DAST is where the security engineer is going to do manual tests against the application to check for the vulnerabilities. Automatic is when we can use a tool to scan the application for vulnerabilities. Dynamic application testing falls a little bit more in the black box portion of penetration testing for applications, because you're not going to be getting the source code, or at least it's implied that you're not getting the source code. When you're doing static application testing, it's white box, which means you actually get access to the source code. So it shouldn't be a surprise if you were asked by a company or a client to do application testing and you would have to do it dynamically because they can't give you access to source code, or you don't have access to the source code because you're looking at a third party's software and you gotta test it for vulnerability. So both of them are complementary, meaning that they can be used at different stages of the SDLC, the software development lifecycle. And I would say you got to do both. So it doesn't mean that automatic tools are going to replace manual testing, which was also the same theme that we did when we were doing static testing. And when you're looking at SSDLC, which is the secure software development lifecycle, which we also have another video of this inside of the channel, so you can go check that out too. When we're looking at the secure software development lifecycle, DAST starts at step 4, right? So static application testing is usually done in the very, very beginning processes because you're looking at source code again. Then when you start testing is when you actually have to run the application, which means now it turns into a dynamic test. And then you can be doing dynamic testing all the way through the release, deployment, operation, and even monitoring phases of the software development lifecycle, the secure software development lifecycle. So every scenario is different. It's common to use automated DAST tools using in the test phases, and they'll often be optimized for speed, meaning that they should be saving you time, but they can have false positives or false negatives, very similar to what happened with static application testing. Manual testing, on the other hand, is run periodically to avoid slowing down the process, and it's usually more thorough, very similar, again, to the static version of testing. So it's very important to understand that automatic tools are not meant to replace manual testing. It's just meant to complement it. It's meant to help speed up the process, but you should still do manual testing through the implementation, through the launch process, as well as just regularly. You should have scheduled testing going on against web applications and software and everything like that. So important note here is that most literature is going to often refer to automatic DAST simply as DAST, and it'll often consider manual DAST as a part of the web application pen testing process, and manual DAST might also be referred to as traditional DAST. So this is just for the jargon, just so you understand the language of the industry. So just like we did for static testing, where there are some pros and cons for dynamic testing. So dynamic testing, the pros are that you can find vulnerabilities while the application is actually running. This will include vulnerabilities that are specific to the deployment process, meaning you can't see them when they're static and you're analyzing just the code by itself. Dynamic will find vulnerabilities like HTTP request smuggling, cache poisoning, parameter pollution that are not, again, able to be found during static testing. The DAST tools don't care about programming languages. In static testing, we actually had to do specific tools for specific programming languages. So Python has its own tool, PHP has its own tool, etc. The number of false positives are reduced, meaning you'll have less false positives during dynamic testing as you would during static testing. Dynamic tools might be able to find business logic flaws, and this will depend on the actual tool itself. So you, again, should not be taken as a replacement for manual testing. This is going to be a common theme that you're going to hear all the time, right? So dynamic or automated tool testing is not a replacement for manual testing. So this is important to understand. The cons of dynamic testing is that the code coverage isn't always the best, because you're not going to be looking at source code really. You're not going to look at specific situations that will be triggered by specific use cases. Some vulnerabilities might be harder to find using DAST. compared to static analysis techniques. Some apps are difficult to be crawled. Modern applications heavily rely on JavaScript for their client side, meaning the user side, which makes it harder for DAST tools to traverse them, to navigate them. DAST scanners won't be able to tell you how to remediate some vulnerabilities in detail since they don't know what the hell is going on with the code itself. And some of the scans might take lots of time to finish. You need a running application to do the testing. So there are some pretty sophisticated cons to doing dynamic testing. So what we're going to be doing for this particular video is we're going to be doing spidering, or which is crawling, which is very similar to what search engines do when they navigate the internet and they go crawl the internet for new content every day. They also can call it indexing. And the tool that we're going to be using is going to navigate through the application itself and then map the application to identify the list of the pages and parameters that can be attacked. And then it's going to do vulnerability scanning for us, which is going to launch attack payloads against the actual pages and parameters that it identified to see where there are any vulnerabilities. And then you can actually customize this. And it's like this with a lot of different tools in a lot of different genres. So customization or configuration is pretty common and standard in this type of environment. So what we're going to do is use Zap Proxy as our tool. This was actually something that I had to study for my CompTIA CYSA certification, and which is literally the tool that we're going to be using for this. A lot of tools used in enterprise setups are paid and pretty expensive, but they'll use the same basic principles as any other application. The main difference among tools will be the vulnerability detection capabilities and how additional features, yada, yada, yada. So it's like, this is pretty common disclosures when it comes down to the types of tools that you'll be using across cybersecurity in general. I have already started the virtual machine and I've already started the attack box, so we can jump into it real quick. We got a couple of questions here. So it says, is DAST a replacement for SAST or SCA? And the answer is no. Obviously, it's a complementary process, meaning that it's in addition to. What is the process of mapping an application's surface and parameters usually called? And this is called spidering and crawling. So I'm just going to copy paste this real quick. And then the next question is, does DAST check the code of an application for vulnerabilities? And that is no, because it's running the actual application itself, the GUI, the graphic user interface, or the website, so on and so forth. It's not looking at source code. Static application testing is when we look at source code. So let's pull up Zap just so you can see what that is. And this is the Z Attack Proxy is the tool that is used for dynamic application testing. It's free and open source, actively maintained by a dedicated international team of volunteers. So pretty cool tool that you can use for your own application testing if you want to do it. And let's now jump into the next section, which is spiders and crawlers. Okay, so that took a few minutes to load on this virtual machine anyways. I'm actually using the attack box on TryHackMe, and then I had to launch the virtual machine that we can use to attack, because you need a website to attack anyways, and so it generates that for you. And then inside of the attack box itself, we already had Zap Proxy installed. So if you're going to do this through your own machine, you need to install Zap Proxy on your machine first, and then load it, so on and so forth. And this is where you'll get to. And so the first thing that we're going to do is we're going to go to Tools, and from there we're going to go to Spider, so that we can scan this website that they generated for us. This thing right here. This is going to be what we're going to scan. So I'm going to go to Tools, Spider. The options that they told us to do right here is we're just going to do either recurse, spider subtree only, or show advanced options. And I think recurse is the best one because it goes through everything. And then spider subtree only seems to also be checked as well. So in this particular case, it says we're going to leave the context box and user boxes empty. And then we're just going to specify a website as our starting point, which is going to be this website right here. And then from there, we're going to click Start Scan. So should be fairly simple. I'm going to go to Tools, Spider, and then starting point, I'm going to do HTTP, and then paste the thing right here. And then we're going to point it to port 882, and that should be it. We're just gonna point that right here, and then I guess I'll do recurse and spider subtree only because that's what it looked like over there, and then we'll do start scan. We'll see how long this thing takes, and we will take it after it is finished scanning. Actually, I think it's already done because it gave me 100%. So it seems to be that we're already done. So if we can kind of, let's see if I can drag this up a little bit. All right, these are the total number of pages that were scanned on our website. And so as you can see here, we have, you know, the regular stuff, the robots.txt, sitemap, about me, login, bootstrap, so on and so forth, getbootstrap.com, GitHub pages, a couple of popper JavaScript stuff, and login, and that's pretty much it. So that seems to be what we got over here. Added nodes is same, and then messages, mostly okay messages, 302 found, a couple of 404s that were not found. So this is the general scan. Basically, this is like the basic information that we got from our scan. So let's see what the instructions tell us. So we can do recurse, spider subtree only, so on and so forth. Right here it says 802 start scan. I did check these two boxes as well, so I wonder if I'm not supposed to check those two boxes. On the left side under sites, if we expand this and expand this, we have all of the same information that they had when they did their scan. So I think that looks pretty promising. It looks very similar to the results that we got on that side. And let's see, you should see the site is populated with URLs. Anytime outside of that is considered out of scope and won't be added to the list. You might notice that if you navigate manually to this, you should see a link. That menu points to the no spider gallery PHP, but if you expand the site's list on Zap, you won't see this URL. So let's go, I already have this opened up, so let's go see what it looks like inside this thing. So it does, I mean, it's not pointed to no spiders gallery, it looks like, for me at least anyway, because it just looks like it's been pointed to that. If I click on no spiders gallery, that's what shows up. So this particular piece does not show up in our list of links though. So if we go look at this whole thing, CSS sheet, the JavaScript, and none of these things actually exist. So this does not exist right here for us. I mean, it's interesting because when you click on no spiders gallery in the actual website itself, it points us to a completely different page. But when you land on the home page, it doesn't show me that. It doesn't show me that it's landed on no spiders gallery. It just shows me that it's landed on 8082, which is the normal thing for it to be landed on. Maybe if I shrink it, it'll show. No, same thing. Does not show that it's been landed on a different website. So that is different from what we've gotten. So this can happen because the particular link is not directly embedded in the HTML code, but generated on the fly by JavaScript, as many modern applications do. And Zap doesn't have a JavaScript engine, so that might be a reason why it's not showing it. To overcome the limitations of Zap, Zap can leverage a real browser like Firefox or Chrome and any scripts that are attached to the website and retrieve the resulting HTML. Instead of parsing links directly to HTTP, it'll do from the result of a browser processing the website. It can only be achieved using the Ajax spider. So let's go back to Zap, and now we're going to go to Tools, and we're going to use the Ajax spider this time. And we're going to do the same website, obviously. And we're going to do, what is it, just in scope? Spider subtree only, Firefox, and that's all we got. So let's do spider subtree only, Firefox headless. I'll do Firefox complete. So let's see what that gives us. Okay, so for this one, it actually opened up a browser instance for us. It actually opened up a couple of browser instances, it seems like. And in the background, as you can see, it's running the full scan. So let's see how this ends up working, how it loads, and where we end up at. And as you can see, it's actually like navigating the whole thing. If I would have done browser headless, which is probably the better idea, it wouldn't have opened up all of these browsers in the front facing for us to see. So that may be a better idea. So for yourself, when you're doing this, if you do browser headless, it won't open up the actual browser. And it ended. Is it still running? No, I think it ended. Okay, so there you go. Now it is actually done, and we definitely have much more that has been populated since the last scan that we ran. So that's a good thing, I think. It's obviously better to do the Ajax scanner. And look, we got the No Spiders Gallery PHP that now shows up in our scan results. And then we have a bunch of stuff at the bottom right here, way more than the first one that we ran. So definitely better to do the Ajax version, in my opinion. It's better to do the Ajax version, and it says you should see Firefox popping up and navigating websites for a bit. When Ajax is done, it'll populate the sites in Zap just as the regular Spider. And since Ajax Spider leverages the power of Firefox, we should be able to see that thing in the list. So yeah, that was definitely nice. So here are questions here. Zap can run Ajax Spider by using browsers without a graphical user interface. What are those browsers called? And they are called headless browsers. Analyzing the sites tab, what HTTP parameters can be passed to login.php using the post method? Okay, so definitely I think what HTTP parameters can be passed to login.php using the post method in alphabetical order and separated by comma. Okay, so let's go here using the post method. Oh, it's pass and user. So password and user are the things that could be passed, and pass user would be the alphabetical version. And what other .php resource besides No Spiders Gallery was found by the Ajax but not the regular Spider? So besides the Spiders Gallery, what other .php? So view.php I think is one. About me.php we already saw. Login.php we already saw. So I'm going to say view.php. So /view.php. And there it is. We got it. So a lot more straightforward. Dynamic testing is a lot more straightforward than static testing because you don't have to look at source code. The last video was a little bit over my head because I'm not good at PHP code. I'm way more well versed with Python. So that the last video was a learning curve for me. But this is pretty straightforward, you know, graphic user interface. It's fun to use. So let's now scan for vulnerabilities here. Let's see what we can find here. Okay, scanning for vulnerabilities is going to be done under the Analyze Scan Policy Manager because you have to create some kind of a scan policy when you run Zap, and usually in a allowed environment, a permitted environment. If you're scanning a website or an application that you're supposed to scan, you'll have access to this information. If you're not, or if you don't have access to the information, if you're doing like a black box test or something like that, you'll have to find this information first to set up your scan policy. But typically right here, it says it's a white box. So usually when you're using a dynamic application testing tool, you're going to be doing it in a white box setup, meaning that you're going to have access to this information. You're going to know what OS is using, the web server, the programming language, so on and so forth. So in this case, this is going to be our application. So it's a Linux OS, web server is Apache, programming language is PHP with no frameworks, and there are no databases. So what we're going to do is we're going to go to Analyze and Scan Policy Manager, which is the only option here, and we're going to add a policy. And we got to kind of optimize this policy here. So under Scan Policy, we can name it. The default alert threshold and strength are going to be both medium, applied to default to all. And then let's see what else we can add here. Okay, so this is actually pretty straightforward here. The alert threshold means the verbosity or verbosity of each of the categories of the scan. So if you have a low verbosity or a low threshold, it means that it's going to find a lot of vulnerabilities, but more likely there's going to be some false positives in there. So not certain or very low certainty. But if you have a higher threshold, it means that it's going to have a high degree of certainty, meaning the stuff that you're going to get are most likely actual vulnerabilities, but your results are going to be less than what you would have gotten if you were running it with a low threshold. The strength is also going to have additional findings. If you have a high strength, a higher strength level, you're going to get more findings at the expense of increasing the scanning time significantly. So it's going to take much longer if you have a higher strength level. So I'm just going to leave it at medium just for the default, just for what it is. What we got to do for our specific application, and this is something that they also say right here that's pretty important. This is a trial and error process to be improved over time. So if you're actually doing this in a real live environment, you're probably going to be doing multiple scans with different types of settings, just so you can see what will come up and what type of results you'll get. So this is not definitive by any means. So, and for the purpose of this video, we're going to just set up the options that they've given us, just so we can do a trial run with this and then figure out what else we could do. So there's no database in use, nor any XML processing, so we can safely disable all of that stuff. So let's go ahead and first make sure that we just THM policy is going to be the name of the thing. I'm going to leave it at medium. Everything else is going to be default. The client browser it needs to be turned off. So I think if I double click this, I can change it. Yeah, all you got to do is just turn off the threshold right here, and it should be turned off in its entirety. And then so we're going to do the same thing for everything that's SQL injection, all the way down to XML and XL or whatever, ST, which is going to be under injection. So we're going to turn all of these things off right here. And there we go. And I don't think there's any other stuff. So yeah, that's it. So we're going to save that. And now we have our new THM policy saved. So we are now going to close this, and we're going to go to tools, and we're going to do an active scan this time around, which will allow us to choose a policy, the THM policy, and it's going to be a recurse, I think. Yeah, recurse. And then we're just going to do the same starting point that we had previously, which is this guy right here. And then select that, and so there it is, and start that scan. So let's see what we can find this time around. All right, so there we go. That one was actually, I think, the most robust response. There was a lot of results that came from this thing, and I mean, yeah, definitely much larger of a result base. And so from here, it says that we should see some results in the alert section, and we can get a description of everything that shows up here. And I mean, that's kind of the big thing. So if we go to alerts, yeah, we have 14 alerts right here. Cross-site scripting, path traversal, absence of anti-CRSF tokens. Yeah, there's definitely much more results for that policy that we created, and it's an active scan, it seems. So it wasn't just it wasn't like a spidering or an indexing type of a exercise that we did. We were doing an actual scan to see what all of the different vulnerabilities are on this application that we ran, and clearly there's a lot. So it allows you to review the findings to ensure that they're all correct. Should you think any of them is a false positive, you can mark it as such by right-clicking on it and finding and selecting mark as false positive. So here's the question. Will disabling some test categories help speed up the scanning phase? Yes, that is true. There should be 2 high-risk alerts in your scan results. One is path traversal. What is the name of the other one? It is cross-site scripting reflected is the answer. Cross-site scripting. There we go. And that's what we got here. Very cool. I like this thing. So let's look at authenticated scans. All right, this is actually a pretty robust section right here. So first and foremost, we're going to deal with logins. And the way that we're going to do this is we're going to create a script. So a ZEST script is a way to save and reproduce a series of requests. To do this, we need to disable the Zap HUD from the toolbar. And we can find it on our toolbar right here, which is this thing. And you can see that it's kind of clicked. So I'm going to click that to disable it. And then once I do that, I need to actually go and create a SAST script. So to record this, we'll create the record and use Zest script, and then let's set a title to the authentication. So if I click on this record button, that's right here, is the little cassette tape. It'll show this right here. So we'll do THM script for this. For this, we're going to do authentication as our option, and from that, I think everything should be fine. And so the prefix should be the website that we've already had right here. And load on start, everything's all good. So we're going to click start recording, and then it's going to open up, or no, we're going to click start recording first, and it's going to start recording. Then we're going to open up the browser, which is the Mozilla Firefox link right here, and it'll open up a browser inside of Zap, like a Zap browser. And then we're going to go to our application, which is this thing at 8082/login.php. And it should take us to the actual login page, and no spiders is the, let me see, no spider, there we go. No spiders is the username, no spiders is the password, and we should now be logged in. So that is the case. And then we can use these credentials, so on and so forth. Once we're logged in, we can stop the recording. Feel free to close the browser as well. Some of the capture might not be necessary, but what we're looking for is this information under that. So I'm going to close this browser. I'm going to stop the recording. And under this, we are going to see, under our THM script, we're going to see all of this information, which is what they are saying we need to look at as well. So there was a GET request for the login page. There was a POST request on the login page, and another GET request that gave us the CowSay page, which is exactly what happened for us. For each of these, it's going to check the status code and response to see if they match, and if they do, they'll assume that the login was successful, and we can now test the recorded script by pressing the run button. So I can just click on the script right here, which is this piece. I can literally just have that whole thing selected, and then click the run button. And it's going to run, and let's see, I think it's already done, and everything seems to be good. And under the responses, so if we go to response, we'll see the responses, 200 status, which is okay. Everything was all good. We have the actual website details that were pulled in this case, the HTML of the website. And then Zest results, we'll see that the login page was found. So it should be all right here. So under Zest results, we have found right here, the favicon itself was not found, but the login page, login.php, was found. All the information that we requested came through okay. The only thing that didn't come through was our favicon, and CowSay PHP was also loaded okay. So now we're going to create a context for this situation. So now that the authentication is recorded, we're going to tell Zap where to actually use it. And this is a very simple application. So the recording and the authentication will apply to the entirety of the application. So we got to define a context that includes every single URL. And to do this, you just click on the full thing, which is, where is the whole piece right here. So let me go find that. All right, so it's actually right here. So we have a scripts tab that runs all of our scripts, obviously. And now we have a sites tab. So I'm just going to click on the entire site like this, right click on this, and then include in context, new context. And here it is. And so do I name it? It seems like I can name it. Let's see, this will automatically create a regex that matches any page on the web application. There are many options that you can configure. For now, click on authentication and link your Zest script by using script-based authentication. When you click on scripts, it's going to tell new, yeah, so that's it. So authentication, this is going to be it. A new regex right here, included in the context, and so we're going to do okay, and that should be, I think that's it, right? So now, since we have it, click on authentication and link your Zest script by doing script-based authentication. Okay, so it is under the sites section right here. So there's a script section and there's a sites section. And so under sites, we just click on our link right here, and we're going to do include in context, new context, and then we need to select authentication. And there it is. And I think this is all I gotta select right here. Let me just make sure. The script is thmauth, which is loaded, configure authentication method. So let's see if we can configure that or if it's already there. Actually, so we're going to do script-based authentication, and then from here we're going to use our THM script. And I believe that's it. Once we do that, be sure to click load to actually load it. So let's do that. There we go. Now it's loaded, and now we can do OK. And you can also configure authentication here to check whether there's a valid session, but we'll do this later in an easier way, apparently. So to do an authenticated scan, Zap will need you to define at least one user in the user section. This won't be used at all in our case, as our script embeds the user and password that we'll use. However, Zap needs a user to be defined, or it'll just skip the authentication altogether. So what we need to do, what is it? It's no spiders, I guess. So session properties, let's go back to here. I think I may have already messed that up. Let me see if I can modify the context. Okay, so yeah, you can literally just double click on the context that's right here for that, and then we'll just add a user, and the username in this case is no spiders. That's it, right? That's the way that they did it. It doesn't seem to be any special thing. So username spiders, we're gonna add it. You've now configured a value for the required field username. Okay, so let's do that then. Username is here, and I'll just do the password too because it's required, and it is going to be enabled. Okay, very good. All right, that seems to be fine. And now we're going to click OK. So now what we're going to do is we're going to re-spider the application to see what we get here. So if I click on our site, it should automatically import everything, and then we also have a user, so we can add that. And there we go. Start the scan, baby. Let's go. So now you can see added nodes under spider. And if I click on this, look at that. We do have added nodes as well, which is cowsay and logout. So avoiding logout. So to prevent Zap from logging itself out, we're going to right click on the logout PHP script in the sites and exclude the script from our context. So we're going to go here. We're going to find logout and exclude it. So right here, logout, right click and exclude from context, which is this context. And it is now excluded. Very good. So, okay. And let me see if there's anything else I got to do here. Now it's going to avoid interacting with the logout script. Note that depending on the application, it'll be desirable to exclude some other stuff. In addition to preventing direct logouts, we can specify indicators to identify its session, still active or not, and repeat the login if necessary. This is easily done by selecting parts of the response that can only appear when you're logged in or logged out. For example, we know that cowsay can only be accessed if you have successfully logged in, so it might be a good indicator that we can use for Zap. So let's say cowsay, let's select cowsay from the Sites tab and select the text that corresponds to the logout link, and then choose flag as context, and then authentication logged in indicator. So this is going to be under sites, right? So let's see, go here. Let's find cowsay, cow mooing, but it's under scripts actually. So cowsay.php scripts, and it's right here. I stand corrected. So it is under sites, but we need to click response right here, and it'll bring us the text right here. And in this case, this is the text that they're referring to. So I think we need to highlight this entire thing and then flag as context and then authentication logged in indicator. So we're going to go right here. I'm going to select this whole piece and right click on that, flag as context, authentication logged in indicator. And there's that. And let's see if it shows us any other stuff. And yeah, that seems to be good. So I'm going to do that. That's okay. And then from now on, Zap is going to search for the log out link. And if it isn't present, it's going to assume that the session needs to be renewed and log back into the application using this script that we had. And we can also do the same thing as a logged out indicator. Since we know that the login link should only be visible if you're logged out, we can use it for the purpose by doing a similar procedure. So we can get the link HTML from About Me script in the Sites tab. So login right here, it's under About Me response. So if I go to About Me PHP response and find the portion that has log in, or does it say log out? Let's see. Okay, so when you do this, you may need to resend the request via the browser to that URL to get the correct pattern, meaning the login.php. You got to resend it so that it actually shows up as login instead of log out. And then once we have everything correctly, we can choose a verification strategy to use the configured patterns correctly. Depending on the website you're checking, you'll want to use different strategies and tune them for the application. In this case, we're going to use pull the specified URL to tell it to pull aboutme.php resource every 60 requests to check for logged in and log out patterns. To do this, double click the context and change the following settings. So we're going to double click our context, and it's under authentication, verification strategy, pull the specified URL, and then we're going to do the aboutme.php. So verification strategy, check this, pull the specified URL, and then it's under URL to pull for verification, which is going to be this thing. And we're going to paste that, 8082/aboutme.php. And that should be all good. Click OK. And then rescanning one last time. I wonder if we're scanning or if we're doing, yeah, active scan. So we're doing an active scan one last time using the same policy, using the no spiders username. So right here, same policy, context. Oh, it should have a context. Why doesn't it have a context? Let me see. Okay, there we go. I clicked the reset button. I don't know why that didn't work before, but that's fine. I think it's like a reset. It acts as refresh. So I did reset, and now all these things are able to populate for us. So you got to click on this reset button in case it's not populating for you, and then start that scan. And there we go. And that's pretty much it. This part was a little bit complicated, but I think I understand what's happening, right? So you want to, as it's saying right here, you want to add things to your verification strategy, right? To see whether or not you're actually logged in or logged out, especially if you're trying to check for pages that only show up if you're logged in or if you're logged out. So for example, the About Me page may be different when somebody is logged in versus not logged in. So if they're logged out, there should be no About Me. Does that make sense? If they're logged in, then there is an About Me, because that's, you know, whoever you're logged in as, there should be an About Me page for that user. So that's what's important to kind of take away from this thing, is that when you create a context, it gives you the overall environment after the script scan, right? So we did a, let's see, so we went, let's go from the top just to review this whole thing, because this also helps me a lot too. So we do a new Zest script by clicking the record thing, and it allows us to record the entire interaction, very similar to what we do with Burp Suite, where it records the interaction with the website itself. And then we use the browser that's inside of Zap. We went to the login page, we logged in, and after you log in, under the script section, the requests, the HTTP requests that were sent, so a GET request retrieves the login page for us, a POST request sends our username and password to that page, and then after that, if you're successfully logged in, you should get the new cowsay.php, which was not available for somebody who was logged out. And then when you have that, you can now see under the scripts, if we run it, I think that's the other thing that I may have needed to do that didn't show it initially, is that when you rerun this whole thing, then it'll show you all of the pages that show up, as well as the posts or not the posts, the requests that were sent via our interaction with the browser. So we did the browser interaction, it recorded everything, and then now we can run everything. And it shows you what's going on. And now you have the full context to record, right? So I can, everything that was just included in that interaction, we right click on the page or on the website inside sites, included in our context. We make sure that our script was included under the authentication and the user that needs to be, because it's going to be actually logging in as a user, so you have to provide that user as well. And then when you re-spider everything, it shows you the logged in pages as well. And when somebody's logged in, there's the CalSay page that shows up, but there's also something important, that the the About Me page also populates. So once we had that, we can exclude pages from the context or include pages into the context. And what we wanted to avoid in this particular case was accidental logouts. So you don't want Zap to log itself out. So we excluded the logout page completely from the context. And then we wanted to include something, which actually we were also excluding the About Me page from the context as well. So we excluded the About Me page, specifically the login portion that would show up for that, as well as the CalSay. Was it the CalSay? It was the CalSay, right? The CalSay, yeah, the CalSay page as well. And then we finally scanned the application one more time, which is now here. And so if we go to alerts right here, still same stuff. We actually have a new one that showed up. So cross-site scripting, path traversal, and remote OS command injection. That was the new thing that came here. So there we go. So remote OS command injection is the new thing that showed up. And it says which type of script was used to record the authentication process to our site in Zap, and which type of script was used. Okay, let's go. Oh, a Zest. Is that what it's called? A Zest script? I think that's what it was. Let me make sure. Yeah, a Zest script is what was used. Okay, so there you go. A Zest script is what was used. And now we are done with this particular task. Very cool. All right, so far what we've done is we've been scanning and spidering and doing a vulnerability assessment against a traditional web application or traditional website. But APIs aren't something that you can easily scan or spider. The endpoints of the API, they don't normally expose information about other endpoints. So it makes it a little bit harder to do discovery on something like this. And most websites nowadays and web applications work through APIs. They don't really work the way that we just went through, like looking like a traditional website with these web pages and the assets just being visible like that. So instead of spidering APIs, we're going to rely on the development team to give us a precise specification of the available endpoints, meaning all the different links and pages. And then we'll send those parameters to those things. And we don't spend time on the discovery process, but we actually get to focus on the vulnerability scanning, the security testing, so on and so forth. So there are a few standards that exist to document APIs. They generally all include information developers, or the information that developers would need to build proper requests and know what to expect as responses for each of those things. And this is all we need to start testing for vulnerabilities. Zap can import APIs using OpenAPI, which is formerly known as Swagger, SOAP, or GraphQL. And depending on the API that we're going to be using, we'll be able to use one of those things. So for example, what's going on is in this particular example, we're looking at the swagger.json endpoint or link or file or whatever. And it follows the OpenAPI 2.0 standard. And this is what we'll see inside of this thing. There's going to be a paths section, and with every single endpoint of that list of the API that's listed inside of that. And for each one of them, there's a complete list of the available parameters. So if we look at the ASCII art, so AC is how I pronounce this, AC art, and then the art ID itself. This is one of the specifications, one of the endpoints inside of the paths section. So you have the AC art, and then there's a get request, and then it gets these parameters, and then this is the responses that would come from that, right? So and it indicates that you can do a call on this particular endpoint using a get method by sending the art ID, and then from that it'll bring all of the description and the path and the name and the required all that stuff from that, whatever the ID of the art piece was that you were requesting. And then we'll find similar definitions for, AC art generate or AC art add, so on and so forth. The definition files are expected to be processed by machines, so their format might be hard to read. They make it easy for us to understand them, and some APIs will also provide a more friendly UI that we can use to run quick tests and explore the available endpoints. And we can go to Swagger UI to check it. So let's go to Swagger UI inside of our browser real quick just to check to see what that actually looks like here. And here's what we got. So they used Flask to do this, API spec. This is the Swagger, and we got the option to add, post option, post, get, and options. These are all the various not sections, I guess, commands that go with this. And we can analyze each one of these specifically. Let's see if we even we need to do that. We already did this piece, so yeah, right here. So Swagger UI to check it out. Production applications might hide API definitions to prevent external attackers from knowing how to interact with them. Remember, you can always ask the development team for them if you actually need them, if they actually exist. So importing the open API definitions into Zap is what we're going to be working on right now. So we have two formats. You can either provide an offline file or a URL so that Zap can download it from that. And since ours exposes the definition file inside of this URL, we can use the URL option. So we're going to go to import and import from a URL, and we just need to give it this specific URL here. So I'm just going to copy this thing and then go into Zap, and I'm going to do import and import from a URL. Is it a GraphQL? Open API. Okay, open API from a URL. There we go. And we'll just paste the URL in here. Context is default. Click on import and fail to parse, fail to parse. Further details may be open in output. So let's see. Okay, so this is what I mean sometimes when I say that you got to pay attention to the details. So I did not, I tried to import this thing instead of trying to import the swagger.json, and that's why I kept having a failed message. So I now imported the swagger.json using import open API, and then literally that's it. And it worked like a charm, and now I'm running the scan against the current version that we just imported. And in our alerts, we should be able to see some new things that pop up, and one of them should be the answer to our question down here for the ASCII art generate endpoint. And then read the details on the path traversal vulnerability detected based solely on the information presented by the scanner. Would you categorize this finding as a false positive, yay or nay? So path traversal is right here. And it says based on what? Based solely on the information presented by the scanner, would you categorize this as a false positive? So let's see. Okay, so for the path traversal thing, if we actually open this up, because it's a little bit hard to read at the bottom right here, it'll open up in a new window. It just gives us a general description of what path traversal is. There is nothing available under the other info section. That's typically, it'll give you a little bit more information about why it thinks that this particular move or this particular thing was an actual attack. The attack itself, I'm guessing that this is specifically what can happen. I don't know if this is exactly what actually happened because it's a scan and it's saying that it's a possible vulnerability that can happen. and obviously that they're trying to access the etc password file that gives you the usernames. It doesn't give you the hashes of the user's passwords because that's inside the etc shadow file, but etc password being traversed, these dot dot forward slash dot dot, that basically means that they keep going back one directory, keep going back one directory until they get to the directory that holds the etc password file, and then inside of that they try to find it, and then this is what it looks like when it's URL encoded. So after view.php image equals, and then they just start putting these this dot dot percentage 2f dot dot percentage 2f. The percentage 2f is a forward slash when you URL encode something, and then the dots are the dots. So this is technically what would happen. I'm, just based on the fact that there's no other info, I put yeah. But initially my thing was, I don't think this is a false positive because it is a vulnerability. Technically, if this is accessible and somebody can actually traverse to this particular link, I think that is a vulnerability, but the answer was it's a false positive. So do you categorize this as a false positive, yay or nay? And the answer is yay in this case. The answer to this one is what high risk vulnerability was found on the ASI generate, and it's this thing right here, the remote OS command injection is the only other one that was found as a high level vulnerability here. So let's check that out. What is it? Remote OS command injection. And that is indeed the answer. So that's what we got for our answers for checking APIs with Zap. If you have any more information as to why they made the decisions that they made in this particular thing, I really would love to hear more about it. But this one is pretty straightforward for the remote OS command injection. It gives you the URL, the ASCII generate, and then it gives you the remote OS command injection. So that one is pretty straightforward, but I am curious as to why they didn't think that this was a false positive, the OS traversal, the path traversal. So moving on to our last piece right here, which is integrating DAST into the development pipeline, the software development pipeline. All right, so this one has some nitty-gritty info that we got to read up on a little bit. So generally, when we consider dynamic testing, people refer to using automated scanners into the development pipeline rather than manual scanning or manual processes because of the term being different. So typically we would call that application pen testing. But having to add DAST, dynamic testing, to the development process isn't as straightforward as it may seem because there's a few catches. There are caveats. I love that word, caveats. There are a few caveats, a few things to consider. One of them is that you got to consider, you got to decide at which stage of the process we're going to run the scan. Then you got to decide what will trigger a scan. We can run a scan on each commit that's made to the code. So every time that you actually run the code or process the code, that would be considered a commitment. Every time you save the code, that's considered a commitment. So you can either run it at each commitment made to the code or on a scheduled basis. And then you got to determine the intensity of each scan. A full vulnerability scan on a medium application requires a lot of time because you're doing a full scan of everything. And the application itself it's not small. It's not like the one that we looked at that had a handful of pages, like less than a dozen pages. You know what I mean? Most applications are pretty robust. They're very sophisticated, so it takes a lot of time. So you don't want to slow down the development team. You don't want to slow down the development lifecycle. So since no solution actually fits everything, there's no one size fits all. Determining this you have to do with the actual development team so that you understand what their schedule is like, what their timelines are like, and then you got to communicate the security requirements to make sure that they understand what is important in this whole process so that it's a collaborative type of an environment. So what we're going to do in this particular section is determine how we can actually quickly implement dynamic testing to the development pipeline to get early visibility of any kind of vulnerability, and then run automatic scans on every commitment that's made to test for a subset of vulnerabilities, and do that in a way to avoid long delays in the actual development cycle. So there is the CI/CD pipeline, and in our current machine we have the entire development for the web application that we scanned, and the following two components are in charge of doing that. There's the Gitia repository running on the 3000 port, where the code for both applications are stored, and there's the Jenkins instance that runs the CI/CD pipeline, and that's on the 8080 port. So if we go back into our browser right here and go visit those ports, so let me just delete this so we can actually go look at those various endpoints that we have. So the first one was 3000, and that's going to show the Gitia repository. And the next one is going to be, let me see if I still have this saved here. And so this is our Jenkins login. I would need the login for this just to see what we can get past that. So every time a commitment is made in Gitia, Jenkins will take the code from the repository and compile it into a Docker instance. The Docker instances are what we have scanned so far. So the user, the developer, sends the commitment to the repository with the code. Jenkins gets informed that there was a new commitment that was made. It retrieves the code from the Gitia repository, and then it goes and develops the apps and runs the apps, and that's where we get the endpoints to scan, right? So Jenkins takes the code and turns it into an app, and then that's where we get the stuff to scan. So our username and password is THM, and from here we should be able to actually get access to Jenkins, which is right there. So perfect. So now running automated scans with the Zap2 Docker. In our pipeline, we can use Zap2 Docker, a Dockered version of Zap with automation as the primary purpose. The full documentation can be found at this link right here. So we'll just move that next in our tabs right here. It has the user guide, the baseline scan, a full scan, API scan, scan hooks, web swings, and diagnosing Docker problems. And these are just some of the commands that we can get. So we don't need to do this specifically because I think we already have Zap2 Docker on the attack box that I'm using. But if you wanted to download this and install it on your machine, you can install it in the command line using this Docker pull OWASP Zap2 stable, etc. The commands in this section are provided for reference only. We don't need to run them, as we will have Jenkins to do it for us later. So this is the command to install it. This is the command for baseline scan. This is the command for full scan, and this is the command for an API scan. But again, we don't have to do it in this particular instance because Jenkins is going to end up doing it for us with a couple of clicks. So the environment that we have access to, again, the one that I have access to in the attack box, already has Zap2 Docker ready to use. So all we need to do is tell Jenkins to run Zap2 Docker with the options that we need. And before doing that, we need to see what we actually have. So we can find the organization called THM, which is the very first thing that you see right here. And inside of that, there's going to be 2 repositories for web applications. And for each one of them, there are branches. So if I click on this thing right here, I should be able to get into this. And inside of this, we have the simple API, and then we have the simple web app. So these are the 2 repositories that we have. And then inside of the repositories themselves, there is going to be a branch, right? So this is the branch that's inside of the simple web app repository. The single branch called main, if you click the branch, you'll be able to see the builds for it. And for example, has been built 2 times already inside of the simple web app. So if I click on this one more time and then click on main, we should be able to see 2 instances that have been built right here. Oh, this one has 3, look at that. On March 28th, January 30th, I think March 28th was the one that I did. No, I wasn't even here on March 28th doing this. So this has been, somebody else has been doing something over here. Okay, anyway, so for each build, we can see that there are 2 stages configured: build the Docker image and deploy the Docker image. So build and deploy. And before they are defined in Jenkins, both of these are defined in Jenkins for each repository. If we go to Gitea to open the Jenkins file on the simple web app repository, we can see the specific commands run on each one of those stages. So if I go to Gitea here, and what do I do to be able to get access to this? So maybe I can sign in to Gitea the same way, huh? So let's do THM. Let's see if that works. It does indeed work. And these are the stuff that we have done right here. So if I click on the information that was pushed to the simple web app, this is what we have: the Docker file, the Jenkins file, and this is the stuff that's inside of the Jenkins file. Very much similar to what they said right here. In the second stage, you can see how the web application manually is deployed on port 8082 right here. This piece right here, deployment, right? So build the Docker and then deploy the Docker. If we want to incorporate Zap to Docker in the pipeline, we can add a third stage that runs the scan for us after building the container. For the convenience, the stage is already defined in the Jenkins file, and you can uncomment it to get it running. So feel free to use Git to send a commit to the repository, or use Gitea's built-in editor if you find it easier. So if we want to incorporate Zap2 into the pipeline, we can add a third stage that runs the scan for us after building the container. This is already defined in the end of the Jenkins file. So right here, this piece right here, it's already been defined. So if I can edit this, let me see, edit the file, there we go. Edit the file and go here and uncomment this piece by removing these two pieces right here. And now that has been uncommented. And so if I save this now, that should no longer be a commented portion. So commit changes, and voila. Now the bottom part is now ready to go, and we actually have a scan. So cool. So we got it to get it running. So now we are running the baseline scan only. This will be only run for each commit to the repository. So it's not sensible to delay. It isn't sensible to delay the pipeline with a full scan that might take hours to finish. This intends to file no hanging fruit, and we're not going to see any SQL injection, CSS, or anything like that. And so since Jenkins can catch anything in the repository, it will start building the process immediately after you edit the file. You can switch back to the simple web app to see the progress live. So I did that already, and since I've done this, if I go to Jenkins, look at that. It's already running it. It is already running it for us. Super exciting. Okay, cool. So while that runs, let's see what else we can do. We can see that the current build now has scan with OWASP Zap stage, and it'll take about 5 minutes. Once finished, the build will fail, as Zap will find some vulnerabilities in the app. To check the report, open the build and go to the workspaces section in menu, and then we should be able to see. So if I click on it and then click on the most recent build, I'll go to workspaces. Is it still running? It's still running. Once that's done, we should be able to go there and see. So here you can explore the project files, and Zap will put its reports in the folder, download and examine the report to answer the questions. We should right click and save the report before opening it. Opening it directly from Jenkins will break the formatting. It's good to know. Repeat the same process to enable Zap on the simple API repository and get the corresponding report, and use the report for the other questions. So I'm going to go back here. Since it's on the simple web app, we're going to go back and we're going to do the simple API and go for the Jenkins file. And inside of the Jenkins file, we're going to edit this file, and we're going to uncomment that last section as well, just to get this to run. And then we'll come back and see how this whole thing ends up working, and that should be fun. So let's see, commit changes, and it should run live, right? Because it's connected to Jenkins, and Jenkins is going to do it live as we go through everything. So if I click this, there should be another thing that pops up real quick well, actually this is simple web app. So if I go back to THM and click on simple API, there should be something else running inside of that too. Yep, that one's running too. Okay, so I will come back when these are done so we can look at our reports and get some questions answered. So you're not gonna notice it because it's literally gonna get edited out, but you know, I'll be back in 5 minutes. All right, so here we go. We got a failed notice as we were told we were gonna get. So I'm gonna click on this thing right here. Then we're gonna go to workspaces, and there it is. And then it's gonna be inside the Zap reports folder. And that is what it is. And so what am I looking for here? We're looking for, I think we're looking for the baseline, right? So the baseline web app HTML or Zap YAML. So I will download both of these. I'm gonna see if I can download them both, all files in zip. So maybe we could do it that way. So I'm gonna open this as a zip file, and let's see what we can find here. Okay, I think the HTML version of this works. So let's see if we have the answers inside this HTML. So in the, which one are we on? This is the simple web app. So the simple API, or simple web app. How many medium risk vulnerabilities were found? So there we go. Number of alerts for medium is 3. So let's see if that's right. Okay, it is right. So now we're going to go to the main branch of simple API on Jenkins. One of the builds failed during the build Docker image step. What is the number of the pre-existing failed build? So this is on Jenkins, and it's for the simple API build. So if I click on this and go into the main, it says one of them failed previously, and it's number 4 that was failed in the build stage. So that is the one that failed. Now that we're going to download the report for this one, what high risk vulnerability was found? So same thing, we're going to click on the number 8. We're going to go to workspaces, click on the actual thing right here, and go to our Zap reports and download all the files in the zip folder. And Zap reports 1 is going to be the one that just downloaded, and we'll open this thing up and check this one out. And let's see what the high, what is it? The one high vulnerability is remote OS command injection, which is what we previously found. So that should be our final answer. Boom, just like that. And we got it. So that was it. Just like that, we got the room done. What's happening to my, can I zoom out or what? What's going on here? All right, whatever. It seems like my screen froze. Hopefully the recording is still all good and we haven't lost anything in the process. But yeah, that was it. That was it for our dynamic application security testing room. All right, if you got any value from this video, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that we drop something. We have 145 videos that are out. The count has grown tremendously since the last video that was dropped this last Friday. So I'm extremely grateful for what's been happening, and it's really, really nice to see the community keep growing. So very much love it to actually have you guys with us. And yeah, it means the world to me that this is actually happening, and I hope that you find value in it as well. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Peace. All right, we are finally in the good stuff. Weaponizing vulnerabilities is what we're going to be talking about today. And we're going to go through some really, really good resources. For example, the exploit database. If you have not seen this before, we're going to go through the NIST National Vulnerability Database. We're going to go through the Department of Defense website for the Vulnerability Disclosure Program. And of course, we're going to actually execute a vulnerability ourselves. We're going to exploit a vulnerability that we found using a tool which is called SQL Map. And then from that, we're going to run some nice remote code execution hacks. So it's going to be a fun room. This is a really, really exciting room. I love this stuff because I love pen testing and ethical hacking. So this should be extremely fun. We're going to be talking about these specific learning objectives. I already got ahead of myself, so I already told you what's about to happen. So without further ado, let us jump into the introduction of this room. Weaponizing vulnerabilities. It is the time. We have finally arrived. A very, very fun title just by itself. I'm super excited about this room. And as it says, we're going to learn how a vulnerability evolves and the methods to weaponize multiple vulnerabilities, leading to remote code execution. So this is going to be a fun room. Super excited about it. Let's dive into it. All right, the goal here is to take a vulnerability in a software or a system and create an exploit for it, which then we can use to get access to the vulnerability and do a lot of malicious actions or other malicious actions. This is actually probably just going to be one type of vulnerability that we're going to exploit, or one type of exploit that we're going to create for a vulnerability. And there are many other vulnerabilities that exist, exploits that exist that can be ran at a variety of vulnerabilities, a single vulnerability, a set of vulnerabilities. There is a database of vulnerabilities. It's called the National Vulnerability Database. That is obviously as a part of NIST, the National Institute for Standards of Technology. And this is just by itself, you can learn so much about this. And CVEs is what we've already covered in a lot of different rooms. A CVE number is the common vulnerability and exploits number that's attached to various vulnerabilities that exist. And you can just go through and search for essentially any operating system or any version of an OS or anything like that, and you'll find vulnerabilities that are attached to them. That's why blue teams and security teams are constantly focused on upgrading and updating their software systems and their versions and so on and so forth. And there are teams of penetration testers and ethical hackers that are constantly attacking these systems so that they can find vulnerabilities before bad hackers, before black hat hackers do, and patch them in advance so that they stay at least one step ahead of hackers. So this is a big world just by itself. Just weaponizing vulnerabilities, exploiting vulnerabilities just by itself is the giant branch of cybersecurity. And this is where we get into offensive security and red teaming. So I love this stuff. This is my favorite part of cybersecurity. So this is going to be a really fun one. So an exploit can be utilized in conjunction with additional exploits or vulnerabilities for the attacker to take control of a system that they are targeting. Even though a vulnerability's impact isn't as significant as another that is more difficult to access, it might still be quite simple to attack. And if the exploit is adequately implemented and managed, in that case, a low-level vulnerability can grant you access to something that can do real damage. For example, enter the network and system and further exploit and do stuff that is typically harder to access directly. So you take one step and it's a small step, but as long as it gives you a little bit of access, now you can take a bigger step that gives you even more access. So low-level vulnerabilities are still important in the eyes of cyber attackers, and all of those things should still be considered when you're patching something and when you're securing something. It's not as important as a severe vulnerability. Obviously, you want to take care of the level 9 and level 10 vulnerabilities first, but you want to take care of everything ultimately so that even the low-level ones are taken care of so that nobody can attack you at all in any capacity to give themselves higher access, so on and so forth. So another closely related room is weaponization, which I do not think, I have not done this one, so this is another really good one, and focuses on various techniques that assist the red team in building custom payloads using PSH and HTA and VBA, and none of those things I've even heard of, so I'm super excited about that. I think PSH is PowerShell. HTA is what? Oh, HTML application files. Okay, fair enough. We're going to consider the defensive part as a security engineer in this room and see how bad guys actually combine vulnerabilities to gain complete control of a system through a case study. And then we're going to focus on the core theoretical concepts necessary for a security engineer to understand how to exploit and how the exploit development cycle works. So what is an exploit? What is the vulnerability lifecycle? How do we chain multiple vulnerabilities together? And how can we automate multiple everyday tasks as security engineers? This is a really juicy room. Super excited about this one. Understanding weaponization, understanding vulnerability databases, and how to exploit vulnerabilities is prerequisites, and I haven't done any of these things. So, oh, actually, I did vulnerabilities 101, so that's good. There's probably a video of this. I'm pretty sure there is a video of this. Actually, there is, because I do recognize this image right here. So there's definitely a video on vulnerabilities 101, and I've done exploit vulnerabilities. So yeah, there's at least a few of those. This one on weaponization I haven't done, so hopefully we can still make it through through this particular room. So we'll see how it goes. We'll see how it goes, and if not, I mean, there's no option at this point. We're gonna make it to the end of this room, and then if I need to, or when I get to, I'll go ahead and record the video for the other weaponizing room, and we'll have both of them for ourselves. So let us jump into the basic explanation of an exploit. By now you should already know this, but let's talk about it a little bit more. An exploit can take various forms. So it could be an executable file that's designed for a specific endpoint, meaning a specific computer or IP address, or an IoT device. It can be delivered through a text message, an email, or even a file that is hidden inside of digital files in the macros of digital files. When the exploit is executed, an attacker can perform various actions on the target system, like controlling it remotely or even locally, disrupting functionality, stealing data, or anything else that they could allow on that system. The exploit could be either local or remote, and local basically means you're on the device itself. Remote is you're executing remotely, so that part should be fairly easy to understand. The attacker who has access to a specific computing resource can execute code locally. They may also install additional malicious code or gain remote control of the resource. And somebody who exploits a vulnerability remotely over a network or communication channel to gain control of a system uses a specific type of exploit known as a remote exploit. And that's the stuff that we're going to be talking about today. An exploit is a technical tool that may be used against any user in a standalone or connected cyber environment. And in a standalone environment, an exploit may be delivered via a removable media like a USB drive. They can be developed and financed by various actors, including nation states seeking to engage in cyber espionage or warfare, organized criminal groups looking to profit from their activities, and hackers on the dark web selling their services to the highest bidder. Additionally, some specialized actors look for weaknesses and develop exploits for them. It's critical to realize that an exploit is not a goal in and of itself. It is a method for carrying out something that's much more significant. And exploit creation is a complicated process requiring high information security expertise. As a result, it involves highly experienced individuals and continuous updates that can fetch a high price on niche or illegal markets, mainly on the dark web. And we did a small quick little video on the dark web if you want to go check that out. That's on the channel as well, and it kind of just shows you the difference between the public web, the deep web, and the dark web, and it shows you some of the previous websites that the FBI actually logged on their database, so that we actually go through some FBI news and resources that we pulled from the FBI website. And we also talk about the softwares that you can use to gain access to the dark web. So it's an introductory video. It's not really that big of a video, or that it's not that detailed of a video, but it is something if you want to kind of learn a little bit more about the dark web and go check out the FBI articles and stuff like that. I think it's pretty entertaining. It's fun to look at. So what is the term for an exploit that is used to gain control of a system remotely? That would be a remote exploit. And we are moving on. So the vulnerability lifecycle. Let's talk about this. The DoD, the Department of Defense, has implemented a vulnerability disclosure program that uses the widely recognized lifecycle of vulnerability framework, which is, what is this on? This is this SCIF, Lifecycle of a Vulnerability, the National Security Institute. Interesting, I didn't know that this website existed. So this is another cool one. So they use the lifecycle of vulnerability framework to better understand how vulnerabilities can be mitigated earlier. Vulnerability Development or Disclosure Program, a VDP, a Vulnerability Disclosure Program, typically involves the triage, validation, and mitigation facilitation of a vulnerability report submitted by researchers. And the 5 stages are discovery, coordination, mitigation, management, and lessons learned. So the product is launched, vulnerabilities discovered, development of a POC, development of the patch is then released, and the patch has been applied. So the vendor in the public market launches an information technology product, so it could be hardware or software. They discover a vulnerability, and researchers working independently or sponsored by public-private organizations, ethical hackers, pen testers, whatever, they discover it. A 0-day vulnerability is something that has never been found before, so it's the first time that they found it. And when they find that, when it's found, it's made available to the general public via the internet or other special sources. And then before it's publicly disclosed, the manufacturer typically has already developed a patch for it. Obviously, if they didn't, I mean, it would cause a panic, right? It would cause a stir. So then they develop a proof of concept or exploit. So the vulnerability has been discovered. Then they develop an actual exploit or proof of concept to exploit the vulnerability. And they need to make sure that it actually is a viable vulnerability that can be hacked. So you keep the disclosure discreet because it's typically the first stage in developing an exploit, and bad actors can use it in the wild. So if you publicize the exploit and you let them know that this is what it is before having the patch, then people can actually use your own exploit against you. Patch development or update is when they actually patch it, and they actually, they develop the patch for this exploit right here, then they release the patch, and then they actually install the patch. So they release the patch for the vulnerability so customers can apply it, and the customer and user will update or patch the system. And usually, like if you have a Microsoft machine, there's updates that happen all the time, and a lot of times people don't even read what the update is about, but usually it's about something like this. There's something that has happened that they want to get ahead of, and they develop the patch for it, and they just release it on the software update. And it's important for you as the user to always have your machine updating, because you never know. You never know what vulnerability may have been discovered that there is now an exploit for, and your computer could be hacked. And if you have some sensitive data or pictures that you don't want people to see or something like that, then you definitely want to make sure that you patch your system. So a vulnerability not patched by the vendor and unknown to most people is called a 0-day, I believe. Yeah, 0-day vulnerability. What is a commonly used term for the demonstration that proves the exploitability of a newly discovered vulnerability? And that is the proof of concept. And what does a product manufacturer typically release to prevent a known vulnerability from being exploited by adversaries? And that would be a patch. And we are making some good progress here. So let's move on to opportunity for weaponizing vulnerabilities. Weaponizing vulnerabilities or creating exploits on those things is a process that obviously requires a lot of understanding of the target resource. It doesn't matter if it's software, hardware, or any other system. You just need a lot of good understanding. This is why they do reconnaissance, or we do reconnaissance a lot, or when you do a pen test or something, they give you access to all the resources that they want you to try to attack. Or if you're doing security engineering on a web application, they typically give you access to the source code and things like that, just so you have all the information that you need. And then you create an exploit that involves the steps that literally depend on that target system. Time, expertise, knowledge of the target, all that stuff is very, very important if you actually want to weaponize a vulnerability, right? It can be weaponized by locally developing an exploit or purchasing it from suppliers. So we already talked about this. And this is kind of the extra steps that you go through the V vulnerability something, what was it? Vulnerability development lifecycle, vulnerability disclosure program, the lifecycle of a vulnerability framework. I think that's basically what we were talking about. But so the vulnerability is discovered, development of the exploit, and then that goes right here. And as soon as there's an exploit discovered or developed, there's a CVE number assigned that we just talked about, which is not in the vulnerability disclosure program, but it was actually a part of the first piece right here, the National Vulnerability Database. So this is where we find all of the CVEs, right? And so you see it right here as well. It shows you the severity 8.8 high, which means you got to take care of that now. So if you're looking at your list of vulnerabilities and you see that there is only, there's these, or it might be like low level vulnerabilities. When you look at stuff like that, you want to take care of the high stuff first. Like it should be simple to understand. It should be like very common sense, but some people, I don't know, don't understand it. Some people go by the ease of the patch. Like if it's easy to fix, they'll go by that, but you need to go by the actual severity of it and how bad the damage could be, so on and so forth. So a CVE would be assigned and the patch is developed and everything up until this point. So between these 2 points, right, between these 3 points is the 0-day exploit. And then once the patch has been released and there's a CVE that's been published, now it is the, I guess it's called an end-day exploit, which essentially means that it's now known and it's not that big of a deal. So the end refers to the number of days elapsed since the patch was released. So if we were to look at these things right here, you see how it says 2024. These have all been released in 2024. But there are patches that we can, like if I just actually go to Google and literally type in CVE 2013, for example, you'll see a bunch of things that come up, right? CVE 2013, 2022, 3900, 2013, 2013, so on and so forth. So there's, for every year, essentially, for the years that these things were discovered and patched is what you're going to, or published, excuse me, patched and published is what you're going to see the attachment of the year to it. But prior to that publishing, it's a 0-day exploit. And companies will pay you a lot of money to discover 0-day exploits, by the way. So if you can hack Microsoft and find some kind of 0-day exploit that they're not aware of, obviously, because they would have patched it. If you can find it, that means they haven't patched it. So that means that it's probably something that they don't know about. And that is actually a really good thing. So the window of opportunity for resource exploitation depends on several factors, including availability of the update, discovery time, failure severity. The 0-day vulnerability can take a few days to several months or even years to discover. 0-day attacks are typically targeted as specific targets, and it takes a lot of time and effort to find those things. And end day refers to when the patch is available. So we already talked about that. The data when a vulnerability has been discovered is typically unknown. However, CVE databases show the dates on the CVE ID assignments, which we already talked about as well. Adversaries with access to updated software can reverse engineer the patch to find the vulnerability according to the exploit database, which is a really cool website that we've used a lot. And this is another place that you can just go and search for different things to try to find exploits for them. So if we do Microsoft and look at that, there's so many freaking exploits that have been created. There's 141 pages of exploits that are available just on Microsoft and by a bunch of different exploit authors and so on and so forth. So the exploit database is a really big one. It's a really fun one, actually. There's a lot of cool stuff in here that you can try out. Of course, responsibly. According to the database, most public exploits are created in the first week following the release of a patch to offer their clients more time to upgrade. Certain manufacturers might postpone the announcement when a CV is formally released. The public can immediately access information about it. Most security providers begin creating their vulnerability signatures and prevention strategies at this time to ensure mitigation from threat actors. So, can it take days, months, or even years to develop an exploit? Yes, it can. An exploit developed once the vendor has released the patch is called a public exploit. Or no? Actually, you know what? I think that they're looking for an end day. Yeah, end day is what it is. So an end day vulnerability or end day exploit. So now let's talk about exploit chaining. Exploit chaining, or multi-stage exploitation, is when you connect multiple exploits together. So you string together multiple exploits to be able to gain access or break through a vulnerability. The desired goal is to complete remote code execution chain, or at least for the exercise that we're going to be doing in a little bit. And all of it really just goes like this, right? So you do recon, which is basically you get as much information and intelligence as possible on your target, and then you develop your initial exploit to be able to gain that initial vulnerability that you can exploit, and then you kind of use that to escalate your privileges. And we've done a lot of privilege escalation rooms in the junior pen tester videos and the pen test plus videos, and you've seen that a lot. If you haven't, go check those videos out. They're really cool videos. But once you have initial exploit, and this could be literally as easy as doing some social media stalking and finding somebody's work email on their social media. And by the way, so many people still do this. Like, so many freaking people on LinkedIn put their work email on their LinkedIn profile. So this is not hard to do. And you get access to their work email, and then you use something like Hydra or John the Ripper or Cain and Abel, which is like amazing softwares for cracking passwords. And you use that email address and you freaking crack their password, and like you get access to their username, their work account, and then you're off to the races. And now you can try to find a way to escalate your privileges and get access to a higher login. Somebody, maybe that might be a manager, or somebody could be a domain admin, something like that. And then you get persistence. Persistence means you stay in the system, so you don't have to rerun this process over and over and over again. Because if they find out that you did this, if they find out that you did the initial exploit and they patch that, that means you no longer have that entrance into their network anymore. So when you do persistence, you actually stay in the system. You stay inside of their network, allow you to continue down this path that you got. And then from there, you do lateral movement, which is basically moving laterally through the system until you find something that is juicier or more informative or more sensitive, or something that basically has what you need. And then you would do remote code execution at that point to execute whatever the code is that you want to get whatever you want out of your attack vector. So if you're trying to extract data, if you're trying to crash the system, whatever it is, once you're in the machine that you want to be, once you're in the user account that you want to be, is when you execute your remote code, and voila, you have done pretty bad damage. So it's important to note that chaining exploits in tandem can be a highly effective technique, as it allows them to bypass multiple layers of security to gain access to sensitive information. Therefore, organizations must keep their systems updated and patched, and implement proper network segmentation and best security practices to minimize the risk of such attacks. So if you want to be a good security engineer, if you want to be a good security analyst, you have to think like a hacker, okay? That way you can actually do this part. Keep the systems updated, patch them, network segmentation. Like, network segmentation means break up the network into multiple segments. So if somebody gets into one part of your network, they don't get access to everything else, and you can cut them off easily. So that's very, very important. It's called containment. Technically, that's the word for getting, once you find somebody, you contain it so that the damage doesn't spread. So what is the technique called? To string together multiple exploits. And so we have exploit chaining. I think that's the one that they're looking for here. So exploit, come on, chaining. After initial access to the system, the process of gaining higher access within the system is called privilege escalation. And the step in which the adversary tries to maintain long time access is called persistence. And we are making good progress. So now let's move on to chaining multiple vulnerabilities, the actual exercise here. So I'm going to start this virtual machine, and I think I have to start the attack box as well. Yeah. and we're gonna have some fun. So I will come back as soon as these things are loaded. It's gonna take a couple of minutes for them to load, and then we'll get into the exercise. Okay, here we go. Our virtual machine is up. So let's read through our little situation here. We're doing the exploit chaining to exploit a vulnerability, yada, yada, yada. We connected our machine. Here's the scenario. So Bob is a security engineer with Chat AI, and he's been tasked to exploit a web application that is at our IP address /AI. As the initial assessment, the pen testing team has done, some of the vulnerabilities in the web application are SQL injection and arbitrary file upload. The goal is to chain these things together to execute some code. The first and most crucial step is exploiting a target system is finding and using a vulnerability that provides an initial entry point. So in this case, such entry points are typically acquired through SQL injection, which further escalates arbitrary file upload, and then you can do remote execution. The easiest way to check for this is to use a special character. So for this case, for example, if we go to AI login.php, right? So, and by the way, we talk about SQL injection here, which is I think another room that we may have already done. Yeah, so I've already done this room, and there should be already a video on this blind SQLI, Boolean based, time based, all these things. So you should already have this video for SQL injection. If not, drop it in the comments. So if you don't find it inside the channel videos, which this is our channel, by the way. And by the way, just over the last week, we got over 1,500 new followers. This was insane. This was like, I was literally shocked as this was happening. I was like, what the hell is going on? But if you go here, I mean, I might as well do it here. So SQL injection, let's search for this. So what do we got? We got security threats, how to hack websites using OWASP top 10. This is the Splunk, threat modeling, red team tactics. I mean, there seems to be a lot. I don't know which one it is, but there seems to be a lot of videos on SQL injection. But so if you don't find this specific room, where was it? This one. If you don't find this one in the course contents, or not the course content, the channel contents, if you don't find this one that has these things, let me know and I'll record a video specifically on this thing. But please go through everything first before you drop a comment and say that you couldn't find it. Just do like a quick little view of the timestamps, because the timestamps always match the actual sections right here. So the tasks, the timestamps will actually match the tasks. Anyways, that's where you can learn more about SQL injection or any of the other videos that were there. So after doing that, we found that we got this little section that has our login page. And then the input fields ask for username and password. So if you enter test@chat.ai, and I'll just do this. I'll actually do this right now so that we can kind of go through it. But if you do test@chat.ai versus this little apostrophe at the end, this is what's known as a special character. When you do something like this, you will get a different kind of a response from the system. And so we're actually going to do it right now, just so you can see what that situation looks like. And this is what SQL injection means, right? When you can do special characters and then start putting in various types of commands and requests into the actual URL, that is what we're doing in this case. So let's go here. So this is our login page. And so I'm going to do the second one. So we're just going to, actually, let's do the first one. So that's the username and password. And so, oh, just gives us a basic error. So now if I just put an apostrophe at the end of this and do that, undefined, okay? So it was not an error, it just says undefined. And it says, notice the special character. He discovered that the application is probably vulnerable to SQL injection and now aims to exploit this vulnerability. So the term undefined should not come up. It should just give you error again. But in this particular case, it gave us a different type of error, which is undefined, which can lead us to believe that this is potentially a vulnerable system. So now we want to exploit it. So we're going to use SQL map, which is a command line tool to find and exploit SQL injection vulnerabilities across all the major databases. And we can learn more about SQL map here, which I have not used before. It seems to be an easy one. It's like a pretty quick room. Yeah, it is an easy room. So maybe we'll do that later. Not right now, for sure. So it requires an endpoint. So SQL map requires an endpoint to exploit the injection vulnerability. And the way that we can do this is how scary this can be sometimes. So you can either do it through Burp Suite, right? Or you can literally just click on this, inspect, and it'll now show you the stuff that's happening behind the scenes. And then there's something right down here called the network that shows you what is actually gonna be done here. So if I do this one more time, right? So if I literally just go continue and run that, now there's something that shows up at the bottom here. And look at that. It's user login, email test, chat AI, password test, yada, yada, yada. So that's our actual full link, right? So this is what it will look like. You have the domain up until AI, that's the regular part of the domain, then includes then this piece right here, which literally we just saw, right? And so in this particular case, it was under general, and it shows the full request URL. So wait, hold on, let me zoom out a little bit. And if I go here, and if I just do this, oops, it actually took me here, not what I was trying to do. But I mean, that's it. I just double clicked it, and this is the full URL. That's it. That's our full endpoint that we can now use to do some manipulative stuff. So how easy was that? How crazy is that? You literally just do right click, you go to inspect, and then you go to the network tab, and then you just resubmit the information, and now it gives you the freaking URL. That's crazy. Okay, here we go. So you don't even need Burp Suite for this, which is, it's scary. Like, some of these things are scary to think about. Anyways, moving on. So now that we have the endpoint, we can now open the terminal and execute this following command to use SQL map and do some funky things. So here's what we're gonna do. We're gonna open up the terminal, and we're gonna type in this command. So let me first copy the URL. Okay, and oops, let's open the terminal back up. All right, so here we go. All right, so very, very basic, very similar. In this particular case, I think they didn't actually use the version of the email with the special character at the end. So if you notice right here, it just says chatai.com and password, whereas in my version, it gives you the URL encoded piece of the what an apostrophe looks like, which is %27. So I'm just going to delete that %27 portion just to match everything that's going on earlier. But I feel like that should work anyways, but we're just going to delete that just to match. And so we have the test at chatai.com, and then at password, which is, for me, it's just test. They put 1, 2, 3. The rest of the command is what it is. So now we're just going to press enter, and everything should happen the same way here. Look at that. So testing, so on and so forth. And so we're just going to scroll all the way down and see what we get at the end of this. So it says the above command will exploit the SQL injection vulnerability as well as chain it to an arbitrary file upload attempt, which uploads a file stager into the root web directory that can be accessed by typing the domain name at port 80, so :80, and then this is the file into the browser. And then now we can see that we have a little uploader that we can actually upload some things into. And the malicious file allows us, or Bob, to gain initial access to the server. Now Bob has opened avenues of exploitation for him, as he can upload any file and execute it. He creates a simple PHP-based backdoor that will allow him to run any command on the server. And this is it. This is the PHP backdoor. So we're going to create one of these as well, and then we can upload it into the system, and we should get some kind of a result. So in this case, what is the response when we enter the apostrophe version of this? And so I think it was undefined, right? Yeah. And then execute who am I. What is the output that you receive? I see, actually, so there it is. This is where it goes. So you put it right after the file. So hack.php, which is the file that we uploaded. Once we upload that file, we can go to that URL and then attach the command itself via a question mark and then whatever the command is. So in this case, the command is dir, D-I-R, which lists all of the files that are inside the current directory that you're in, which is this particular directory, and it gives us all the files. So that's how we execute our command. And then is there a flag text inside of it? What's the flag value? How many files are available in this folder? And so very, very basic, easy set of commands that we're going to execute. So let's see, it looks like the back end database is MySQL. Do you want to skip the test payloads specific for other databases? Yeah, why not? And for the remaining, do you want to include all tests for MySQL? Yeah, why not? And not exploitable with null values. Do you want to try with a random integer value? Yes. Okay, I'm just going to wait until this thing finishes, and we're going to get our final task. So actually, while that is happening, I'm just going to create another terminal, and we're going to create our PHP code here. So we're going to do nano hack.php, create a file. Here we go. Okay, I think that's it. So PHP, if set, yada yada yada. I just like typing things out, but just to make sure that I did it right, I'm gonna see if I can just copy paste this on top of this. Oh, it is exactly the same thing. Yeah. So unfortunately, you literally can't do it the way that I thought you could. So we're just gonna erase it this way, and I think this thing in the background is still running. So let's see what else we need to do to make sure that it just completes what it completes. But for now, we have our script. So we're gonna close this out. And so if I do nano hack.php, I should have a script now. Nano hack.php. There it is. Okay, cool. So let's see. Do you want to keep testing others? The parameter email is vulnerable. Yes, test the other stuff too. This is pretty cool. The SQL map thing is pretty cool. It's literally mapping everything that has to do with that endpoint to tell us what all of the different vulnerabilities are. Payloads to, it is very important to not stress network connection during usage of time-based payloads. Do you want SQL map to optimize values for relay responses? Yes. I'm just going to keep saying yes to everything. Which web application language does a web server support? It's going to be PHP, or excuse me, number 4. There we go. And it says the backdoor has been successfully uploaded on this. Calling OS shell to quit, type X or Q and press enter. So it seems like we have a shell already. So what if I do dir here? Yes. Huh. I'm already here? What? How is that possible? Okay, they ended up in the same place. The OS shell is where they actually ended up as well. So I'm in the right place. I wonder why we need to even do the other thing though. So who am I? It says NT authority system. So I wonder if that's it is the answer, isn't it? So NT authority system. That's exactly who we are. How we noticed the flag.txt in the web root directory. What is the flag value? So is there a flag.txt? There is a flag.txt. What is going on? I don't even need to do any of the other stuff. So cat flag.txt. Let me see if it shows. Oh, cat is not. Okay, so type flag.txt. There's the flag. What is happening? This should not be this easy. I feel like we were supposed to upload something else into it. But whatever. I mean, we're getting all the answers. So how many files are available in the XAMPP image folder? So let's go inside. This is the folder right here. So we are going to, since it is a Microsoft, as it seems, and none of the Linux commands work, so we're going to do cd xampp, and we're going to go inside of that thing. And then now that we're, oh, there's nothing in there, so dir. Okay, so I guess I can't go in there, so let's see, if I do dir and I do the exact string. So if I do dir, and we're going to do okay, that worked. So we just did dir, and we did the actual entire path right there. And there are 2 files in here. So I'm going to do 2, and that's it. I didn't even need to upload my script that I made. I'm kind of upset about that. I really wanted to upload the script. How did they even, what is happening here, bruh? Okay, whatever. Oh, you know what? I think this is what it is. Like, so, okay, this is what they found, right? So they found this actual file right here, which is the UKMPF, these things, these HP files right here. They found these files, and they just went to one of those files, and they found out that it's an upload directory. That's basically what it was. And instead of doing what we just did manually, they literally just freaking did it. Or maybe what's happening is that since we're using SQL map, it's actually uploading the file directly for us, and we don't need to do it. So I didn't even need to create the file. I think that's exactly what happened. It literally says it right here. So it says it's going to exploit the vulnerability as well as chain it with an arbitrary file upload attempt, which uploads a file stager in the root web directory that can be accessed by doing this. So this file has already been created from what I gather. So you saw that I didn't upload anything. So let's actually go to this domain and see if it's already been uploaded for us, which I think that's exactly what happened. Instead of me having to upload anything, the SQL map did it for us, which is actually very convenient. So port 80, did I do port 80? Port 80, TMP, UKMFP, TMP, UKMFP, .php in the browser. Oh, no, it's not found. Okay, so I guess that didn't work. So never mind. Whatever, man. I mean, it worked now. I don't know. Gosh, what's happening? Okay, so maybe if I did this then. So let's see. Nope. So the issue seems to be that there is no path that is this path. That's the thing. I'm trying to find exactly what this path is, and there is no path like this. And that is the part that I'm kind of upset about, because I really want to find that upload page too, even though we don't need to, because we actually got access to everything and we were able to pull this off without doing that. I just want to be able to do it, and I don't know why I can't do it, and that's kind of upsetting to me. So let's find one more time. We're going to confirm this one more time. Okay, so that one didn't work. I think it's this one actually. So this particular one, that is the file stager. So the file stager is probably the link that we got to go to. And there it is. Oh, I feel so good about this now. Finally. I actually have it. So now that means I can go and upload my hack file and then upload that mofo. And now it has actually been uploaded, which means I can now run the freaking test. I uploaded it in the wrong place. Hold on, I'm gonna upload it in the root folder instead of uploading it in that. I'm gonna upload it here. Okay, file uploaded. So now what we can do, we should be able to just run hack.php $cmd equals who am I? And there it is. Yes. So all of the commands that we ran previously, we can now run here. And I am so freaking happy that I persisted and I figured it out. And all I had to do was read the instructions. So many things could have been, so much time could have been saved by me just reading some instructions. Okay, cool. We're done. We are officially done. And now we can figure it out. So which means that all of the other commands that I also ran, who am I, and opening of the flag text in the directory and all of that stuff, it could have been done by just using our web shell right here. Not web shell, but I guess it technically is a web shell, but yeah, it could have all just been done through the URL, or it could have just been done through the command line because it created a backdoor for us already, and we could just execute via OS query, which was inside of this, or OS shell, excuse me, which was inside of that. So anyways, we are done, we're finished. Now we can move on to the final task here. All right, now that we have seen how somebody can chain multiple vulnerabilities to exploit something, we need to do the other side where we use scripting to make our lives a little bit easier. Without automation, a lot of this could be very time consuming, and obviously human error is a big deal, meaning that you can miss it, you know, because you're imperfect, you're a human being. I am a human being, we're both imperfect, and it makes it a vulnerability when it comes down to analyzing for security. So a lot of different ways that we can do this is using scripts themselves, tools, platforms that do security orchestration, automation, and response, which is called SOAR systems. And these are systems that can kind of integrate with SIM systems like Splunk and things like that, that can make your life a little bit easier. So a script is a really good one, and this is one that I'm actually going to save for myself as well, that basically does a search through the system for any malicious keywords like shell, apt, SQL error, hack, all these things, and you can add more words to it. So this comment right here says that this is the list of the bad words, and you can add as many words to this as you want. And then the path itself is going to be errorlog.txt, which is the log that you want this script to search through. And then the file itself, it's going to open the path for the file, or it's going to open this file, which is the path that we assigned right here, and it's going to open it in read mode. And then while this FEOF, while the file is open, I want you to go through each line, and for each keyword as the keyword, I want you to go find it and then say that the malicious keyword has been found in this file and basically notify me. So a very, very simple script that goes through whatever the file is that you assign here, and it searches for any of these words, and then it'll tell you if any of those words actually exist in your file. And that's basically the script. So very, very easy script to use. I'm going to use it, and it's something that I think you should also try to use. So I'm gonna do this for you. I'm gonna do this super slow, or you could literally just go and get into this room and get access to this, but I'll do this. I'm gonna do this for you just in case you want to take a little screenshot. So there's the script, and you can take a screenshot of that and then create your own little script, and this will search whatever computer you're on for these specific words for the file, yada yada yada. So there you go, that's the file for you, and you are very welcome. So now we can do scheduling tools, which is basically another way that you can automate something, which means that every time that you open the computer, this script will run and it'll check for vulnerabilities for you on the files that you have declared, which is again very, very useful. So at runtime, or at specific times you want this script to be ran just so it can see what's going on, and it'll make life easier. It'll make things happen faster. You can literally have it be done by the minute. You could have it run that script every single minute just to see what's going on, right? Cron jobs and Windows Task Scheduler. Cron jobs is something that's on Linux. Windows Task Scheduler is on Windows, as the name implies. They allow us to automate vulnerability scans, backups, software updates, and a lot of other things. And you can use a tool that does vulnerability scanning and automate the identifying and analyzing of vulnerabilities in the network, and it can scan the network regularly, detecting vulnerabilities that may have been introduced, and it can then generate reports that have been found for you. So literally you could just make this script or any kind of a script, and you can schedule it to run as frequently as you want. And within the script you can also create a set of commands that will generate a file for you that will give you the report instead of you having to read it on the screen, and then you can just go check the most recent report. Or you can write another script that reads the reports and it says, hey, this is a problem we just found, yada yada yada. So a very, very cool series of effects or attempts and automation that you can do. And then there's SOAR, which is just really freaking badass. Security orchestration, automation, and response are tools that have been generated to do all of this stuff for you with a couple of clicks and a couple of file uploads. They provide a centralized management interface for automating and orchestrating security tasks. They automate incident response, threat hunting, incident management tasks. Additionally, they can be used to integrate with other security tools such as firewalls, IDS, SIEMs, so on and so forth. Shuffler.io and Splunk are a few of the renowned SOAR platforms that you can explore. And these are just some things that you want to keep in mind when you're doing this. You want to test your scripts, obviously, in a controlled environment before you actually deploy them. You want to ensure that the scripts and automating tools are documented and easy to understand. Use logging and monitoring to keep track of the tasks. Review the automation and security checks regularly to ensure that they're still practical and relevant. And keep the scripts and automation tools updated and patched to address anything. So this is a course just by itself. Okay, they had one little task assigned to this, but automation of security is a course just by itself. We could probably do an entire freaking 5-hour video on this. So it is important to ensure that automated scripts are acquired from legitimate sources. Yeah. Okay, and there it is. We're done. We are officially done. If you found any use in this video, if you learned anything exciting, I want you to go to the subscribe button and click that subscribe button. Join our community. It would be awesome to have you. Something that I want to show you that was extremely humbling. Honestly, it was amazing to see, was when I went through our comment section and looked at look at this. This is pretty insane when you think about it. It just keeps going. There have been so many comments that come through here that some people just say thank you. Some people ask some real questions. Some people just notify me of the updates of their path when they're studying for their stuff. And it's turned into a really big community. Like, it's still going. Like, this is still going. So this is something that extremely humbling for me. I'm so happy to see that people are actually finding value from the channel and joining the community. So I would very much love it for you to actually join our community and just drop a hi in the comments, or if you have any questions, let me know. And I will definitely make sure to reply to you, because I reply to every single comment that comes in. And if it's a big question that's inside the comments, I'll go ahead and make a video from it. So it's still going. This is one of the most humbling experiences that I've gone through in my life. So I'm very, very happy to hear and to see that people are actually finding value from our channel, and it's growing the way that it is. So super happy, super happy, and would love to have you be a part of the community as well. So go ahead and smash that subscribe button, like the video, drop a comment if you have any questions, or if you just want to say hi. And yeah, I would love to see you. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. I hope you found this video useful. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video. what is DevSecOps and how did it even start? And what were the previous models that came out before DevSecOps? And of course, they have to be all introduced to us in this wonderful theme of Star Wars. You know, no copyright or anything intended. And how does it all work? What does shifting left even mean? How can we actually use DevSecOps to make sure that security teams and development teams work well together? And finally, we have the little game that we played at the very end. I don't want this to stay on too long just because I don't want to give it away. But we played a little game at the end as well, just so we can make sure that we understood everything that was going on inside of this course or inside of this particular video. And yeah, without further ado, let's jump into the introduction of this particular room. All right, so we're going to learn the history behind software development and how they've evolved over the years and what it actually makes DevSecOps. So DevSecOps is just a security arm of DevOps, which is development operations, essentially. And development operations refers to software development. So DevSecOps is just a branch of that, and it's a very, very important branch of DevOps, and we're just going to understand the culture and the discipline of it, and we're going to go through some of the very, very important portions of this. And this is the first room in this particular path, and this is actually something that was recently developed in TryHackMe. It is, oh no, you know what? It's 712 days old, so it is not recently developed. But it is a free room, so if you definitely want to go check this out, you're more than welcome to. And there is a view site button at the end of this where you actually get to use the stuff that they teach you. So this is a cool one. DevSecOps is a really, really big field, and there's going to be a lot of people that will need to be going into this field because it's one of those big branches of cybersecurity that there's constantly being recruiting done for. And it pays extremely well. So if you actually want to go into software development, or if you understand code and if you like code and if you want to be around the development of software, then this is one of those really big fields where you can make a crap ton of money if you're really good at it. So that's the other part, right? So you got to know what the hell you're doing and you got to be good at it. So that being said, let's actually jump into just the story behind it and what DevSecOps is, and we'll kind of get into some of the nitty gritty. All right, so here's a corny joke for you. A long, long time ago, there were waterfalls in a galaxy far, far away. That is the security person's version of a joke that they used that they got from, I wonder what movie this is from. Okay, so the first model for project management was called the watermelon model, the waterfall model. The first version of that was the waterfall model. And it worked based on a hierarchy, as you can see right here. And this is what kind of the term waterfall came from, right? So you start with analysis and you go down to design, implementation, testing, maintenance. And this is back in the 70s. So this is already 50 years old, okay? So the admin worked tirelessly to keep everything running smoothly and afloat, and developers built and added as many features as possible. And finally, quality assurance engineers test the system functionality, ensuring that everything worked. And if anything troubles the server, if anything needs deployment, sysadmins have to jump on it. If it's a code problem, developers will put out the fire. If there's anything to do with testing functionality, quality assurance goes into it. But what if there's a flaw, a bug? Who fixes that? And these are situations that led to many blame games and passing the baton around the creation, and then friction would have, and then backlogs would be, and everything just kind of goes downhill, not in a good way, right? So customer expectations grew, features and releases were released, and responsibilities would end up being big messes, and bugs and security flaws were again backlogged, and a lot of these things were unresolved. And this was something that ended up being a pain in the freaking ass for all the people that were involved, especially the people that are using the freaking software, right? So this and the system became a root cause of ineffectiveness in flexibility and communication across all of the teams that were involved. And then we have the agile model, which is a little bit more current. And this is what's actually happening nowadays, which is something, I've heard a lot of companies still using agile, and I see it in job descriptions all the time. Agile is not specific to cybersecurity or security engineering. It's a project management model. And so because there were so many challenges with the waterfall model, there was something that needed to be for flexibility and adaptability, and then the agile model came around, and then there's something called the Agile Manifesto. Look at this thing. This looks, for God's sakes, what the hell? This website has been outdated forever. You can look at this, man. This is literally, just this website gives me anxiety because the image, look, this is the same image and it's been, what is this called? Cascaded, I think. So they are using the same image over and over and over again. And just by itself, it's like, who made this? You couldn't make something a little bit more pleasing to the eye? Well, whatever. This is the manifesto for agile software development. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to the value individuals and interactions over processes, and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to challenge over following a plan. That is, while there is a value in the items on the right, we value the items on the left more. Goodness gracious. Honestly, all these people, although I'm super excited that you guys exist and you've done this for us, you could have done a better job of freaking writing this. And then we have the 12 principles of agile software, and you better guess, look at this. I'm not going to sit here and read this. You are more than welcome to go to agilemanifesto.org and read all this shit. But yeah, that's basically it. So this was developed, and yay. And individuals and interactions over processes, working software. I just read this, so I'm not going to reread this again, but this is the agile model, right? So you analyze, plan, design, build, test, review, and then launch the damn thing. And then DevOps, A New Hope. Of course, they are ripping off Star Wars as, oh my God, look at this. In 2008, a conversation between Andrew Clay and Patrick Dubois led to something quite revolutionary. Discussing the drawbacks of agile, DevOps was born. After an event in Belgium the following year, DevOps Days became the next buzzword, and its popularity increased. And it's quite different from the previous methodologies because it focuses on driving cultural change to increase efficiency. It does this by uniting the magic terms, the magic of all teams working on a project using integration and automation. With these ingredients, you can get cross-integration across all departments, quality assurance, sysadmins, developers, all at the same time. For example, ensuring developers can now be involved in deployment, and sysadmins can now write scripts. QA can figure out how to fix flaws versus constantly testing for functionality. By introducing automation and integration of systems, these engineers can now have same visibility at all times and interact accordingly. We will dive more into this in a little bit. So why is this important? If you haven't already been able to put two and two together, it's important because it makes sure everybody is using each other at the same time. Like, it's cross-pollination almost. They're working together instead of passing the baton back and forth and waiting for one team to finish while so that they can do their job. It's like, it's collaborative. You use that term a lot, you hear that term a lot, but it is collaborative, and it helps align tech projects to business requirements, increasing the impact and value of the business projects, and it becomes more efficient and prioritized accordingly. And changes rolled out are usually small and reversible, visible to everybody, and it makes everything just super fast and increase competency when delivering the work. So it's very, very important. I am not going to read this because we just went through all this stuff, but it's important to understand the history of DevOps. So that's how we got to where we are. It is the declarative approach and requires users to specify the end state of the infrastructure, deploy these machines in a running state directly into an environment, automating the configuration choices throughout the workflow. The software builds it and releases it with no human interaction. That's basically where we have ended up to now. You come with the goal in mind, and the software takes care of it for you. So very, very, very important to understand this. And I mean, we are in the age of AI, so this shouldn't be news to anybody. So I've already answered these questions, but we can kind of go through it. What methodology relies on self-organizing teams that focus on constructive collaboration, and that is the agile methodology? What methodology relies on automation and integration to drive cultural change? That would be DevOps. What traditional approach to project management led to mistrust and poor communication? That was the waterfall. And what does DevOps emphasize? It emphasizes the building of trust. So this is our little history lesson behind why DevOps was created and how it was created. So let's talk about the infinite loop of DevOps. So it starts with the plan, and we go to the code, build it, test it, release it, deploy it, operate it, monitor the damn thing, and based on all of this stuff that you found in these stages, replan, recode, rebuild, retest, re-release, etc., etc. So it is an infinite loop, as the name implies, and it never ends. Very unlike the waterfall and the agile model, it's continuous. And the infinite loop expands some concepts that we need to kind of really understand and wrap our head around. This is going to be something, again, that you're just going to run across all the time as you go into DevSecOps or DevOps in general. So CI and CD is something that comes up all the time. Continuous integration and continuous development. Continuous integration and development deal with the frequent merging of code and adding testing automated manner to perform checks as new code is pushed and merged. And you can test code and push and merge thanks to a dynamic and routine in deployment, which takes the form of minor code changes systematically and routinely. And thanks to this, it detects bugs early and decreases the effort of maintaining the code. So continuous integration and deployment. And to make something like this happen, to make this whole thing happen, you need something like infrastructure as a code. And this isn't too far from infrastructure as a service, by the way. So infrastructure as code is a way to manage and provision infrastructure through code and automation. Thanks to this, we can reuse code that's been deployed for infrastructure like cloud instances, meaning if you want to create new virtual machines, instead of redoing the whole thing, you just duplicate one instance that you created and you multiply that by 100, and you say, I need 100 new versions of this thing, and just like that, boom, you have 100 new virtual machines. Super, super easy to do, super quick to do. And it helps inconsistent resource creation and management. And standard tools are Terraform, which I've used a lot, or I shouldn't say a lot. I have used Terraform frequently enough to know what the hell it is. And again, super freaking easy, you guys. It's so easy with Terraform to create a bunch of virtual machines on AWS, for example. It's insane how easy these kinds of things become. Vagrant is another one. And we're going to be using this in the path of DevSecOps later. I don't think it's going to be covered in this room. Then we have configuration management. So we state infrastructure is managed constantly and applying changes efficiently, which makes it much more maintainable. And thanks to this, time is saved. Time is a big freaking deal in coding. And it's just a pain in the ass to just have to recode things and manually copy paste things and do a lot of things like that. You could literally just, with a couple of clicks, this is what I love about the new world. People are like upset about it. It's like, no, bro, it just saves time for you to do the really important stuff and then do more big projects and things like that. Then you have orchestration. It's just automation of workflows. Think about an orchestrator, think about an orchestra, the maestro at the in front of the entire room that orchestrates everything. It achieves stability, for example, automating the planning of resources. We can have fast responses, and it can be achieved thanks to monitoring, which is right here. So it focuses on collect data and look at the performance and stability of the services and the infrastructure. And then once you have that, you can do faster recovery, cross-team visibility, more data to analyze for better root cause analysis, and generates an automated response, as mentioned earlier. And then you have microservices that breaks an application into a lot of different pieces that allows you to figure out how to scale things if you need to grow them, reduce the complexity, or fix bugs if you need to fix them, because instead of looking at one giant thing, you can track it down to see what one specific microservice crashed or has the bug in it. And then all of this, again, goes back to the top right here: continuous integration, continuous deployment, and then you use infrastructure as a code. So this is the loop. This is literally the loop, just broken down into 6 steps right here, right? So very, very easy to understand, and hopefully you can understand why this is the preferred method right now, because it makes things easier. It makes things easier, it makes it faster and more manageable. What helps adding tests in an automated manner and deals with frequent merging of all the code's small changes, and that is continuous integration and continuous development. What process focuses on collecting data to analyze the performance and stability of services, and that is monitoring. And what is a way to provision infrastructure through reusable and consistent pieces of code? And we're going to call that IAC, which is infrastructure as code. And just like that, we have the infinite loop down. So shifting left, let's see what this is. The whole idea behind shifting left is that DevSecOps teams, or DevOps teams, excuse me, they focus on instilling security from the earliest stages in the lifecycle and makes it more collaborative between development and security. So the DevOps team understands security. That's essentially what we're trying to do. And since it can be introduced early, risks are reduced very, very massively, because they're thinking about security while they're doing the developing. Before, they would do the developing, and then security would have to look at it and be like, hey, there's a bunch of security flaws in here, and you would need to fix those things and then go back into development. Now they just think about security as they're developing. Very, very basic. Security testing was implemented at the end of the development lifecycle. This was previously. And as the industry evolved, security teams would perform a lot of different analyses and security testing in the final stages of the lifecycle, and then depending on the results, they would either need to permit the application or literally go back to the drawing board. And it would cause long delays in development and friction. And so implementing security measures during all stages rather than the end of the cycle will ensure that the software is designed. I mean, this is common sense. Like, we don't need to beat this over the head, right? So it's like, if you just keep security in mind while you're doing the developing, it just makes things a lot easier. And this is what shifting left really basically means, because you're looking at this graph right here. And this is the traditional model where it would go through planning and designing. Let me see if I can zoom this in a little bit. I would go through the plan and design, development and build, and then in testing is when they started thinking about security, and then in the deployment and release is when they really started thinking about security, and then they would have to refix all the shit that was found here. When you shift this mountain to the left in the plan and design phase, and development and building phase is where most of the security conversations was done, so that as you're going through testing and deployment, you don't have to focus too much about it because most of the work has been done. And then you can try to fix bugs or new bugs as they come, or security vulnerabilities as they come around. So this is the reason why shifting left. And as we talked about in previous videos in this particular path, I think it was in the SSDLC path, as well as SAST and DAST, in these specific modules, as we talked about them, we just noticed that the cost of fixing something is so much cheaper in the plan and design phase and the development and build phase, and it's so much more expensive after you've deployed and released and you're in the actual operational phase of something. So The cost of fixing it is so much easier and cheaper, time-wise, energy-wise, money-wise, if you catch it and just focus on it in the beginning. And this is really the big piece right here, right? So it ensures these flaws are caught early by introducing processes from the start. Post-development security reviews of new software could become a bottleneck, meaning it can hold things up from being actually deployed. And even when you find a problem, it's not enough time to remediate them before the next version. So to keep up with this, you need a fast-paced environment for scaling and growth. And security is at risk of being left behind. So instilling security in the beginning becomes more flexible and adapted to a new development cycle, and increases the chance of addressing things promptly, meaning quickly. And this approach to shifting left can be referred to as DevSecOps, and we are finally here. So what term is used to describe accounting for security from the earliest stages? And that is called shift left. And what is the development approach when security is introduced from early stages of a cycle? And that would be DevSecOps. And there we go, just like that. Very, very easy to understand and pretty common sense, if you ask me. I mean, you should not need a lot of explanation for this, which is why I'm kind of skimming through this, because this should be common sense. So security strikes back. Now let's talk about this. And again, they have ripped off freaking Star Wars. So let's talk about this. What is this? Okay, so as the parody of The Empire Strikes Back. So this is what happened, right? So the value of DevSecOps is to bring down vulnerabilities and maximize test coverage and intensify the automation of security frameworks. This reduces risk, assisting organizations in preventing damage to their brand and financial losses because of security flaws, right? To do this, culture is key, which means that whole building trust thing that we were talking about earlier, that's really big in this environment, because everybody needs to communicate with everybody. Everybody needs to trust each other so that they can believe and understand that, hey, you know what, if I hand this off, if I give this responsibility to this other team member, they're going to actually take care of it. But then it requires that that person actually really does take care of it. So it is one of those things that it is a two-way street, right? So if I trust you to do something, you got to do it. If you don't do it, you hurt everybody, not just me, but you too. And ultimately, it'll be tracked back down to who did what or who didn't do what, because communication is no longer done just by one-on-one face-to-face communication. Communication is done through email and through messengers and things like this. And all of this could be tracked back to, oh, this was your responsibility. This was my responsibility to do. And one of us didn't do what we were supposed to do. And now you're going to get fired. And so this is where it all comes down to, right? So it only works with collective effort. It aims to bridge the security knowledge gaps between the teams and for everyone to think and be accountable for security. They first need the tools and knowledge to drive autonomy efficiently and confidently. So the challenges are this. There's something called a security silo, which, if you know what a silo means, so if we literally, let me see if I could do a Google search for this just so we can kind of see what it is. It brings up a TV series, obviously. So let's go to images and see if we can find, there we go. This is a silo. So a silo is basically a big ass building that contains things. So these are silos. You see this? These are a bunch of silos, right? A security silo, so now that you have the visual, it means that people are left out of the DevOps process because it's a separate entity, right? And where specialized people can only maintain and lead security practices, this situation creates a silo around security and prevents engineers from understanding the necessity of security and applying security measures from the beginning. This is not scalable or flexible because everybody's separate. Everybody is in their own little pocket and they don't communicate and they keep the knowledge, yada, yada, yada. It should be a supportive function to help other teams scale and build security. Without security teams, being a blocker, but rather a ramp to promote secure solutions and decisions. The best practice is to share these responsibilities across all team members instead of having a specialized security engineer. Lack of visibility and prioritization is a result of people operating as if they're in a silo. So to create a culture where security and other essential application components treat security as a regular aspect of the application, that's the goal. That's the culture that you want to make. Developers can focus on development with confidence about security instead of security departments playing police and the blame game and standing over their shoulder and micromanaging them. There should be trust between the teams, and security should promote the autonomy of the teams by establishing processes that instill security. So this is the job of the security team ultimately, is to actually build certain things, certain processes, and put those in place so that as the development team is moving along, you can just make sure that the process that you've developed keeps them on their path that they need to be without you having to micromanage. And as long as they follow a path that you've designed that was a good path, then they don't make any kind of a security mistake. And then finally, there's the stringent processes. And everything must not go through a complicated process and verification against before being used by developers. So this is what stringent means, is that it's super strict, right? Procedures should be flexible to account for these types of scenarios where lower level tasks should be treated differently, higher tasks and changes are targeted for stringent processes. So developers need environments to test software without security limitations. These environments are known as a sandbox, and this is something that you will hear all the time. Sandboxes are not just applied to development of software, they're applied to digital forensics when you're going through some kind of an incident response and you want to launch what you think might be malware and you don't want it to affect the rest of the network, so you deploy it inside of a sandbox. And in the same way, you want to deploy a patch to a software inside of a sandbox before publishing it. So a sandbox is a very important term to understand. And this is the kind of environment that a developer can use to just build the software and see what's up with it, just to make sure that it's actually working. And then they go through the security filters to make sure that it's actually secure as well. And this all happens during the coding and development phases without actually launching and becoming a public product. So this is what's important to understand, is that like all of these things ultimately actually allow for quick development of applications and software and business processes. And the big thing is that like teach them what they need to do, teach the development team what they need to do, give them the best practices, all that stuff, and then put them in a sandbox environment and give them some kind of filtration system that you've developed that says, hey, make sure that you don't do this or make sure you do this while they're developing the code. And then they can test the code as much as they want inside of the sandbox, make sure it actually works. And then once it works, you go over there and you're like, all right, let's look at security and make sure that all of this is good too. So it should be fairly simple once you actually have the trust and people are like, they're really in good communication with each other. So what DevSecOps challenge can lead to a siloed culture? And look at that, security silos. They give you the answer inside of this thing. So security silos. What DevSecOps challenge can affect not prioritizing the right risks at the right times? And that is what? Lack of visibility. And finally, what DevSecOps challenge stems from needlessly overcomplicated security processes? And that is stringent processes. Oh, stringent. God, come on. There we go. I should have just copy pasted that one too, but I wanted to be fancy and type it out and I misspelled it twice. Okay, so let's talk about culture and then we can go do our practical exercise. The best DevSecOps culture, or in my opinion, any kind of culture in a business, has these things. This is what's really, really important to understand. And I'm not going to read this word for word because it should be easy to wrap your head around this. Number one, you want to promote the autonomy of a team. Autonomy means freedom. They should be able to do what they think is important for their specific role in their team. You hire somebody, you give them autonomy to do what you hired them to do. That's what's important about understanding this. And it doesn't matter what size the organization is, it doesn't matter what they're doing, whether it's developing software or whether they're developing widgets. It doesn't matter. You want to hire them, and then you want to let them do what they were hired to do. And you lead by example, promote education like creating playbooks or runbooks, and to help them spot things and fix them earlier, understand the risk and confidence, all of these things. And you're more than welcome to pause the screen and read this word for word, but you should understand what this means without me having to read this word for word. So promote autonomy of the team. Then have visibility and transparency. This is like super, to me, it's very, very common sense, but it might not be for everybody. So visibility means that if you want to build autonomy in the group, then they need to have availability of everything. They need to be able to see everything what's going on so that they can make the decisions according to the information that they have. You don't want to hold back information. You don't want to hold back anything from them. It also means the same thing. Transparency is literally meaning the same thing. You want to be open and honest and give them the information that they need. Now, I understand if you're in an environment where there's security level, so there's the secret and the top secret and then all of this kind of levels of information. I understand in that environment that there is, you give them everything on a need to know basis, and if they don't need to know certain information, you don't give it to them, but they need to still have visibility and transparency so that they can do their job. So if a dashboard visualizes the number of security flaws by the criticality of the service, this helps prioritize accordingly so people can actually just look at what's going on. So there is nothing lost in the noise, or there is nothing lost in a backlog, and people can attack those flaws at the right time. The security state measure depends on the company, but it could be a number of high findings that a service might find or might not have, which determines if it's in a good security state or not. Transparency refers to introducing tools and practices that are accessible to the teams. If you present a check before merging code, the review doesn't pass and shows a message saying signature of possible code injection flaw detected, please remediate. The developer or engineer should have access to the tool that is flagging that message so they can see what's going on, and then they can remediate. These analysis tools that flag the alerts have a UI that specifies the line in the code that is actually doing this, meaning they know exactly at what line that error was happening or the vulnerability exists, and then they can go ahead and fix it. Again, this is super common sense, but sometimes people don't think about it. And then you account for flexibility thanks to the understanding and empathy. This is more of a human level strategy. This is not technical strategy. This piece right here, technical strategy. UI that tells the specific line of code, that's a technical thing. A dashboard that visualizes the number of security flaws, that's a technical thing. This is a human element. So if you want to get good at cybersecurity, and you'll hear this a lot, you need to be good at dealing with people. You can't just be a coding nerd. I mean, you can, and it's good to have certain technical skills. Don't get me wrong, okay? You need to have technical skills. But it's very, very important, especially if you want to go up the ranks and if you want to work in teams and if you want to ultimately manage teams, which means you would end up getting paid much more money. If you want to do stuff like that, you need to learn how to deal with people, and you got to be flexible. You got to have understanding of what's going on in the environment and how people work. You need to have empathy for people making mistakes or people going through life. Life hits people sometimes and people get distracted, or something happens, somebody's parent passes away, or their dog gets sick, or there's like something that's going on with people all the time. And you need to account for that, and you need to be understanding of that. There's a factor that can determine success, the level of understanding and empathy. This means that the definition of risk for security teams is unequivocal, but for other teams, risk can be different and just as precise for them. This doesn't only apply to risk to an umbrella of things. It ramifies into what they prioritize, how they work, what they think is important enough to leave aside a project with a tight deadline to fix a bug. There is no magic tool or process for everybody because you're dealing with individual human beings. It's essential to understand how developers and engineers work, what they know to be a risk, what they prioritize, what are their strengths, right? If you know their perspective, it's easier to build a process that finds common ground and has a higher chance to work versus adding another tool that creates more noise and stress for everybody. Because not everything doesn't work for everyone. That's not how it works. So the understanding builds perspective, which accounts for empathy for how other teams work and builds a process that accounts for flexibility. This is needed because every situation might be different, deadlines might be different, and bandwidth can change over time. So if you're going to be a DevSecOps engineer, suppose you took the time to understand how a team owns a service, and then they'll have a security scanner added to the development process, worked and viewed priority. It'll be easier to get their buy-in and demonstrate value to them. And if it, for example, if it's a platform team and owns an internal service, but a core service, a risk would be a bug that disrupts the service, not a potential injection that lives behind a proxy. You would need internal credentials to exploit it. You can tune the scanners or add triaging processes that tackles the question, and this would in turn build trust versus the crying wolf. The crying wolf is this concept of somebody just complaining and saying that, I don't think this is going to work. I don't think you're doing this right. I don't think this was my fault. I don't think this is my job, right? So it's like if you understand what they're doing, what their actual role is, if you understand what their priorities are in their roles, if you understand how they think, what their personality types are, and all of that stuff, you can finally deliver your solution. So if you want to add a service, for example, you can deliver your solution in a way that they would understand, that addresses their mindset and their priorities, and that gets them to buy in. That gets them to accept the solution that you're offering, and it's very, very important for that to actually take place. So this is a management concept right here. This is a management thing. This is a leadership thing. And you don't have to go into management and leadership, but if you want to, you really need to understand people, and you need to understand how that works. So how can you make security scalable so it's not left behind when startups face hypergrowth or large corporations? And what we do here is we do promote autonomy of a team. So we're gonna just copy paste so I don't have to make mistakes. And how can you support teams in understanding risk and educating on security flaws? And that is visibility and transparency. Copy and paste. And finally, what are key factors to successfully instill security in the development process by accounting for flexibility? I think it's understanding and empathy. Yeah, I believe that's what the answer is. It's not accounting for flexibility. It's understanding and empathy are the two factors that will allow you to do that. And there you go, just like that. So let's do an exercise now. So fuel trouble is the name of this exercise. And we actually have a site that's attached to this. And look at that. There again, whoever made this obviously loves Star Wars, okay? So, all right, let's go into it. Okay, so here's the story. Sekipo, X-Fighter Dev, Chuba QA, and S2A2 have been assigned to discover minerals in a nearby planet in the galaxy. Watto, the bug, is funding the mission by providing equipment and fuel to carry out the project. They are tasked to set a course and research these planets. So which software development model have they used in each case to achieve the mission? The mission is to travel to the planet with the least amount of risk possible. Accounts for 130,000 light years of travel. The models are Waterfall, Agile, and DevOps. And this is basically what we got. So Comic 1, some tests have passed to go to test doing, which was the initial decision by X-Fighter Dev. It is decided that it is the next planet to visit. Comic 2, some tests indicated that it's a high risk to travel to test doing first. Some tests have passed for Nabu, but S2D2 has decided that the course should be changed to Hoth. And Comic 3, the initial decision based on analysis by X-Fighter Dev is to travel to Hoth. Costs were questioned, and although Hoth is one of the closest, Sekipo has analyzed the trajectory and set new parameters for the test. Chuba QA has concluded to change orbit to Dagobah based on further tests. Okay, so let's see here. Okay, so I mean, they kind of give it away in these portions right here, but if we look at it here, so we see the code is ready, let's go. Some tests have passed, trajectory to test doing can be done, and systems have been deployed. So code is ready, they tested the code, the systems have been deployed, and now Homeboy comes and says, hey, how are you going to pay for all this? And if we look at this, test doing is 125,000 light years, or 125 light years, I guess, and they only have 130 light years of travel. So that's going to be kind of expensive, so on and so forth, which I don't think this even really matters. But this is, they stepped this, they did this, they did this, and then now they're going to do this. And this kind of brings the problem, this last piece brings the problem for the whole thing. And it resembles this thing. They did everything in a hierarchical kind of a manner. So let's see if this is actually right. Waterfall. Yeah, that is right. So what software development did the team in comic 1 follow? All right, so now here's the comic 2. It says, everything is built ready for testing. And then this says, tests have failed. So let's zoom in here. Tests have failed, but they pass if we go to Hackaboo. Let's do that instead. I've developed a new build, but this version is for TryHackMe, and it's better. And then Homeboy is going to say, how's you going to pay for all this, huh? So everything's ready to go. Tests have failed, and we can go to this other thing. So it's kind of like recommending a solution. And then this is another one that says, yeah, but this version is better. And the final result is what? TryHackMe is what they're saying. So TryHackMe, 80 light years, and same thing. It's going to come out and say, I feel like this question is going to come up all the time. They have 130 light years. This is going to cost 80 light years. Comic 2. Some tests indicate that it's a high risk to travel to this. First, they passed for Nabu, but SSD2 decided that it should be changed to Hoth. And we're going to say that this is agile. Yeah. And so the hint for this one, by the way, for number 1, the hint was the team decided to stick to the trajectory that was decided from the start, regardless of the hints that only some tests were passed. And then the hint for this one says the team was able to change the course as needed. However, their tests were missing and the planet still wasn't the best option. So finally, we have the last thing right here. And so look, everything's built, ready for TryHackMe. How are you going to pay for this? So it comes up early. Ejecting from the spaceship. They kicked his ass out. That's funny. Test passed. Everything's deployed. Let's go to Dagobah instead. And Dagobah, 60 light years away. So this seems to be DevOps. Look at that. So finish. And there's our flag. So not bad. I mean, it wasn't really that hard, honestly. It's kind of a easy, it's like a gimme. This was a gimme. This didn't even require much thinking. But yeah, it was fun. It was cool. Just to see how badly they butchered these characters was kind of fun. And yeah, that's it. That is it for our introduction to DevSecOps. If you had fun in this video, if you learned anything, if it was entertaining in any way, I definitely do invite you to like, subscribe, and turn on that notification bell and join our community. We have had a nice growth spurt in the last couple of days. It was actually kind of crazy how quickly we grew, and it's been really, really humbling and really nice to see what's been going on with our channel. This is literally all the comments that have come in ever since I started this channel, and there's so many people just saying so many cool things, and people are asking questions, and the community is growing. That's basically all I can say, is that the community is growing, and a lot of people have got a lot of really great information from it, and they're providing really good information to each other now. It's like this was one of those things where people are now recommending solutions to each other, and they're talking to each other. and it really is exactly what I was hoping would happen. Is it actually turns into a community, and that's exactly what has happened. So it would be awesome to have you as a part of our community as well, if you're not already a part of the community. So would love to see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video. Peace. What is Mother's secret, and how the hell can we solve this particular room? This is actually one of the rooms that I had to do a lot of homework on, just to try to understand what we're supposed to do, because they tell us to use the information that we learned from the SAST and the DAST rooms as a part of the DevSecOps, so on and so forth. And to be very honest with you, the information that we're supposed to pull from this thing is not going to be found just from going through those 3 different rooms. This is a much more advanced room than what I have previously studied, as you can tell, because I already put out the videos for the DAST and SAST. These are already here. So these videos are already here, and the stuff that we learned inside of those videos is not what's going to be, it's not what's going to help us for this particular room. So it took me a good amount of research just to try to figure out exactly what I'm supposed to even do. And a lot of the stuff that's available on Google and on YouTube, they kind of cut corners, and they don't give you the routes that they took to actually find the information that they found. So what I am going to do now is I'm going to share with you exactly how to get to these answers. I'm not going to shortcut anything, and we're going to do everything together so that you can see exactly what we did and how we found these things. So I'm excited to finally go through this with you, because it took me a couple of days to actually figure out what the hell I'm supposed to do here. So hopefully this will be useful for you as well, because this is a little bit of a difficult room. They listed it as easy, which is kind of obnoxious to think about, because it definitely wasn't easy for me. So hopefully with the aid of this video, it'll be easier for you at least. So let's jump into it. All right, the situation is this, right? Upon accessing the mother computer, aka mother, you will see the mother UI server. Since you only have a crew member level role, you only have access to limited resources, but there are other ways to access it. So what we're supposed to do is find those other ways. We're going to download the file attached to this task, explore the available endpoints, and try to find any clues. Search for a file that contains essential information about the ship's activities. Exploit the vulnerable code to download the secrets from the server, and capture all the hidden flags during the exploration. And for the operating manual, they give us a few hints here. One of them is the emergency command override is 100,375, so 100,375, and use it when accessing alien loaders. Download the task file to learn more about the mother's routes, and hitting the routes in the right order makes mother confused, and it might make it think that you are a science officer. So can you guess what is available at this particular endpoint, which is one of the flags that we're supposed to find as we go through this? And that's essentially all they give us. So what is the number of the emergency command override? In this particular case, we have this over here. So that one's a gimme. It's an easy one. And we can just copy and paste that over here. The rest of this, we actually have to find as we go through the rest of the information. So the first thing that we got to do is we got to look at these task files. And I downloaded them, and this is basically what the task file looks like. So if I kind of zoom this in a little bit and expand this so you can see what's going on. So this is it. I'm not very good at reading these types. I mean, it's Python, so I understand Python, and I understand exactly what is trying to be done here, but this is it doesn't give you the full picture, because this is just literally it's a router Python file. And so one of the ways that I kind of figured out what was supposed to be happening is I went to Gemini, and so we're just going to start a new chat, and I'm going to paste this in here. And Gemini is Google's AI, so you can use ChatGPT for this, you can use the Meta AI for this, it doesn't really matter. So I'm really just going to say, can you explain the different endpoints that are available through this file and how to access them? Okay, so here's the breakdown, right? It tells us these are different endpoints. We have the YAML.js, and you can get it through a post command, and then Nostromo.js, and same thing, it's another post request, and then the post Nostromo/mother is another post request. So basically, we need to be making HTTP requests to this. We need to be making post requests to this. So if we went and typed in something like, can you create a curl command to access these endpoints, right? So here's what it would look like. So it would be curl execute a post command, HTTP localhost port, YAML is one of them, and then we're going to be looking for the file path variable and then the file name, and that's one specific version. And then this is the Nostromo one, which is essentially the same exact thing: file path, your file extension, so on and so forth. So this is the various curl commands that we would make against this these various endpoints, but this is not enough. So this is not complete. One of the things that I was trying to find, and as you can see, this one is already running still, and it still hasn't given me much. So this is a GoBuster directory enumerator that's trying to find the different files, so .html, .js, .txt, so on and so forth. And then I did another version over here where instead of doing .js, I just did JS, TXT, PHP. And I was literally going around in circles as I was running these commands, because I was just trying to find where some potential endpoints might be, where potential supporting files might be, because this is not the full file. This thing is not the full story here. This is just giving us a few different endpoints and trying to access any of these things. So YAML.js, I'll actually show you so you can see what I mean instead of just trying to tell you. So this is the website itself, right? So this is the website that when I loaded the virtual machine, this is the IP address that they gave me. And then I go to this website, and this is the instructions. So it says, you know, the level of authorization we have as crew member. Alien loader is whatever the name of the stupid program is. The pathways, there's nothing in here. It says Nostromo holds countless winding corridors, concealed chambers, harboring secrets. Embrace the power of this and then try to find the secrets. The role that we have as crew member, and the flag is classified. So this is literally all we get, right? This is all we get. There's nothing else that you can click on or anything like this. So what I did was I clicked on inspect, and when you click on inspect, it gives you all this information down here. And inside of the network tab, nothing shows up in this particular case. It's just a few things. And inside of the debugger, there's one little file that actually shows up, which is index.min.js. And inside of this, there's actually a bunch of JavaScript code. And so if we copy this code, and if we go, there's something called Beautify JS, I think, or Beautify JSON, let's say JS, I think, JavaScript, there you go. So right here, and then we paste this in here and we beautify the code, and this is what the code looks like. And inside of this, you see that there's a few, I mean, there's a lot of different variables, and there's a lot of different parameters. Just to zoom in on it for you, just so you can kind of see what all this looks like. It's not, I mean, it literally, unless you exactly know what you're reading, and unless you know how to read through JavaScript code, you really don't know what to look for and what to pull from this. But one of the things that we really want to try to find in this entire process is something like a very simple assignment parameter. So when you see something like this, when you see a double or a triple equal sign, that means something is being assigned. Typically, you're creating variables, or you're trying to compare variables. There's comparative operators, and then there's assignment operators. And there's something that also checks to make sure, and it's these things. It's either equal to or greater than, equal to or less than, or double equals. And it's not an assignment when it's double equals. It's a single equal is when it's assigning a variable, and double equals, or equal to and less than, equal to is greater than, is when it's starting to compare things. So one of the things that we want to find in this particular thing is the double equal signs because it gives us a little bit more data to pull from. So I think one of the things, let's see, if we go down here, this might be, hold on one second. Okay, it's a little bit easier, believe it or not, it's a little bit easier to search through the contents of that file by just creating our own file inside of nano here. So basically what I did was I came to the terminal, I did nano, and let me just zoom in for you because I've heard people really wanting to see the zoomed in version of all these things. So if we do nano, index.js is the name of the file that I created, and inside of that I pasted that entire content. So the entire contents of this piece right here, this giant line of code, because this is a really long line of code. And so I went in here, I just did Control A, so it selects everything, and I did Control C to copy it, and then I came inside of this nano file that I made, index.js, and then I pasted it in here, and then I saved it. And so now we have this, and then so what you can do is you can grep through this. So if I do, let's move this up here. If I cat through this file, cat basically displays the whole thing onto the screen. If you cat through the file and then you pipe it into a grep command, which searches through the file for the double equal sign, it gives you everything that has a double equal. And from what I've learned before is that every time you see a double equal, especially in a parameter, so in this particular case, the stuff that's inside of these quotes is one parameter. So if we copy this, and then if we go to something called CyberChef, CyberChef is this very, very useful tool, and it's not cyberchef.com. It's CyberChef is the name of the tool, but it's a GitHub repository. And in github.io, it brings this whole thing up here for you. So if I put this right here, and then if I do from base64, it'll give me the text version. So in this particular case, it's classified, which means if we go back into the browser right here, and if we look at the flag right here, it says it's classified. So that means that we actually were able to pull content from this page, from the code that's going on in the background. So if we go and search through the rest of these things, we should be able to find some kind of information that's helpful to us. So in this particular case, I'm going to go copy this one, and we're going to go to CyberChef, and we're going to paste it in here, and look at that. So we actually have a flag in this particular case. So that one is super useful. So we have a flag, so that flag should apply to one of these things. So it says, what's the flag in here? So it's not that one. So there's another one. What's this? It's this one. So the contents of the classified flag box, which is actually exactly this thing, right? So this piece right here, it's classified, and this is the flag box, and that was the content of the flag box. Now there's an actual order in here, right? So if we pay attention to this right here, it says order and then 937. So what is the order number? It's 937. Perfect. Okay, cool. So now what's the hidden flag inside the Nostromo route, and what's the name of the science officer? What is mother's secret, or where is mother's secret, and what is mother's secret? And so this is where things get a little bit interesting, because now we have to actually make requests. We have to make HTTP requests to the various API endpoints that we got. And so this is where our little tool that we got from Gemini, these little curl commands from Gemini, are going to come in fairly handy. So the first one is curl xpost, and this is for YAML, and do a directory search for the file path and then the file name YAML. So let's see what we can find, because one of them on here it already says, can you guess where it is? So there's API Nostromo mother secret.txt, and then the YAML, and so on and so forth. So now we have to try to just do a bunch of different post requests from curl, and to really just try to search through the different portions of this website through the different API endpoints to try to find that information. So now that we have, at the very least, we have some curl commands and things like that, we can try to do some work here. So I'm going to clear the screen, and we're going to try to figure out what the hell to do. So let's see. Okay, so just using the basic template that we got from Gemini is going to be this little piece right here. So it's a curl command, and we're sending a post request, and the HTTP is not going to be localhost port YAML, etc., etc. It's actually going to be the IP address that we have. So I already have it on this side right here. So I'm just going to type it in real quick. And then from there, we're going to first try to find, I guess, the specific file that's right here, which is the secret.txt. And the path for this is the API Nostromo mother. So the path for this, we're just going to do /API Nostromo mother. And then the, I guess, I wonder if I should do a / as well. I'll do /, and then the file itself is going to end up being the secret.txt. And let's see if we can get anything from this. Authentication failed. Kindly visit Nostromo and YAML route first, not necessarily in that order. And so just to give you an idea, because this actually doesn't look like that when you go to the link directly through the thing. So if I went to API Nostromo mother and then secret.txt, come on. The error message that it gives us, it just says you just hit the wrong route. So it doesn't give us anything else, which is actually very interesting because I guess in this particular case, we're not doing any kind of a post request. We're making a get request because we're just trying to pull it through our browser, and we're trying to get that information from our browser. So it's not giving us any specific kind of request. It's literally just, or it's not doing a post request, I should say. It's not doing specifically a post request, it's making a get request. So in this particular case, we have to actually make a post request. So when we did make the post request, it gave us a message and it says you got to visit Nostromo and YAML route first. So that's actually helpful. So the next thing that I would try in this case would be one of those routes. So let's try to see what we can get from that. Okay, so the first one that we're just going to try is we're going to go to the route for YAML. So I'm going to get rid of this whole thing, and we're just going to do the YAML at the very end of this. And there's not a YAML file path, so the file path actually needs to change too. So we're just going to change this to .yaml, and not a YAML file path, secret.yaml file path. Still nothing. So let's see what we can find here. We do have this little piece of information where it says uses when accessing alien loaders. So I'm going to try this. Okay, so this was the command that ended up actually getting us some kind of a result here. So modified the curl command a little bit. We changed it, or I changed it, so that we can look for this particular header. So the content type application JSON, and then the rest of it is pretty much the same. So for the directory, it's going to be the file path parameter, searching for the 100.375.yaml file. At the endpoint, that's the IP address /YAML. And then when you do this, it actually gives us a new message where it says, for science officer eyes only, special secrets, rerouting to API Nostromo order, and then this is the order number. So I believe that we need to now change our approach to reroute to the API Nostromo file, searching for the order .txt. So if we do that, so I can just modify this now, or well, let me cancel that out because it always looks super funky. So if we modify this thing now, and we go to API Nostromo as the directory, and then from there we go and look for the what was the secret file? I cleared it. It's this thing, the order.txt. So copy this thing and then go and paste that inside of our file path. And let's see if we get anything. Okay, we got another flag. So there we go. We got another flag. Wow, this is not an easy thing. So this is the hidden flag in the Nostromo route. There we go. The science officer we still got to find, and mother's secret now. Now we got to find mother's secret. I feel like it would be similar to the path that we just took right here. So let's see what else we can find. So mother's secret is actually going to be inside of the API Nostromo mother route secret.txt. So let's see what that is. So if we run the command again, API Nostromo mother, and then we're going to just go and look for the secret.txt file inside of this thing. And let me just zoom in a little bit so it's easier for you to see what's happening here. So that's the new command, and so the secret is this route. So now we want to be searching for this path. I think we're going to be looking through this particular path, and in the same, I want to say it's the same API, so it'll be the same folder, but now the file path is going to be different. So let me see. So if we do opt M0th3R mother, do that. It says sign officer eyes only. Okay, so let's see what else we can do. I think there's hold on. Making some progress. I think there's going to be some progress made. Hold on one second. I believe that what we need to do is we need to traverse this thing and go to the actual home directory. And so this is how you traverse, just so you know. When you do ... it's like doing cd ... it takes you back one directory. So if we do let's see, if we do one directory, it'll give us the same thing. So if I do another directory, I think we just need to keep traversing to see if it's going to be inside of any of the other directories. Sign officer eyes only, same thing. So I'm just going to do like all of them. I'm going to go back as many as I can. I think it's like 4 is the number that we gotta. 1, 2, and then another 2. Yeah, there you go. So it was inside of the like root. So you go back 1, 2, 3, 4. You traverse back 4 directories until you get to the home directory, and this is it. This is the secret flag right here. So this is our flag, and so we got that, and now we can go and paste this here. And then the location was opt M0th3R, like that, mother. And so now it says, what is the name of the science officer that has the permission? And it already changed it. So when you make the post request, the actual API itself changes too. So it's Ash. It changes from crew member to Ash now. So if I click down, it'll also say that my role is now Ash. So there it is. That was it. Ash was the person. And this was not, in my opinion, this was not covered inside of the last 2 videos that we did on DAST and SAST. So static application security testing and dynamic application security testing. This was just not on there. Same thing, the DevSecOps room and all that stuff. None of these things were covered in that. In those rooms, and it just required a little bit of trial and error, because a lot of the stuff that I searched for to try to find some kind of instructions for this room, they only had answers. Like nobody could give me the path to try to find the different endpoints, to try to find the different this specific file, this index.js file. This file right here, a lot of people were like, yeah, here's the file, and this is the contents of the file. I'm like, yeah, but how the hell did you find this file? Like, where did you go to find this file? Because the only thing that they gave us in the task files was just that singular file, this freaking file, this one API routes and whatever. That's the only thing that they gave us. And it was it took me a day of just clicking around trying to find, do trial and error. I did so many different, I did Nikto scans, and I did GoBuster scans, and I did Nmap scan. Like, I did so many different types of scans to try to find that freaking file, and I couldn't find them until I literally just, and it's kind of odd that it's like so simple, is that I just went and I inspected the page, and then it brings us the console down here, and then if you're on Chrome, the console is on the right side of the screen. What it brought us the console down here, and then you click on debugger, and it actually gives you this one single JS file, and inside of this JS file was that original flag that we found that was on the contents of the page, which was this particular one, which is inside of the classified flag box. So this was the one that's inside of the classified flag box. That was from that JS file, and then from that is where we found the order number, so order 937, which is this thing right here. And then from that we were able to, at the very least, establish our initial things. And then when we used Gemini to break down what this thing actually was doing, and it was saying that you need to, this is a post request inside of that original, so inside of this file right here, there's just several requests. And I mean, you are living in the age of AI, so don't feel bad about using a tool like Gemini or ChatGPT or something like that. It's not that bad. It's not that big of a deal. If you do understand Python, and if you do understand requests and the different things that we're supposed to be doing inside of this particular file, it doesn't feel that bad, because you can go in here, and it's right here. So the first one is router post. So there's a post request right here. And then you can see what it's trying to do, and it's looking inside of the public directory, and it's looking for the file path. And this one is for YAML. This is for the YAML search. So this is the post request for the YAML file. It's checking if it is a YAML file, and it's going to go through it. If it's not a YAML file path, then it gave us the error messages that we found. If it couldn't read the file, it gave us the error messages that we found. And then the next one was another one that basically was another post request that was going through the Nostromo path. So in this one, this post request went through the root. So this / the singular / means it's searching through the root folder. And then it just went through that. Then in the next one right here is actually going through the Nostromo directory. It's going through the Nostromo path and looking for similar files. And if it was some kind of an error, it would say science officer eyes only, which you already saw. If it was something that we could actually find, it would tell us, and we were able to pull that information. And then the last one was another post request that went through the Nostromo mother path, and it was doing the same thing. So kindly visit Nostromo and YAML route first. So this was the error message that we found when we did that request. And then the other one was science officer eyes only, and we were supposed to traverse it to try to find it, and it was telling us that it's going to be inside of the Nostromo path, and then we just had to keep going up. That's where the file traversal part came through, where we had to actually do the .. /.. So sending those post requests inside of our terminal using those curl commands is what ended up getting us to where it was. And I mean, I went through a lot of different iterations. I had to stop the recording multiple times to try to get through all the different iterations of these different post requests. And originally from the one that Gemini gave me to this final iteration that was searching through the header content for content type application JSON, then we searched for the file path, and then we searched through the specific endpoints themselves. And the first one that was on the YAML was for the 100.375.YAML, which was the hint that they gave us at the beginning, where they're like, if you want to enter this thing, the emergency command is this, and you want to access alien loaders, if you want to access these things, you need to search for the it doesn't tell us that you need to search for this, but this was, again, it was like one of those trial and error things that I was like, okay, let me try it. And then I tried it, and it actually gave me a little bit of extra information, which in this case was, only for special, for science officer eyes only, special, secrets, rerouting to this particular path, and then the text file right here. So then we ran that, and then from here we found the same thing. We used the first portion, which is exactly the same for the command, and then for the file path, we changed it to the order.txt that we got, order937.txt, and then we went to the API Nostromo route as it told us as the result of the last command, and then it gave us this, right? So it gave us the flag right here that was inside of the API Nostromo, and then we had to go and find the secret.txt file that was available inside of the API Nostromo mother route, and this one they also told us that it's right here. So can you guess what's inside of this thing? And so it's API Nostromo mother secret.txt, and that's the route that it gave us, which is this thing. So this is mother secret, and then, or where is mother secret is inside of this thing, and what is mother secret? We had to go and actually find it, and to be able to find it, we needed to go up 4 levels. So the secret itself was /opt/mother, but in this particular case, we had to traverse up the ladder. Like we had to keep going back one. And just to show you what that actually means, just so you can kind of see what that ... does, so you're not fully confused. So let's say I have the directory tools, and then I have another directory inside of tools that is, the word lists. And this is what I was using to use GoBuster to try to enumerate the directories and try to find files, which it didn't work for me, but we went over there, and then there was inside of this, there was the dirbuster. So this is now the full path, right? This is the path that I'm in. And so I have now gone up 3 levels, or gone down 3 levels, however you want to look at it. Now, for me to go back to the root directory, which is this thing right here, this piece that you see, this little squiggly line, that means I'm in my root directory. So for me to go back to my root directory, I would have to do cd ... and that takes me back 1 level. And then I do cd ... again, it takes me back another level, and then ... again, and it takes me back another level. And this, you don't know that this is what you have to do. This is what you do when you just do trial and error, and you go through different iterations. The iterations word is what you'll find a lot. And when you're doing pen testing and things like that, you have to traverse directories. You'll hear that a lot as well. That's a specific strategy where you just use that mechanism, .. You'll use that so you can go back and forth inside of a web server to try to find what's inside of each one of these directories, and eventually, hopefully, you'll find what you're looking for. And so that's what we had to go through to find the information for all of these answers. And sure enough, with enough trial and error, we found it. So that is it for the mother's secret room, this mother effort. So hopefully you found the information in this video useful, and hopefully it made your life a little bit easier as you're trying to learn what to do for this particular room. If you found this video useful and if it made your life a little bit easier, I want you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. Our community has been growing, and I would love to see you in the comment section. We do get a lot of comments coming in all the time from people that have learned stuff from the videos, to people just saying that they're grateful or asking questions and things like that. So it's been really nice to see the community growing as much as possible. And look, literally the word iteration, I told you that it comes up a lot, a fun iteration. So this thing comes up a lot, and an iteration means just another version or another attempt at something with making a minor tweak and something like that. So very, very nice to see all the people in the comments, and I would love to see you in the comments as well. So make sure you like, subscribe, and turn on that notification bell, and definitely drop a comment to say hi, to ask a question, and so on and so forth. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I will see you in the next room. Later. Today we are solving the traverse challenge that is inside of the software security engineer pathway of TryHackMe, and this has barely any instruction, so we're pretty much left to our own vices to try to figure this whole thing out. And it should be a pretty exciting room, I would say. It should be fairly informative in a sense that we're going to literally, we have to just do whatever we can to try to find these answers along this path. So I've already started the virtual machine that they've given us. I've already started the attack box that they've given us. So without further ado, let's jump into the little kind of synopsis for this room, and then we're gonna literally jump into all the questions and the exercises. All right, so here is the scenario. Bob is a security engineer at a firm and works closely with the software DevOps team to develop a tourism web app. Once the website was moved from the quality assurance to production, the team noticed that the website was getting hacked daily and wanted to know the exact reason. Bob consulted the blue team as well, but has yet to be successful. Therefore, he finally enrolled in the software security pathway at TryHackMe to learn if he was doing something wrong. We've already developed the machine, and we have gotten that. So let's see what some of these questions are like. So it says, what type of encoding is used by the hackers to obfuscate the JavaScript file? What is the flag value after de-obfuscating the file? Logging is an important aspect. What is the name of the file containing the email dumps? The logs folder contains email logs and has a message for the software team lead. What is the name of the directory that Bob has created? What is the key file for opening the directory that Bob has created for Mark? What is the email address for ID 5? What is the ID for the user with admin privileges? What's the endpoint for logging in as admin? Mention the last endpoint instead of the URL. For example, if the answer is this, then just write /admin. The attacker uploaded a web shell and renamed a file used for managing the server. Can you find the name of the web shell that the attacker has uploaded? What is the name of the file renamed by the attacker for managing the web server? And can you use the file manager to restore the original website by removing the finally hacked message? What is the flag value after restoring the website? So that is what we got. So I'm guessing this is our website. So let's go and check it out and see what that website actually looks like. Okay, so this is the website. Finally hacked. I hate minified JavaScript. And that's basically all we got. So clearly it's been hacked. If we inspect the page, let's see if we can find anything behind the scenes real quick before we do some deep dives into this stuff. Okay, so straight from the get, I opened all of these things. So they were all closed like this. So I opened all of these things and literally opened every single one so that I could kind of see what's inside of everything. From the very beginning, we see that there are two JS files. There's tailwind.min.js and then custom.min.js. So those could be the two potential JavaScript files. And then when we come down to the body portion, and then we go inside of the UL section of that, there's a couple of notes here that it says /logs DevOps team to check and remove later on. So these are comments that they've left right here, and /img. And again, please keep all images in this folder. These are just comments that they've left for us. So those could be potentially interesting sections for us to look at. And then what else do we got? This is the content of the page on the main section, and then we have the footer, which says the same exact thing. So there's really pretty much nothing else inside of the source code of this page, with the exception of these two comments right here that could be a little bit of interest to us. And then we have these two JS files. So if I try to open this, let me see if I can open this thing. So in case you're having trouble clicking on something like this, because sometimes that happens, if you just click on right click on the screen again and then click on view page source, it'll open up a new tab for you where it actually shows you everything like what we just saw without you having to open any, like click those buttons to actually open the code, and it shows you exactly the same thing. So it literally just shows the same exact stuff that we just saw, except now I should be able to click on this. And so I can click on it, and this is it. So I will keep the obfuscated so no one can understand. And this looks like hexadecimal. So if we go to, let's see if I can highlight this whole portion here. And I'm going to copy this whole portion, and let's see if we go to CyberChef, if we can find anything inside of CyberChef. So if we do the input right here, and then from hex, if I just drop this here, This is what we see over here. So this is the actual content of the hexadecimal stuff. And it has confirmed for us that it is actually hexadecimal because it gave us some kind of output when we went from hex. So it seems, let's see, this actually, I think this might be something for us. So if we go and do, I think, what is it, Beautify.js? Or is that what it is, Beautify.js? I wonder if that's what this is going to look like. So do this. Yeah, there we go. Okay, cool. So we have this, and then so there's interesting, there's stuff right here. These are all variables, right? So variable n equals e equals so on and so forth. So directory listing is the only way. And then the script right here, itself gives us if f equals null, console log flag. So this is flag. So this is actually us trying to find a flag. You know how we were supposed to find a flag? So there's a flag in here, and it says n plus space e plus space o plus space I. So n plus e plus o plus I, all separated with spaces. These empty quotes that you see right here, these are just spaces. So it's saying flag is directory listing is the only way. So I think that's our flag. And we have the fact that this thing was hexadecimal. So we have a couple of solutions here. So let's go into here. So it says what type of encoding is used by this, and hexadecimal is the right answer. And so what was it? It said directory listing is the only way. So that might be the flag itself. So directory listing is the only way. There we go. All right, cool. So now logging is an important aspect. What is the name of the file containing all the email dumps? All right, if you remember, we actually had a little thing that told us, so where is it? Let me go back right here. So it told us that we have a logs directory. So if they're saying logging is the best thing, so if we go to the website itself and just go to /logs, we have a couple of logs, or well, one log. We have one log here, and it is the email dump. So email dump.txt is the name of the log. So I'm going to copy this, and let's see if that's the answer here. That is. Okay, cool. Now the log folder contains email logs and has a message for the software team lead. What is the name of the directory that Bob has created? So now we have to enumerate the directories just so we can see what we can find. And what is the key file for opening the directory that Bob has created for Mark? So this is the key right here. We can actually see it. It's right on the page. So it says the page is password protected and cannot be only opened through the key. And this is the key. So that's the key. And we're supposed to find an enumerator. So let me first drop in this key. Yeah, okay, so that's all good. So now the thing that we got to do is we got to enumerate this specific IP address so that we can see, hopefully we can try to find what all of the directories are. So the way that we're going to do that is we're going to use GoBuster, and the GoBuster requires that we use a dictionary for the words to search for it, essentially. And so that's going to be inside of word lists, and then I'm gonna ls this, and then let's see what we can find here. So there we go, GoBuster ls, and okay, so these are all of our word lists. There's actually, I think there's another set of lists that's inside of sec lists. So if I go back, let's see what else we can find. So if I do cd seclist, and seclist is something that you can find on GitHub. So if you actually do a Google search for seclists, you'll be able to find that stuff, that entire, it's like a giant file inside of GitHub, and then you can download that, and it'll have all these different things for you. So there will be password lists and payload lists, web shell lists, username lists, and under discovery is, I think, where we can find our directory lists. So we have, let's see, DNS infrastructure, mainframe, SNMP. I think it'll be DNS. And let's see, subdomains and stuff like that. So maybe not DNS. Let me see. I'm gonna look around a little bit real quick. So we got the big directory list. We have a medium and a small directory list. Inside of the regular word list for Dirbuster, it only goes up to medium, so there is no big directory list. So I wonder, I mean, I'm gonna try the medium one because I'm pretty sure if I try the big list, then it'll take a long time. So I'm just going to try the medium list first, and then from the medium list, we'll see if we can find any useful directories that we can potentially use here, and we'll just take it from there. So we are now back in our root directory, and I have the path for that specific list. So now we can use GoBuster. So we're going to do GoBuster. We're going to do a dir search, which is for directories, and the URL is going to be the URL for our IP address right here, which is the 10.10.171.78. And then word list is going to be, okay, there we go. That actually started working, and we immediately have some results that we can look at. So we have the IMG directory, which was inside the notes. We have the logs directory, which was also inside the notes. Then we have JavaScript API client planning, PHP my admin, and server status. So it could be any of these really. Let's see. So we can try. I'm just going to go through all of them to see which one the potential directory might be. That would be our answer here. So let's see what we can find. Okay, so the first guess was actually the right guess. So it's planning. So planning is the directory that was the log folder contains email logs and it has a message. What is the name of the directory that Bob has created? It's the planning directory, and this is the key that Bob created for Mark. So what's the email address for ID number 5? So I think we can now use that key to log in as Mark. So if we go to planning, so let's go to the directory /planning, and let's see what we can find here. Okay, so it's literally just a password requirement, and I'm pretty sure this is the key. So we're gonna go here and we're gonna paste that in here, and there we go. So we're here. So there we go. This is the API sample here. So the endpoint is API customer ID 1, and it's a get method, and IDs for the customer. And so if you wanted to do a curl command, essentially that's what it would be like. And this is what it would give us. This is what it would give you as your result. So if I just do this inside of the browser, I think I should be able to actually get something. So let's try this. Let's actually go inside of our browser, and we're just going to paste that API at the end of this customer ID 1. Okay, nothing was found. So I think I might need to actually make a GET request then. Instead of trying it in the browser, I think I might need to make a GET request. Let's see. Oh no, you know what? There was a space right there. So without a space, there you go. Okay, so that's my bad. So I can actually do this inside the browser, and it was just because I had a space between this / and the API word. So for ID 2, we have Bob at Traverse, his password, his role, his URL, and etc. etc. So the question here is, what is the email address for ID 5? So let's go and look at ID 5, and this is it. So this is the email address for ID 5, john@traverse.com. So that would be the email address for ID 5. Very good. And what is the ID for the user with admin privileges? So if we start from the top, so if we go to ID 1, Alice is also a role, is a user, and their URL is the client. And we already saw ID 2. So ID 3 is admin. ID 3 is admin, real admin at traverse.com. Admin password is right there. and their URL is /real admin, and their ID is 3. So this is the third ID. Very good. And then so it says, what's the endpoint for login as admin? And it's right here, is /real admin. So there's their endpoint. And so now it says the attacker uploaded a web shell and renamed the file used for managing the server. Can you find the name of the web shell that the attacker has uploaded? So let's log in as real admin, and this is their password, which is admin key. I'm just gonna open up a new, actually I'll just go back right here. So we'll go back to this browser right here and we'll do real admin. And there we go. And so, whoops, their email address is this, so realadmin@traverse.com, and then we have their admin key. So let's see, realadmin@traverse.com, and then we can paste. Oh, that seems too long for their password. I keep clicking that thinking I'm inside this thing. So this would be their password. So copy that. And there you go. Okay, so we are now here. So welcome to the admin page, OS version, etc. Logged in users, Ubuntu. You can also execute commands using the drop down button. So system owner, current directory, etc. And is that it? That's all we could do. So if I execute this, that's the system owner. If I do current directory, it's going to be ls command, and it's going to give me that. So I think these are the only two that I can create. So we have to now traverse, essentially we have to go inside of that directory and find the file. Basically, because of the fact that we can't create our own commands here, the only thing that I can think of is using Burp Suite to forward the request, and then from there modify the commands that would go in here. So for example, when you do current directory, that's essentially doing PWD, like print working directory. It doesn't show anything over here, so nothing is being typed inside the URL for us to find anything. And so it's being done in the background. And so we need to be able to pull the stuff that's happening in the background. So for example, if I go to debugger or network, for example, and if we refresh the page, it should reload something and it should actually show us what is being submitted. And we still see nothing in the actual contents of this that shows us what the command is that's being submitted or anything like that. So we literally have to go ahead and create that ourselves. And the only way that we can do that, as far as the only way that I know anyway, is to use Burp Suite, because Burp Suite allows you to intercept traffic or intercept a request. It allows you to intercept a request, and then you can modify the request with your own command. So I'll just show you. It's easier to show you than to try to explain it. So let's do that. I'm going to fire up Burp Suite real quick, and then we're going to intercept this traffic, and then we're going to go ahead and capture it, the whole thing. So let's try that. All right, so the first thing that we're going to do is we're going to turn on Foxy Proxy so it can actually enable Burp Suite on port 8080, which is our web browser port. And then in this case, I think I should be able to just open it right here. So that is Burp Suite. So we can just open it up real quick. And then once you have that, you turn on intercept on the proxy. And I'll just show you what that looks like. And then we intercept the request. So it's pretty simple. Like once you actually understand it, it's pretty simple. And then I've done several videos on Burp Suite. So if you've never used Burp Suite, you can just go to the channel and you can search through the channel like so. And then you just do Burp Suite as the search. And then you just get a bunch of stuff, a bunch of videos that comes through having used Burp Suite. So it's really, really useful tool. I think it's actually, you got to do it as one word, I think. Well, either way, it shows up, it brings up a bunch of stuff that you can search for to actually find Burp Suite, and then just watch it. If you've never actually used Burp Suite before, I would recommend that you go through it so you can see what it's like. So now that we have Burp Suite open, we're going to go to the proxy tab right here. Intercept is already on, so I don't need to turn that on or anyway. I usually like turning it off and then just turning it back on. And then when you do this, now it's actually capturing everything that's going on inside of the browser that it's connected to. And to connect Burp Suite to a browser and do that entire setup, you go watch the videos on Burp Suite. I'm not going to do that right now. But assuming that your Burp Suite is connected to your browser through your proxy, Foxy proxy or anything like that, you can now intercept the traffic. So if I go here and if I do a reload of this, it says, do you want to resend this? And I do. And now we got a little notification on Burp Suite. And then if you notice, the website itself, it's now hanging. This is what they call, I think it's called hanging. I don't know what it is, but it doesn't fully load the command. It just kind of stuck on loading. And the reason for that is because Burp Suite has now captured that traffic. Look, it's captured that traffic, right? And then the command, remember, so print working directory is the command that you send if you want to see what the current working directory is. And that was the last command that we wanted to send. So we can now see that the command that's actually being sent is print working directory. So what we want to do now is we want to modify this, and then we want to send our own command inside of Burp Suite, and we want to forward our own command so we can see what happens on the other side. So the first thing that we want to do is we want to forward this request. So what I'm just going to do is I'm going to click on forward, and then it's going to forward the request, and then it's going to do the print working directory, and the thing is completed. But now if I go back inside of this, I should be able to go into my HTTP history, and I should see the request that we just forwarded. So the post request through real admin, and then you can see that it was the command print working directory, and then the response was as such. And then inside of that response, let's see if we can find the current working directory that we got, because it should give us the actual response, right? So there we go. This is the response that we got. So this was the print working directory response. So this is what it looks like when you actually forward a request without modifying the command itself. All right, so another neat thing about Burp Suite is that we can repeat certain requests. So since I have this one request that has a status code of 200, which was done successfully, I can right click on this and I can send it to the repeater. And now the repeater tab at the top has been highlighted. And so if we go here, now we have this entire request right here. So now what I can do is I can modify the command inside of this thing, and then I can send it, and hopefully I'll get another response back. So for example, if we change it to ls, which is list, right? So print working directory prints the current directory. The one that was a system command, it was telling us who the system is. So we got the username essentially of the system. So now if I do ls, and if I click send at this moment, it should give us a new response, and it should show us what the specific contents of the directory are. So it came back with a 200 response, which means it actually went through okay. And so let's see what the actual contents of this particular directory are, the directory that we're in. So we go down to where we were, boom, okay, here we go. So password for accessing the original file manager is this. And then we have index.php, main.php, renamed file manager PHP, and then the shell PHP. So these are the various contents of the directory that we're in. So I think this is one of the questions, right? So the attacker uploaded a web shell and renamed a file used for managing the server. Can you find the name of the web shell that the attacker has uploaded. So let's see. Okay, so just from the contents of this, we can see that there's something called the shell right here. So that's, I would say that that's the actual name of the web shell. So if we do thm shell php, that's the actual file. Okay, great. And what's the name of the file that was renamed by the attacker, which is obviously the renamed file manager, etc. So we're just going to copy this thing, and we're going to go back and paste that here. So that'll be the file. And so finally, can you use the file manager to restore the original website by removing the finally hacked message? What is the flag value after restoring the main website? So this is the part that I think it's going to be a little bit confusing. So let me see. I got to be able to, I need to find a way to actually use this thing and see if we can actually make it work. So I'm going to copy this one more time. I'm going to see if I can load it on our browser here. And if we can, awesome. If not, I might need to create some kind of a listener, like a netcat listener, and go and paste or connect to this specific browser, or not browser, the web server, through the netcat listener, and see if there's a way that we can actually make this happen. Oh, I need to turn off intercept. So let me turn this off. Intercept is off. Admin file manager. So username admin, password. The password was right there too. So we might be able to just use the password that's inside of this thing without creating our netcat listener. So let's see. So THM right here, right? So password for accessing original file manager. So if we do this, let's see if this actually works without us needing to create some kind of a reverse shell. That would be great. Okay, so we are inside of the file manager. Not bad. Okay, this might be easier than creating the reverse shell, but okay, we'll see. We'll see how it goes. So these are the various files that we got here. So we got Tailwind, min, the index, header, footer, the real admin directory. So inside of the real admin directory were our renamed file manager, as well as the index PHP, main PHP, so on and so forth. And so the question is asking us what? So can you, to restore the original website by removing the finally hacked message, what is the value? So I think the finally hacked message, I think it's going to be on the index file, because the index file is typically the file that shows up as the home page of a website. So index is the home page of a website typically. So let's actually try that. So if I just went and did index.php, yeah, so this is the actual home page of the website. So this is the file that we probably need to modify, and this is the file that has been messed with. So if I just download this file right here, there's a little download button. So if I download this file, I'm going to download it, and that's going to be our thing. So what we need to do is, can I upload a file as well? I just need to make sure, yeah, I can upload a file. So there we go, we have an upload button. So essentially what I got to do is I got to remove this, because this is the malicious page right here. So remove this, and then from here we can modify the contents of it to make it whole, so it doesn't actually show up this message, and then hopefully the rest of it will be fine. So let's go and look at the actual file itself. So it should be inside of our directory right here. There we go, index.php. It's already here. So let's see what's inside of this thing, nano-index.php. And here is the file. And I'm going to kind of make this a little bit bigger so it's easier to look at. And what do we got? We got the start of this whole thing. So let's see if we can find that message that messed up message that shows, you know, hacked finally, whatever, whatever. Okay, so this is not the index file that we need to look at based on what I'm seeing here. I think that's actually the wrong index file, and so I'm just going to delete it real quick. There we go. And let's go back to our browser, and in the file manager, let's go back. Okay, this is the one. I think it's this file actually. Yeah, because this is the, yes, because this is the home page. Yes, yes, yes. Okay, this makes sense. Because this is the home page, and it's not the one that's inside of the real admin. So this is, so just so you understand, if I go to index.php, this is the one that's on the root directory, right? So the file that we were just downloading, that's on real admin. So when I click on real admin and I go inside of the real admin, that means I literally did this. I went inside of the real admin directory like that, and I was looking at this file. And if we do that, then it's not, yeah, I mean, it's empty. So there's nothing in here. So this is actually not the file. And so what we want to look at is the main file that is on the home page in the root directory, which is the one that's right here actually. So it's this file. That's the one that I gotta look at. So this is the one that I'm gonna download, and then we're going to go look at that specific file. I think, yeah. So that one should actually show us the contents. There we go. So let's do nano index.php, and this should, there we go. Now you see it right there on the screen. Finally hacked, and the message itself is finally hacked. All right, so now I gotta modify this freaking thing to make it like the good one. So let's see what this is supposed to actually look like. Okay, so I am actually not that great on PHP code, but I understand what's happening here. So this is the message variable, and the message variable is finally hacked, right? And so the content of this thing says that if the message is not, so this thing right here, when you see a exclamation equal sign, that means not. So if the message variable is not finally hacked, then you can print onto the screen that you successfully restored the website, and that's the flag. I mean, so this is literally the flag right here. So we could just copy paste this from this right here, but instead of doing that, let's actually try to fix this, right? So what I'm going to do is I'm just going to change the message, because it could literally be anything, right? So finally hacked, finally not hacked, or not hacked, whatever. Like this message could be anything, as long as it doesn't say specifically finally hacked, right? Because that's what this if statement right here is checking for us. So it's saying if the message variable is not finally hacked, which could be anything, that means that you can print the successfully restored. So I'm just going to change this. I'm going to change the message variable to finally, I guess not hacked, whatever. So we'll do finally not hacked. There we go. Now this is not this. Does that make sense? That's basically it. That's all we got to do. So I'm going to now save this file, and we're going to close it out. And so let's just make sure that that's actually the saved file. Okay, there we go. It still says finally not hacked, so we are good with that. So now we have an updated index.php file. So what we're going to do is we're going to delete this one, and we're going to replace this one, because this is the malicious one that we just downloaded. So I'm going to click on this. I'm going to delete it, and it says, are you sure you want to do that? Yes, I'm sure I want to do that. And then I'm going to click on upload, and then I'm going to drag a file from my root, which is index.php, and I'm going to open this mofo, and it is now uploaded, and it says it's successfully uploaded. So I think we should be okay. So let's go here and let's see. Yeah, we do have an index.php. So now once I reload this, here's the moment of truth. Let's turn off Burp Suite. This is the moment of truth. We reload this and we should get a success message. Look at that, successfully restored, website flag, yada, yada, yada. So that is golden. I hope you caught that. I mean, I think that was actually pretty basic. So you should have caught what we just did right now. And there's our flag, and look at that, we established success here. And I am zoomed out again. God, I hate when this happens. But there we go, we got it. We actually got our success message. So I'm very, very happy about this, and hopefully you understood what we just did. If not, I'm just going to do a quick review of everything that we just did so you understand what we just did. All right, so here is the review. Okay, so the first thing that we did was we needed to find the original website. Obviously, we went to the original website and we looked at the contents that were on the page. And there was a specific file that we needed to find, which was that JavaScript file. So let me see if I can actually reload this thing. And let's just see if we can still see it. So if I do click on view page source, there we go. So all we did was we just looked at view page source, and it says this is the custom.js file. This is the official file. Don't change this. And then we clicked on the custom.js file, and it gave us the contents of it. And it says, I will keep the obfuscated so no one can understand. So this is what type of encoding was the original JavaScript file. And just based on what I've seen before, I know that this is hexadecimal. But if you just go ahead and copy this and then go to CyberChef, which is exactly what we did, and we went to CyberChef and then I pasted it in here. And I think you can also even just double click sometimes, or do smart, let me see, there's some kind of magic. Magic is the specific one. So magic kind of tries to auto detect what the thing is, and it gives you a specific recipe. For example, in this case, it's from hex. And so it detected what this was, and then it went and gave you the response for it. So you can tell that this is a hexadecimal type of encoding. So if you didn't know what this was, I had my I had my recording thing set up, or not recording, the talk to text or whatever. So if you didn't know what that was, and I mean in this case it's been completely replaced by this, then you could just use the magic specific recipe and it would tell you what type of encoding it was. Anyways, so we found out that it is a hexadecimal encoding. And then when you look at the value of the file, which is exactly what we did. So we took the value from that hexadecimal decoding, and then we came to a beautifier.io, which just beautifies JavaScript, or I think it can detect a lot of different types of code and beautify the code, which essentially means that it just makes it easier for you to analyze and look at. When we look at this, we see that there's multiple variables here. So there's a function inside of a function, and this particular function is do nothing, whatever. But there's multiple variables here, and variable NEOIF, right? You have these variables, and then there's a command, an if statement right here that says flag. So this is a string, which means anything that's inside of a quote, essentially, and you see this right here, anything inside of a quote, these are strings. So when you see this inside of this, you can just assume that that's basically what is going to print onto the page. For example, this code does nothing, right? So when you see something like this, that's just a string. So we know that this is the flag, this is where it starts, and now it's including the n variable. So this string plus the n variable plus an empty space. So we have the quotations, and inside of the quotations is just a space. And then this variable plus another empty space, and then this variable plus another empty space, and then this variable. So when you just add all of these variables together and separate them with empty spaces, you would get the result of this particular question, which is directory listing is the only way. Then we get logging is an important aspect. What's the name of the file containing the email dumps? And that was also inside of our source code right here. So if we go back to the source code of this page, we saw that there's a section right here, another comment that gives us a /logs. But then that was also something that we found when we went and did the dirbuster. When I did GoBuster and I used the directory right here. When we did directory enumeration using GoBuster, we also saw that there was another directory right here called logs. So You could have found it either by using GoBuster and just enumerating all the directories, which we had to do anyways because we needed to find this directory or this specific path. But that in our particular case, it was also included inside of the source code of the web page. So when we went there, we saw that there is something called the email dump.txt file, and then we opened the email dump.txt file, and it was an email from who? I think it was from Bob. There was an email from Bob to Mark, and inside of this file we found this key. And then we went to this path because that was the path that we found from here. And then when we went to that path, we saw that it literally just asked for the key, and we got the key, and then we were able to enter the API endpoint. So let's go and review that one more time just so you can kind of see what that's like. So the API endpoint in our particular case was the /planning. And I don't know if it's still logged in. Maybe it logged us out, but let's see. Okay, please enter the password one more time. So copy that, paste that, or paste that. There we go. Okay, let's try that one more time. There we go. So this is the API endpoint instructions, which essentially says that if you go to this endpoint, and this is a sample endpoint, then you'll see these types of responses, this type of result, which, you know, this is the data, and this is JSON format. So this is the data, the ID, name, email, password, timestamp, role of the person, the login URL, and whether or not they are admin. And so if we go to that endpoint now, we should be able to see the first user, which in this case is Alice. And then Alice at Traverse, this is her password. There, the type of user is admin is set to 0, which means it's no, so she's not an admin. So that is the specific API endpoint that we can query to see the rest of these questions. So it says, what's the email address for ID number 5? And then so we just changed the ID right here to ID 5, and we got the email address for, who was it? It was John. So John at traverse.com, and that was it. And then what's the ID for the user with the admin privileges? So for that one, I just literally just went through each individual user one by one, and then we ended up at user number 3, which was admin. And you see how there is admin is set to 1. That means they are an admin. So there we go. Let's make sure that this is all good, and I just zoomed the hell out of that, so that's super weird. Let's kind of zoom back in with this. So there we go, we got that information, and then what is their path to log in, and this was the real admin path for them to log in. And then we went to the real admin path, and then we were able to get into the actual file manager, which is this specific page right here. And this is the root directory of the file manager, because inside of the root directory, we can see that the other directories, so these are, I don't know if you noticed, but these are actually all of the directories that showed up when we did our GoBuster attack, not attack, but our GoBuster enumerator, right? So if we just kind of move this to the side, you can see that actually these are literally all the same directories. So IMG, client, API, JavaScript, etc., etc. So these are all the different directories that showed up as we went through the root directory of this URL. So that means this is literally our root directory. And so on the root directory, there are several files that are of note to us, or there are several. One of them is a file, another one is a directory. The directory that's of note to us is the real admin directory. And so if we go inside of this, now we see these various files. And inside of that, there was a web shell that was renamed for managing the server. And that was the THM shell, which is this thing right here. And then we have the one that's renamed file manager. And this is the renamed file manager that we found. And then finally, it was getting the final flag that's inside of our root domain, which is this thing. So this was the final piece where we downloaded this, which is the index.php, because every website that you go to, the home page is the index page. So it could be index.html, index.php, anything like that. But index page of any website is going to be the home page. So we knew that if we land on the home page, the index.php is going to load, and it would show us, originally the message that it showed us was, you know, it was finally hacked or something like that. And so what I did was I just downloaded this and I modified the code of that to show finally not hacked, which was basically all we had to do, because it was a very simple script that was inside of that. So if we go look at that one more time, this is basically it. And this is all they needed, because the if statement right here, the loop right here says if the message variable, which is this thing, if the message variable is not finally hacked, then print onto the screen our flag. And in our particular case, this was the flag. And so all I had to do was just change this variable from finally hacked to finally not hacked. Or it could have been anything. It could be finally free or whatever. Literally anything that doesn't read this. As long as it doesn't say that specifically, then you should be all good. And I think even if this was like lowercase, so if I think that could have even worked too. But in either case, as long as the message variable does not read, is not finally hacked, then it would print the success message for us, which it did, and we got our final flag. So that was it. That was all we had to do for the Traverse lab inside of TryHackMe, which is very exciting, and I'm super happy that we were able to accomplish it. So hopefully you learned something from this as well. I don't know why I only got 56 points. When all these other people got so many other points, because I got all the answers right. So this part is very annoying to me. I'm so upset that I only got, or not 56, I guess. No, there we go. Yeah, my final points is 88. But whoever this person is right here, they got 196 points. I don't understand why they got 196. Maybe it's because they completed it twice or something. I don't know. But I want to know why they got 196 and everybody else is only capped at 88 points. I am so upset at this. I want to make sure that I also get all the points because I got all the answers. What the hell? Anyways, that was it. That was it for the Traverse Challenge on TryHackMe. If you found this video useful, please go ahead and like, subscribe, turn on the notification bell, do all that good stuff, and join our community. We are having a lovely, lovely growth in our community, and it would be lovely to see you inside of the comment section as well. And this is what is happening. This is a very, very active comment section, and there's a lot of people coming through, and I respond to every single person. And if you have a question, I will respond to your question too. If you just want to say hi, I'll say hi back to you, so on and so forth. This was hilarious. That came yesterday. It goes, love you, bro, no Diddy. If you know what's going on with the Diddy fiasco. So yeah, man, I would love to see you inside of the comment section. I'd love to see you as a part of our community. And it would be really nice to just have the community keep growing, because this has been, it's been very humbling for me, but I think a lot of people are also finding value from it. So make sure that you like, subscribe, turn on the notification bell, and of course, drop a comment just to say hi. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. And we did the Traverse video today inside of TryHackMe. This was the Traverse Challenge. So if no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video. Peace.